Good morning, my dear students. Today, let us discuss another concept in the current electricity. That concept is effect of effect of temperature on resistance. Means on increasing the temperature, how the resistance of a material changes. Let us discuss today, and along with that some Kirchhoff voltage rule and Kirchhoff current rule, and along with that cells and EMF concept. Today let us discuss. Now, so for example, if you take, this is one of the conductors and this is the conductor. The initial temperature I am taking the T1 degree Celsius, and at this temperature the resistance is R1. When the temperature increases to T1 degrees Celsius to T2 degrees Celsius, now the resistance becomes R2. Now, here practically we can observe that for small change in temperature, so the final resistance of any material is directly proportional to initial resistance of the material and also change in temperature delta T. So, when the temperature at T1 degrees Celsius, the resistance is R1, and when you increase the temperature to T2 degrees Celsius, the resistance becomes R2. Now, we have to find out R2 value. Therefore, now what? So, R2 is directly proportional to R1 into delta T. That means what? The final temperature of the given material is directly proportional to the initial resistance, and so directly proportional to the change in temperature. On removing this proportionality, we are getting one constant, that constant is alpha into R1, that is into delta T. So, here this alpha is the proportionality symbol, and this alpha is called as the coefficient of resistance. Therefore, now the final resistance R2 is given by alpha into, so now what? So, alpha into, so R1, so now what? They are change in resistance, the change in resistance delta R. So, the change in resistance delta R is directly proportional to, so our initial resistance and the final temperature. Sorry for the mistake here. The change in resistance of any material is directly proportional to initial resistance and change in temperature. Delta R is equal to alpha into R1 into delta T, and so this delta R is equal to alpha R1 into delta T, and delta R is given by, so R2 minus R1 is equal to alpha into R1, so into delta T. Therefore, the final resistance is given by R2 is equal to, so R1, if you take R1 plus alpha into R1, so delta T. If you take the common R1, therefore final resistance is given by R1 into 1 plus alpha delta T. This delta T you can write at T2 minus T1, and once again you listen, sorry for this small mistake. Now, here what I am taking, that this is one of the conductors. At temperature T1 degrees Celsius, the resistance is R1. At T2 degrees Celsius, the resistance is R2. Means when the temperature increases from T1 degrees Celsius to T2 degrees Celsius, the resistance is what? R2 we have taken. Now, the change in resistance of the given conductor or given material is directly proportional to the initial resistance and directly proportional to the change in temperature. So, by solving, so we are getting that the final resistance of the, so the final resistance of the given metal is equal to, so R2 is equal to R1 into 1 plus alpha into delta T. This delta T you can write change in temperature delta T is equal to T2 minus T1. So, this is the final, so this is the first formula in the discussion. Therefore, this is the final resistance. And here what is the alpha? Alpha is called as coefficient of resistance. This alpha can be defined as, so this alpha can be defined as, so now what I am taking that, so R2 minus R1 is equal to alpha into R1 delta T, because the change in resistance is directly proportional to R1 and directly proportional to change in temperature. From this alpha is equal, what you can say, delta R by, so R1 into delta T. So, delta alpha is equal to, you can say, delta R by R1 by, so delta T. Therefore, now this is the alpha formula. How can you define? So, the change in resistance by original resistance or the change in resistance by initial resistance is called fractional change in resistance. Therefore, fractional change in resistance of a material per unit rise in temperature is called as coefficient of resistance, temperature coefficient of resistance. Therefore, now the unit of this one is what? Now the unit of this one is so per degree Celsius. Therefore, per degree Celsius is the unit of the temperature, what is that? Alpha value, and this alpha value is different for different material. For the copper it is different, and for the zinc it is different, for aluminum and for the different types of the materials existed. So in that alpha value is different completely. Therefore, now here what you can say again, so now here alpha is equal to, you can say, so R2 minus R1 by, so R1 into, so T2 minus T1, so also you can write. Therefore, this is one more expression. Therefore, this delta R you write as R2 minus R1, so by R1 into T2 minus T1. And here, for example, for metals, for conductors, alpha is equal to positive. For conductors, alpha is equal to positive means what? R2 greater than R1. That means what? For any given conductor, when you increase the temperature, resistance increases. When the resistance increases, then we can say R2 greater than R1. So when R2 greater than R1, therefore now alpha is equal to positive. Therefore now what? On increasing the temperature, so what you can say, now for that resistance of the conductor increases for only conductors. And for the semiconductors, alpha is equal to negative. Means what? For insulators and for the semiconductors, alpha is equal to negative. Alpha is equal to, when you look at the alpha is negative, so when R2 value is less than R1 value, this separation becomes negative. That means what? On increasing the temperature for the semiconductors and insulator, so the resistance is going to be decreases. Therefore, for the semiconductor, on increasing the temperature, the resistance is going to be decreases. And for the alloys, right now, for alloys, what you can say now? For alloys, alpha is almost all equal to 0. Not exactly, but alpha is exactly, not exactly, alpha is equal to, nearly equal to 0. That means what? On increasing the temperature, the resistance of the alloys like constant and so magneton, so therefore all those are used in the construction of the meter bridge wire. So for the constant and mangan and all these are, alpha is equal to 0. Why? Because even though on increasing the temperature, there is a very slight change in the resistance is there. Therefore now what? R2 minus R1 is almost equal to 0. Therefore alpha is equal to 0 for the alloys, we can say that. Okay. Therefore this is a small point, small story in this so effect of temperature on the resistance. So for the conductors, for the semiconductor, for the alloys, and this is the formula. So to find out the coefficient of resistance, and this is the final resistance formula we can find out. Now let us discuss one question based on this, one numerical based on this. Now for a material at temperature T1 is equal to 0 degrees Celsius, the resistance is given by R1 is equal to 100 ohm meter. For the given material at the temperature 0 degrees Celsius, so resistance of the metal is equal to 100 ohm, and at temperature T2 is equal to 100 degrees Celsius, what is the resistance? R2 is equal to how much? For this one, the alpha is equal to 0.04 degrees Celsius they have given. So this is the question. So what they have question is for a given material at temperature 0 degrees Celsius, the resistance is equal to 100 ohm. At the temperature T2 means when the temperature increases from 0 to 100 degrees Celsius, now what is the resistance? For that they have given, so alpha is equal to 0.04, so 0.004 degrees Celsius. Therefore now, so what I am saying that, so formula what R2 is equal to, from this expression you can say, so R2 is equal to R1 into 1 plus alpha into T2 minus T1. All values you substitute here, you can get the answer. Therefore now R2 is equal to what? R2 is equal to R1. R1 value how much? R1 is equal to, they have given, so that is 100 degrees, 100 ohms. Therefore 1 is only alpha value, so 0.004 into T2 minus T1. 100 minus 0, because the second temperature so increases to 100 degrees Celsius, and so if you simplify you can get what, this is the 100, so 1 plus so 100 into 0.004 means what, you can get that is equal to 0.4. Therefore, after simplification the final resistance of the given material is R2 is equal to, that is equal to 100 into, so 1 plus 0.4, 1.4, therefore R2 is equal to 140 ohm nana. Therefore, this is the final resistance of the material when its temperature increases from 0 degrees Celsius to, so what, that is 0 degrees Celsius to 100 degrees Celsius. Next, the second question is, the second question is, so now the second question is, for a given material, so the resistance, the temperature T1 is equal to 20 degrees Celsius, the resistance R1 is equal to 5 ohm beta, and at the temperature T2 is equal to 100 degrees Celsius, so now the resistance is given by R2 is equal to 6 ohm. So, at the temperature of 20 degrees Celsius, the resistance of the given metal is 5 ohm. At the temperature T2 is equal to 100 degrees Celsius, the resistance is so R2 is equal to 6 ohm. Now, they will ask that alpha is equal to how much. Therefore, now here the temperature coefficient of resistance we have to find out. Formula what? So, from the expression now alpha is equal to, so what is the formula? R2 minus R1 by R1 into T2 minus T1. Use this expression, or you can take direct formula R2 is equal to R1 into 1 plus alpha into delta T, that is also correct only, but direct I am using the formula alpha is equal to R2 minus R1 by R1 into T2 minus T1. That alpha is given by R2 minus R1. So, R2 is equal to how much? That is the 6 minus 5 by 5 into T2 minus T1. T2 minus T1 means what? So, that is so 100 minus 20, that is equal to 80. Therefore, so you can say alpha is equal to, you can get that alpha is equal to 6 minus 5, that is the 1 by, so 5 into 80, that is equal to 400. Therefore, now if you solve what you can get, that is equal to 1 by 4 into, so 10 power minus 2, and if you simplify you can get what, that is equal to, so 1 by 4 means what, 0.25 into 10 power minus 2, and so what, per degree Celsius you can get the answer, and you can convert into, so 2.5 into 10 power minus 3, so per degree Celsius or 0.00, so 25, so you can get the answer like this. Therefore, this is the one more sample problem from the, so temperature effect on resistance. Next, next, let us go. The concept is cells and EMF. Cells and EMF concept. So, what is a cell? Cell is a device to store the electric energy, and so which provides the potential difference to the electrical circuit or electrical network. Therefore, so to run the electric circuit or to run the electric network compulsory, we need to apply a potential difference. The potential difference is supplied by the cell. Therefore, cell is a device which produces or which provides or which supplies a potential difference to the electrical circuit. And every cell having two important properties. One is the electromotive force or simply EMF of the cell, and another one is the internal resistance of the cell, that is a small r. So, this is called as the EMF and this is called as the internal resistance. Now, so this cell is connected to the, so what, external resistance. That external resistance I am taking that capital R beta. Right now, for example, when the cell is open, means what? There is no connection. So the external resistance is not connected. Now we can say this cell is under open circuit. Under open circuit, the current is equal to 0. Therefore, the potential difference across the terminals of a cell when there is no passage of the current is called as electromotive force. So here we have opened because it is a switch off. So when the switch off, that the potential difference across the terminals of a cell when there is no flow of current in the open circuit is called as what? Electromotive force. And what is the internal resistance? So that is the resistance, because every cell is constructed by using some amount of the electrolyte. So inside the cell, so there is a liquid conductor. That liquid conductor is called as the electro. Now, so this cell is providing a current I. So when the current is passing, now the potential difference across and the resistance offered by the electrolyte present inside the cell is called internal resistance. And when the current is passing on switch on, when the current is passing, now if you measure that potential difference across the terminal, that is called as the terminal. Done? Yes. Now, so among these 5 terms we have to get one relation. So the current in any circuit is always, remember, so if you take, this is I have taken only single cell, single external resistance, but if you take multiple resistances, external resistance and multiple number of the cells, in such case the current coming from the system I is equal to E effective by, so R effective plus R effective. Therefore, this is the first formula, I is equal to E effective by R effective plus R effective, where R effective is the total effective external resistance, so R effective is the total effective internal resistance, E effective is the effective EMF. Therefore, now here one more important point is that, so in terms of the current, what is the terminal voltage? Now, the terminal voltage is given by Vt is equal to E minus I into R, where I is current passes through the, so this is for single cell I am taking that Vt is equal to E minus I into R, and for the single cell the current is given by, so E by, because there is only single cell is there and R is the external resistance, small r is what? Internal resistance. Therefore, Vt is equal to E minus I into R. And so if the voltage across the external resistance is given by, that is the V is equal to I into R beta. Therefore, so this is the first formula, the current in the circuit, this is the terminal voltage across the cell, and this is what? So voltage across the external resistance. So based on this one we can get the, so what? So different types of the problems in this case. Now, so now here one more important point, if there is a single cell and a single external resistance, we can confirm that the terminal voltage across the cell is equal to voltage across the resistance, and it is applicable only for single external resistance connected to a single cell. That time only Vt is equal to V. So in the remaining cases, the terminal voltage across the cell is different and the potential difference across the external resistance is different. Now, so let us solve one problem. For example, now from the expression, now they will give like that. So now the current, for example, I am taking one cell and that cell, that now, so to this cell the EMF is E and internal resistance is R. Now when you are connecting one resistance, right, when you are connecting one resistance, so we don't know the resistance, for example R value. So now what? The current passes through is given by, for example, I1 value. Current passes through is I1, and they will give that I1 is equal to, for example, 2 ampere, and the terminal voltage across resistance is given by V1 is equal to, for example, 5 volts. Now, so when to the same cell, when you are connecting another internal resistance, so another resistance that we don't know that value, for example R2, now the current is passing I2 and I2 is equal to 3 ampere and the V2 is equal to, for example, now I am taking that there is so 6 volts. Now they will ask that, so what is the, so EMF and internal resistance of the given cell. Therefore, now what? So here E is the EMF, R is the internal resistance, and for the same cell, when you connect one resistance R1, that R1 value we don't know. That R1 value we don't know. Therefore, now what you can say, now when R1 is connected, so I1 is equal to 2 ampere. So when when V1 is equal to 5 volts, and in second case to the same cell, now we are connecting another resistance, the current is 3 ampere and V2 is equal to what? 6 volts. So in this case, what we can say now, so we have to find out, we have to find out what? So here this is 3 volts, let us take, but sorry for that. So Vt is equal to 3 volts, let us take that. Now in this case, what is the EMF and what is the internal resistance? What formula we have to apply? From the formula, a very simple question only, from the formula V is equal to E minus I into R. This formula you have to apply. So in the case number 1, if you take, so what you can get now? V1 is equal to E minus I1 into R. As I told you, so the cell is the same. So same cell. So when the cell is the same, EMF and internal resistance both are the same. Now, so therefore in this you substitute V1 is equal to how much now? V1 is equal to 5 volts, and that is equal to E value we don't know. So E minus I1. I1 value how much now? I1 is equal to, they have given 2 ampere into what? Into internal resistance. Next, in the second case, what? V2 is equal to, so E minus I2 into R. I am not changing the E value and R value. Therefore, in this case, that is equal to 3 is equal to E. E value E only, minus that is equal to, so 3 into R I am taking that. Let me take, this is equation number 1. This is equation number 2. Okay, na? Therefore, this is equation number 1, this is equation number 2. And on solving, so what you can get, you can get E value and so R value. Therefore, from equation number 1, what I am taking that is equal to 5 is equal to E minus 3R, and this is E minus 2R, and this is, so 3 is equal to E minus 3 into R. Therefore, now here we have to solve. Therefore, to solve which, what we can take, so let me take, this is equation number 1, this is equation number 2. So remove 1 first from 1 from 2. Therefore, if you do 1 minus 2, what you can get now? 5 minus 3 is equal to what? E minus 2R minus of E minus 3R. That's it. Therefore, remove equation 1 from 2. Therefore, 5 minus 3 is equal to 2 is equal to what? That is the E minus 2R. So, minus E. So, minus into minus plus 3R plus E minus E cancel. Therefore, 2 is equal to, so 3R minus R, that is equal to what? R. Therefore, now finally we can get the internal resistance of the cell is what? That is equal to 2 ohm. We got it. Okay, na? So for the given cell, the internal resistance R is equal to 2 ohm. And so we want not only internal resistance, we also want what? So if, EMF. Therefore, from any one of the equation. Now, from the equation 1, I am taking that. From equation number 1, what I am taking that? 5 is equal, therefore 5 is equal to, so E value we don't know, minus 2 into R value. R value how much you got? 2. Therefore, E 5 is equal to E minus 4. Therefore, E is equal to 9 volts is the EMF of the cell. Therefore, whenever they will give that voltage V1 with current I1 and voltage V2 with current I2, use the formula V is equal to E minus I into R. This V is equal to E minus I into R is called as a cell equation in the physics. Now, so another question, same model but little bit different. Now, for example, this is one cell. So, when you are connecting one external resistance R1 is equal to 10 ohm, the current I am taking that is equal to I1 is equal to 5 amperes beta. So, now what? Same cell E comma R I am taking that. Now, to the same cell, I am not changing the cell. When you are taking the, so when you are increasing the resistance R2 is equal to, so R2 is equal to 20 ohm and the current, so I am taking that is I2 is equal to, for example, 2 ampere. I2 is equal to how much I have taken? 2 ampere. Now the question is again same. What is the EMF of the cell and what is the internal resistance of this cell amount? Therefore, here these are the not two different cells, same cell. For the first case, when I connect a resistance of 10 ohm, the current passes through the circuit is 5 ampere. When I will change the resistance from R1 to R2 is equal to 20 ohm, the current in the circuit is equal to 2 ampere. Now the question is, what is the EMF of the cell and what is the internal resistance of the cell? Now in this case, what we have to apply that? Now I have given one formula. From the formula, I is equal to E by R plus Rm. So you can use this formula, so you can get the answer very simply. Now in the first case, what is that? In the first case, so that is 5 ampere is equal to E by, so R value how much? That is 10 plus R. Therefore now what? So let me take this as equation number 1. Or you can take the multiplication. 5 into 10 what? 50 plus 5 into R is equal to E. Let me take equation number 1. So come to the second case. In the second case what? So current I is equal to 2 ampere is equal to same EMF E by, so that is the 20 plus what you can say, that is the R. Therefore once again, so 220 that is equal to 40 plus R is equal to what? That is the, so that is equal to E, equation number 2 I am taking that. Once again, here E, both is there, and both sides E is the same, and equate them. If you equate, so automatically what you can get, the answers you will get the for that. Okay. Therefore now E value, and you solve the equation 1 and 2, so you can get the, so the answer for E, and I will solve them. E and E cancel. Therefore now if you take the cross multiplication, or you can division, or both, if you take 1 is equal to 2, you will get the R, small r value first, then after that small r value substitute in any one of the equation, you can get the answer for that. Next, now, so here Kirchhoff rules, or before that better, so combination of the cells, combination of the cells, combination of the cells. So here we have taken only single cell for the problems. Now let us discuss a combination of the cells. For example, this is the first cell, and this is second cell, this is the third cell, and so on, like that. I have taken multiple number of the cells. All those I am connecting to one single external resistance R. Here first cell EMF is E1 and its internal resistance is R1. For the second cell EMF is E2, internal resistance R2, and so on up to N resistance I have considered. Now, so when all the cells are correctly connected in series combination, what is the meaning of correctly connected? So here positive, this is negative, positive, negative, positive, negative, means what? To say correct combination of cells in series combination, we have to take that the negative terminal of the first one should be connected to positive, negative of the second one should be connected to the third one positive, like that. Means what? So the negative terminal of one resistor, one cell must and should be connected to the, so positive terminal of the next cell, then we can call that is a correct connection in the series combination. Therefore now the effective EMF is given by ES is equal to, so that formula very simple, so E1 plus E2 plus E3 and so on, what? That is equal to up to En. This is the effective EMF in the, so series combination of the correctly connected cells beta, and the effective internal resistance is given by RS is equal to what? That is R1 plus R2 plus R3 and so on Rn. Therefore this is effective EMF and this is the effective internal resistance. But for identical cells, what is the meaning of identical cells? All cells having the same amount of the EMF and the same internal resistance, those cells are called as the identical cells. For identical cells, the EMF is given by ES is equal to, this is E plus E and so on, how many times? that is N times we have to write, therefore now what, that is equal to N into E. Therefore, for the identical cells the effective EMF is N into E, where N is the number of the cells given in the problem and E is the EMF of the cells. Next, the effective internal resistance also same beta, Rs is equal to, so what, that is so R plus R up to N times, therefore now you can say what, that is equal to N into R. Therefore, for identical cells Es is equal to N into E and Rs is equal to N into R. What is the current in the circuit? Now the current in the circuit is given by, as I told you, E effective by R effective plus so R effective, but it is in the series combination, that is given by Es by only single resistance I have taken, that is R plus Re, that is equal to what, so Rs you can take, that is equal to, for identical cells Es is equal to N into E by R plus N into R, and this is very important formula. Remember, for the identical cells only, maximum problems they will give the identical cells. So for the identical cells, I is equal to Ne by R plus N into R is the current formula in the series combination, and that current is, I am taking what beta, that is a capital IM. Next, this is the series combination. What about the parallel combination? Now, if you take the parallel combination, if you take parallel combination, now this is the first cell, this is the second cell, and this is the third cell, and so on like this. Therefore, all these parallel combination I am connecting to one external resistance, and this combination provides some amount of the current I, and here the EMF is E1 comma R1, here the EMF is E2 comma R2, and here the E3 comma R3. I am taking that. Now, so in this case what is that? Now the effective EMF is given by, the effective EMF in this case is given by, so E effective is equal to, means what, in parallel combination. So in parallel combination, so E1 by so R1 plus E2 by R2 plus E3 by R3 and so on, En by Rn by what? By 1 by R1 plus 1 by R2 and so on, 1 by Rn. This formula somewhat different compared with the series combination. So the effective EMF in the parallel combination is given by E1 by R1 plus E2 by R2 plus E3 by R3 and so on, 1 by R1 plus 1 by R2 plus and 1 by Rn. And the effective internal resistance is given by 1 by Rp is equal to 1 by R1 plus 1 by R2 and so on, 1 by Rn. So this is the internal resistance, and that is the effective EMF in the parallel combination of the cells. And here one important point is that for identical cells, for n identical cells, for n identical cells, for n identical cells, so what is the answer for that? Identical means what? All are the same, EMF of the each cell is the same and internal resistance also same. So now if you solve, you can get that EP is equal to, you see E by R plus E by R plus E by R plus E by R. Like that, how many are there? N E by R is there, correct? Next, so what you can say here? So here 1 by R1, 1 by R1, 1 by R plus how much like that? Therefore now that is what we can get that what, that is N by R only. Okay, na? So because it is the ulta, 1 by R1 plus 1 by R to N by R, and here R get cancelled, N get cancelled is equal to E only. And the interesting point is that, so in the parallel combination of identical cells, the total effective EMF is just equal to EMF of a single cell. It does not depend upon the number of the cells. You see, so Ne by R we got, and here we got N by R, N get cancelled, RR get cancelled. Therefore now what? So now this is the E only. Therefore, so the important point in this observation is that, so for the identical cells in the parallel combination, whatever the number of cells you take, the total effective EMF is just equal to EMF of a single cell only. And what about the internal resistance? Now the effective internal resistance in the identical cases is equal to 1 by Rp is equal to, you will get that 1 by Rp is equal to, so N by R, and Rp is equal to enamadu, Rp is equal to R by N. Therefore, that is the effective internal resistance in the parallel combination, right. Therefore, here one numerical let us solve based on this series and parallel combination of the cells, and one more here, what is the meaning of correct connection cells? So, in the parallel combination, so we have to connect the cells in the correct order. So, when all positive terminals of the cells should be connected to a single point, all negative terminals of the cells should be connected to another point, then we can call all these are correctly connected cells in the parallel combination. See, so for n identical cells, this is one numerical, let us solve. Now, what the one problem let us discuss. Now, for n identical cells, so the current in a series combination is equal to parallel combination. Means what? You have taken, so number of cells in series combination, same number of the cells next time you are connecting in the parallel combination. The condition is that the current in the series combination is equal to current in the parallel combination. Now they will ask that what? Now what is the relation between R and small r? Nana? So, what is the relation between capital R and a small r? So, let us discuss. So, what is that number? Now, in the series combination what? Now, in the series combination the formula what I have given Is is equal to Ne by R plus N into R. This is equation number 1, we have to take that. In parallel combination formula what Ip is equal to E by R plus R by N. As I told so current formula what? The current formula I is equal to E effective by R effective plus R effective. This expression I have given. So, in parallel combination for n identical cells, the effective EMF is given by E effective is equal to E by R plus R by N. And if you simplify what you can get now, that is equal to this N goes upside. So, now that is N into E by N into R plus R. This is equation number 2. So, as per the given condition, what is the condition? The current in the series combination is equal to current in the parallel combination. In such case, what we can say now? So, now we can equate them. So, according to question, current in the series combination is equal to current in the parallel combination. Write the equation. In the series combination, we got Ne by R plus N into R is equal to Ne by R plus, which are Nr plus R. Therefore, here Ne get cancelled. Now you can say what? R plus Nr is equal to Nr plus R. Therefore, now if you bring the capital R this side and small r on this side, so you can get what? Now Nr minus R is equal to N capital R minus capital R. So, if you take the common small r on the left side, capital R on the right side, now you can get R minus N minus 1 is equal to capital R N minus 1. On both sides N minus 1, N minus 1 cancel. Yes, the internal resistance of the cell must and should be equal to what? External resistance. Therefore, the internal resistance of the each cell must and should be equal to external resistance of the given external resistance. Therefore, now then and only then the series combination current is equal to parallel combination current. Next, so let us go for the Kirchhoff rules. Kirchhoff rules. So, what is the Ohm's law? According to Ohm's law, V directly proportional to I. And when we have to use the Ohm's law? So, Ohm's law is applicable when the circuit is very simple. So, when we will call the circuit is simple? If there is a single cell right now. If there is a single cell, then we can call whatever the number of external resistance. Number of external resistance is not a matter, but if you consider a single cell, now you can say what that circuit is the simple and right now. But if you take along with the multiple number of external resistance, if you take multiple number of the cells, then so through any resistor to find out potential difference, to find out the current becomes somewhat complex. So such type of complex electrical circuits can be solved by using the Kirchhoff rules beta, right now. So what is the meaning of Kirchhoff rules? I will say now. First rule is what? Rule number 1, that is so KCL, Kirchhoff current law or Kirchhoff's junction law. So we can say Kirchhoff first law, Kirchhoff first law, Kirchhoff current law, Kirchhoff junction law, all will same. For example, let me take this is one junction in electric circuit. Junction means what? So it is a point in the electric circuit where so the number of conductors will meet. For example, this is one conductor, right? This is one more conductor, this is one more conductor, and this is so one more conductor. So this is one more conductor I am taking. And of course the resistance we don't know here. So the current coming from the first conductor I am taking that I1, the current coming from the second conductor is I2, the current going in the third conductor, for example I3, and in the fourth one is I4, and in the fifth one what I have taken I5. Already you know that. So this point is called as a junction. At any junction inside the electrical circuit, the sum of the currents entering the junction must and should be equal to sum of the currents leaving the junction. Therefore, how many currents are coming? Therefore, if you count first one, second one, and fifth one, both currents are coming toward the junction. Therefore, the sum of the currents coming toward the junction, I1 plus, that is so I2 plus I5 is equal to so I3 plus I4. Therefore, this is the first law, and first law is the law of conservation of electric charge. Okay, na? So this is I1 plus I2 plus I5 is equal to I3 plus I4, and for this sign convention is not required. So but for the second law, Kirchhoff voltage law compulsory you have to follow the, so what is that? That is the some sign convention rule, right now. This is the so first one. Now let's go for the second one, KVL. So now let us go for the Kirchhoff second rule, KVL. So Kirchhoff voltage law, also called Kirchhoff's loop law, and also called Kirchhoff node law. Therefore, what is the meaning of it? So here according to, for example, I am taking that one closed path, this is the one resistance I am taking that, this is one more resistance I am taking that R1, R2. So here one cell I have taken, so first cell, and EMF I am taking that E1, and it is one more cell I am taking that, so that is I am taking that E2, and so just for simple purpose I have taken only two cells, single cells I have taken, two cells I have taken, two external resistance I have taken. So first of all, it is a closed path or not, we have to check it. Therefore, now we are what? For example, if you take this is the A, B, C, and this is what? D. So now it is a closed path. Right? A, B, C, D is a closed path. In any closed path, now, so in any closed path, according to statement of the KVL, in any closed path, therefore what I am taking that, so that so the sum of EMF of all cells plus the sum of potential difference across all resistance must and should be equal to 0. This is the statement of the second Kirchhoff law, that is nothing but a KVL. What is that? The sum of EMF across all cells must and should be plus sum of voltage drops across all resistance is equal to what? 0. Therefore, this is the statement. But to solve this problem, for example, here I am giving that, so R1 is equal to something, R1 is equal to, for example, 5 ohms I have given, R2 is equal to, for example, 15 ohms I have given, and E2 is equal to, for example, 20 volts, E1 is equal to, I am taking 10 volts. Now they will ask that what is the current in the circuit. So as I told you in the previous case what, so if it is a single cell, directly we can apply Ohm's law, I is equal to current is equal to V by R formula, where V, R and both are in the series. So R1 plus R2 we can say, then automatically we can get the answer. But in this case what, two cells are there, and how to solve this one somewhat complex. But here this circuit is very easy. So but thing is that multiple number of the cells if they are present, this is somewhat difficult to solve, that's why. So by using the Kirchhoff voltage law we can take them. Now here the most important point is that sign convention. So sign convention is what? That is a very important. For example, if you travel through a resistor, so resistance is connected between A and B, right? Resistance is connected between A and B. Current is traveling from A to B, that current is I am taking that resistance R. And if you are observing, if you are crossing the resistor in the same direction of the current, this is your observation. This is your observation direction, and current is in the same direction. Therefore, the voltage across the resistors must and should be taken as what, in negative only. V is equal to minus I into R you have to take. The problem in this KVL is only how to identify this so sign convention. What is that? When a observer crosses resistor in the same direction of the current, the voltage across the resistor or the potential difference across the resistor must and should be taken as what? Negative. And so second point is what? Now the second point is when you cross a resistor, this is the direction of the current. I am taking this is the A and this is the B. This resistance is connected between A and B, but you are observing or you are crossing the resistor in the opposite direction. This is your observation. Now in such case, this is the current I. Therefore, the voltage across the resistor can be taken as the V is equal to plus I into R. Okay, that is the voltage across the external resistance. So this is the sign convention about what? About resistance. What about the sign convention about the cell? Therefore, now that also I will say. Now, so for a cell, this is the cell I am taking that. Now, so here this is the A and this is the B. For the cell, direction of current is not required. So when you cross a cell from positive to negative, when you cross a cell positive to negative, the EMF of the cell can be taken as the negative only. Remember, when you cross a cell from positive terminals to negative terminal, EMF of the cell can be taken as the negative. Or when you cross a cell in any closed path, when you cross a cell from negative to positive, now the EMF can be taken as what? EMF can be taken as positive. Therefore, now here this is the A, this is the B, I am taking that. In this case, EMF can be taken as what? Positive. So when we cross a cell negative positive to negative, we are converting to negative, therefore its EMF can be taken as negative. When you are crossing a cell from negative to positive, so we can take what? That EMF is equal to, so positive we can take. So based on this information, now in this case we have to find out the current better, right? So we can find out the current, let us discuss. Now, so let us discuss one current I am taking like this. So here the current is coming like this. This is the current direction I am taking, that I, and here also current is I, and here also current is I, and here also current is I, here also current is I beta. Now it is a closed path. By using the Kirchhoff rules, we have to find out what is the current in the circuit. Okay. First of all, in closed path, A, B, C, D, A. First of all, check it. We have to start from A, we have to reach back to the A, then we can call it as a closed path. Now, first of all, I am traveling from A to B. You see, we have to go from A to B. When you travel from A to B, you are crossing a cell from negative to positive, isn't it? You are crossing from negative to positive. Therefore, now what? So, its EMF can be taken as what? 10 volts is completed. Right. Next, A to B completed, B to C you are traveling. So, while traveling B to C, R1 is there, R2 is there, and current what? So, here current I, so ohms, how many resistance? That is a 5. Therefore, now you are traveling from B to C, you are observing from B to C, current also traveling from B to C, therefore minus 5 into I. So, I into R is there, no? So I told you, when you cross a resistor in the same direction of current, so voltage across the resistor is negative. Similarly, minus, that is what, 5 into I will take. Therefore, now last, C2D, B2C completed, next you have to go for C2D. C2D, nothing is there, no resistance, no cell, leave it and come from D to E. So when you come from the D to A, therefore what, you are crossing from positive to negative, then what, it becomes what, negative minus 20 is equal to what, 0. Because sum of the all EMFs plus sum of all voltages across the resistance is equal to what, 0. And if you simplify, what you can get now answer, 10 minus 5I minus 15I minus 20I, so minus 20 is equal to 0. Minus 20 minus 10, so minus 10, so minus 20I is equal to 0, and you can say 20I is equal to, so minus 10I, therefore I is equal to minus 1 by 2, therefore I is equal to minus 0.5 ampere. So this is the current. Acha. Here our doubt is what? So why the current in this circuit becomes negative? So generally what path we have taken? In closed path we have considered A to B, B to C, C to D, D to A. In such case, we got current is equal to minus 0.5. So you may get doubt, sir, why the current is negative? Because we have considered the direction of the current is reversed. Means what? If you take the current in the opposite direction, means what? A to D, D to C, B to A. Now you are getting I is equal to plus 0.5 ampere. Here minus does not mean that the question is, the answer is wrong. It indicates that the direction we have taken reverse according to original direction of the current. Therefore, now what? If you consider, so A to D, D to C, C to B, B to A, then you will get I is equal to plus 0.5 ampere. Therefore, now your minus does not mean that it is the wrong. So it is indicating that the current travels in the opposite direction of our consideration. That's it. Okay. And sometimes they will ask that, what is the direction of the current also? A to B na, B to C na, C to D na, that also by based on this we can say the answer. Therefore now, so this is the second question now. Now, so let's go another question from the KCL. For example, here one resistance, here one more resistance I am taking that, and so here one more resistance I am taking that. So here the potential difference, for example 20 volts I am taking that, the resistance for example 5 ohms. Here the volts I am taking that is a 10 volts, and this is the 5 volts I am taking that, and the resistance that is equal to, for example now I am taking that is a 10 ohm, and here the resistance I am taking that is a 6 ohm I am taken. Now, so they will ask that what is the current in the 5 ohm resistance? What is the current in the 10 ohm resistance? What is the current in the 6 ohm resistance? Right? Just one sample model I will say to you. Here at this point the potential is equal to 20 volts. At this point the potential is equal to 10 volts. At this point the potential is equal to how much? 5 volts. Now the question is what? What is the current passes through the 5 ohm? And what is the current passes through the 10 ohm? What is the current passes through the 6 ohm? What is the current formula? Current I is equal to, according to Ohm's law, potential difference by given resistance. Here this is the potential at a single point. This is not a potential difference. What we want, potential difference means what? Here compulsory, this 5 ohm resistance, if you take, this is the A, this is the B, and this is the C, and this junction name I will take O beta. Now, first of all, we people have to find out what is the voltage at the junction. So, if you find out the voltage at the junction, so you can find out all values automatically. How to find out? For example, from this some amount of the current is coming, I don't know that current, I will take I. So, this current is coming from A to O. After coming to the O, this current is splitting into two parts. First part I will take I1, second part I will take what? That is the current is I2. So, the current is splitting into two parts at the junction O. Now, according to Kirchhoff first law, the current entering the junction is must and should be equal to the current, so leaving the junction, sum of the current leaving the junction, I is equal to I1 plus I2. So, according to Ohm's law, what is the formula? Potential difference by resistance. Current in the 5 ohm traveling from A to O. Therefore, now A is at a higher potential. So, V naught is at a lower potential, means what? V naught is the lower potential. Current always travel from higher potential to lower potential. In place of the I, we can take what? VA minus VO by, now you take a resistance R1, this you can take a resistance R1, and that is equal to I1. So, what is the I1? So, in this 10 ohm current is traveling from where to where? O to B. Therefore, O is at higher potential. So, B is at lower potential. Now, you can say that is what? V naught by, so that is VB value I am taking that by what? By R2. Next plus, so this one next what? So, current in the 6 ohm is traveling from O to C. Therefore, now O is at higher potential. Therefore, VO minus VC by, so that is I am taking that R3. If you substitute the values, this is the 20 minus V naught by, so this is I am taking that 20, that is equal to, so VO we do not know, VO minus 10 by R2 is equal to how much? That is R2 is equal to, that is 10 I am taking that. So, plus, so VO minus, that is equal to 5 by R3. R3 is equal to how much? That is equal to 6 ohm I have given. Now, on simplification, you are getting the something answer V naught. Therefore, by solving this equation, you get the voltage at the junction V naught. After that, you substitute this current in this one, you can get the current I, I1, I2 and I3, and thank you.
Okay, good morning all of you. Today I am going to discuss about yesterday's topic. Yesterday's chapter, that is called alloalkanes and alloarenes. Yesterday some of the part I discussed. Today remaining part, main concept, very important again. So many times they are asking questions. Now also they will ask, what are those? That concept is nucleophilic substitution reactions. Those are SN1 and SN2. Here important, I will say the main differences. Based on the main differences, we have to solve some questions. Now totally today only this small concept I will discuss. After that we will discuss remaining questions only, question solving, right? SN1 reaction. So SN1 reaction, first point, that means unimolecular nucleophilic substitution reaction. This is called bimolecular nucleophilic substitution reaction. This reaction will take place in polar protic solvent. This is important. Polar protic solvent. This reaction will take place in polar aprotic. What is the meaning of protic to aprotic? Polar means charge separation. Protic means which is able to donate proton. That is called polar protic. Example is water, acetic acid, like that. So water H plus and OH minus, that means charge separation, that is called polar, and it is giving proton, that is called protic. This also CH3 COO minus and H plus. So H plus is giving proton, that is called protic, and charge separation, that is called polar protic. That means polar aprotic SN2. Polar aprotic means that must be polar, that means charge separation. Aprotic means which is not able to donate proton, that is called polar aprotic. So polar aprotic means one of the example is this one, acetone. Here charge separation will be there. How? Carbon, oxygen, the more electronegative, carbon is less electronegative. Electrons are moving towards oxygen side, oxygen getting negative charge, carbon getting positive charge. That means charge separation is there, but it is not able to donate proton. That's why it is called aprotic. Some other one, benzene. Benzene also charge separation is there because of delocalization of pi bonds. Then it is not able to donate proton. Next one, this one, DMSO, dimethyl sulfoxide. Dimethyl sulfoxide is called one of the polar aprotic solvent. Here also charge separation because of electronegative difference between sulfur and oxygen, right? These are the polar aprotic, these are the polar protic. That is the first point. Second point, this reaction will take place in two steps. In mechanism, how many steps will take place? Two steps. This is only single step. Single step reactions are called elementary reactions. This is related to kinetics. So the reaction will take place in only single step, that is called elementary reaction. Reaction will take place in multi-step, that is called as complex reaction. This is the elementary reaction. Compulsory SN2 is an elementary reaction, right? Next, here intermediate is carbocation. Carbocation is the intermediate, right? Here intermediate, there is no intermediate, that is called transition state, but that transition state you should not call intermediate. So simply intermediate. So middle step is the transition state. That means here what you can say, no intermediate. Next one, reactivity order of different types of alkyl halide. Tertiary alkyl halide is more reactive than secondary, than primary, than just alkyl halide. Why? Because intermediate is carbocation. This is tertiary carbocation, this is secondary carbocation, this is primary carbocation, this is carbocation. Which carbocation is more stable? Tertiary carbocation is more stable. More stable intermediate is the more reactive. That means reactivity order of various types of alkyl halides in case of SN1. This is the order. In case of SN2, reverse, exactly reverse. That means alkyl halide, primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. So sir, here intermediate is carbocation. Based on the carbocation we decide like this order, reactivity order. But here there is no intermediate. How to decide the reactivity order? That reactivity order is decided by steric hindrance. Very, very important. Steric hindrance, more steric hindrance. Actually SN2 nucleophile attacking on back side of the leaving group. That means here both sides will not possible, only back side will be attacked. Back side will be attacked means where the more steric hindrance is there approaching of nucleophile is less. Where the steric hindrance is less, approaching of nucleophile is more. Steric hindrance means more bulkier groups. Because of more bulkier groups, that bulkier groups will be means that bulkier groups what will happen, approaching of nucleophile will be stopped. That's why reactivity also will be slow or less reactive. Observe here, alkyl halide and tertiary alkyl halide. Where is the more bulkier groups are there in case of tertiary alkyl halide? Because 3 alkyl groups are there. You just here only alkyl, one alkyl group is there. Here more number of alkyl groups are there means approaching of nucleophile will be very less, because these alkyl group will be hindered. Hindered means stop approaching of nucleophile. That time reactivity will be slow or low. But here reactivity will be high. Why? Because here only one alkyl group. Only one alkyl group means here steric hindrance will be less. That's why here more approaching of nucleophile is there. More approaching of nucleophile means more SN2, that means more reactivity. That means what you can say, steric hindrance is inversely proportional to reactivity in case of SN2. But in case of SN1, observe here more steric hindrance, less steric hindrance. Already I told tertiary is the more steric hindrance, alkyl halide is the less steric hindrance. So in this, which one is the more reactive? Tertiary, because of intermediate is carbocation. That means this is more steric hindrance, more reactive. That means what you can say, steric hindrance is directly proportional to reactivity in case of SN1, in case of SN2. This is directly proportional, this is inversely proportional. This is order. SN1 order is first order kinetics. It is a first order kinetics. It is a second order kinetics. First order kinetics, second order kinetics. Now, next one. In this first order kinetics means concentration depends on only, means order depends on only concentration of reactant. So, that means alkyl means rate of the reaction depends on only concentration of alkyl halide in this case, because this order is first order. So, rate of the reaction depends on only concentration of alkyl halide, but in case of this one, rate is depends on both. What both? Concentration of alkyl halide and nucleophile, approaching of nucleophile. This will take place at a time, both. That's why this is order is 1, this is also order is 1, total order. Order is equal to 1 plus 1, that's why order is equal to, here only order is 1. That means your rate depends on only concentration of reactants, that means alkyl halide. Your rate depends on both alkyl halide and concentration of nucleophile. Next one, last point. This last point is related to stereochemistry. The stereochemistry means stereochemistry related to what you call chiral compound. Chiral compound is there, that chiral or achiral, then later I will tell you. Wait. Now finally here, in this final, in case of stereochemistry, final product is racemic mixture. Racemic mixture. Here final product is only inversion. I will tell you. Here final product is what? Racemic mixture. Here final product is what? Inversion. These are the some of the main points related to SN1 and SN2, right? First one, inversion or retention already though. Racemic mixture means it is the equimolar mixture of two enantiomers. Equimolar mixture of two enantiomers. Two enantiomers. What are the enantiomers? One is D, other one is L. So what is mean by D and L? D is called dextro-rotatory, L is called levo-rotatory. Dextro-rotatory means clockwise rotation, levo-rotatory means anti-clockwise direction. Otherwise D and L, otherwise symbol plus or minus. There is sign, this is called symbol, this is called sign. Plus sign or minus sign. Plus sign means clockwise direction, minus sign means anti-clockwise direction. Clockwise direction means dextro, anti-clockwise direction called levo. This mixture equimolar means that is called total 100% means 50-50. This is called, this total is called what? What do you call? Racemic mixture, RM. RM is called racemic mixture. Well, what is meant by racemic mixture? Equimolar mixture of two enantiomers is called as racemic mixture. That means dextro and levo is formed. One form is dextro, other form is levo. That is the meaning here. Here mean what is the meaning of that? Here alkyl halide there, nucleophile attacking on. So first what is the this reaction mechanism will take place 2 steps. First step is formation of carbocation. Second step is attacking of nucleophile. Mechanism I am saying. And that attacking of nucleophile attacks on either side. In this case, nucleophile attacking on either side. front side to back side. That means this side alkyl halide is there, this is called front side. This is alkyl halide back side, this is called exact opposite, this is called back side. Front side of the alkyl halide and back side of the alkyl halide. That means nucleophile attacking on the front side of the alkyl halide, nucleophile attacking on the back side of the alkyl halide. That means alkyl halide means that is called halide is leaving group. For example, I will take like this. Simply I will take. This is called leaving group, right? This leaving group, this is called removing now. After removing, then you will form what is formed carbocation. So nucleophile, for example, I will take OH minus. So front side will attack. Again, back side also will be attacked. That means like this, front side, back side. So that meaning here, what I am going to say, nucleophile attacking on the same side of the leaving group, same side of the leaving group is called retention. Retention, what I am going to say, retention inversion, that is called stereochemistry point of view. What is that? Nucleophile attacking on the same side of the leaving group is called retention. Nucleophile attack on the back side of the leaving group is called inversion. Both retention plus inversion is called as racemic mixture. What do you call? Retention plus inversion. Retention means just our understanding point of dextro. Inversion means that is called levo. That is not exactly dextro levo, the understanding purpose. This is plus, this is minus. Otherwise, this is 50, this is also 50. These are the representations for what? Racemic mixture. Retention plus inversion. So in case of SN2, so nucleophile attacks on only not front side, only back side of the leaving group. That's you will get inversion product. Inversion. That's all. So other one, next point. Racemic mixture is a optically inactive. Other point, very very important. Racemic mixture is a optically inactive. Why? Why? Because optical rotation of one isomer is cancelled by optical rotation of another isomer. That means retention, for example, dextro. Dextro means clockwise rotation. Levo means anti-clockwise rotation. Both rotations are in same direction or opposite direction. Both are in opposite direction. Opposite direction means cancelling each other. Cancelling each other. That means net optical rotation is or optical rotation is 0. Because of this 0, that's why it is optically inactive. Finally, racemic mixture is a optically inactive. Why? Why means optical rotation of one isomer is cancelled by optical rotation of another isomer. One is clockwise, another one is anti-clockwise. Both are in opposite direction. That net resultant rotation is cancelling each other. That's why it is equal to 0. That's why it is racemic mixture is optically inactive. Right. Next one. Using this, I am going to say some points now. Observe here and some questions also. First one. CH2 double bond CH2 X may be chlorine or bromine. Next one, this one. What is this one? These two I am giving now. In these two, reactivity order of reactivity order, not of reactivity order in case of SN1 and SN2. Right? Observe clearly. This is called allyl halide. This is called benzyl halide. So you should know the definitions of allyl and benzyl. So what is meant by allyl? What is meant by benzyl? Halogen atom is bonded to sp3 hybridized carbon. This is called sp3 because carbon surrounding by 4 bonds. 1, 2, 2 hydrogen. Total 4. 4 hydrogens are there. Halogen atom is bonded to sp3 hybridized carbon. Next to carbon-carbon double bond. Carbon-carbon double bond is called allyl halide. Allyl halide. Now in this is called benzyl halide. That means this is called benzyl halide. That means halide means chlorine. That is called benzyl chloride. That is called benzyl halide now. Bromine means benzyl bromide. That is called allyl chloride or allyl halide. Right. This one observe now. First one, what you have to do? These are all nucleophilic substitution reaction. Nucleophilic substitution reaction, electrophilic substitution reaction and elimination reaction. What are those reactions are there? Total types of reaction 3 are there, total 4 are there. On that 3 main I am going to say. So, on that all reaction intermediate is carbocation. First carbocation we have to check it now. Then what you have to do? Observe here. First one I am taking this one. CH2 double bond CH, CH2. Means what is a leaving group? Good leaving group is halogen, means removing. Halogen is eliminated as a halide ion. So, that you have to remove first. Then remove that. Then I can get remove like this. Then I am getting positive. Halide ion is a negative charge, halide ion. Then carbon getting positive charge. That is called carbocation. This carbocation is called allyl carbocation. This you have to know. Allyl carbocation. This allyl carbocation having the conjugation. How to know conjugation or not? Double bond, single bond, positive charge. It is having the conjugation means it is involves in resonance. Because of resonance it is giving resonance structure. More number of resonance structure, more stable. That means this is called, these are called intermediate. More stable intermediate is the more reactive. So, finally, in this bond is shifting like this, because this shifting like this means it is getting negative charge. This negative charge means already positive charge here. Negative charge what happened attraction, that is called bond is formed. This carbon getting positive charge. So, CH2 plus CH double bond CH2. Then what happened? These are called resonance structures. This is one, other structure, two structure. Two how many resonance structure? Two resonance structure. More number of resonance structures, more stable. That's why benzyl carbocation is involving in resonance. In case of this one, this is called this is called allyl carbocation. This is called benzyl carbocation. Observe now. Benzyl carbocation means what is the meaning of benzyl? What is the meaning of benzyl halide? Halogen atom is bonded to sp3 carbon S next to aromatic ring, also called benzene ring, that is called benzyl halide. In case of this one, carbon carbon double bond. In case of this one, halogen atom is attached to sp3 carbon next to aromatic ring, also called benzene ring, is called as benzyl halide. Same benzyl halide also like this. CH2 plus halogen is eliminated as a halide ion. So, right. So, benzyl halide now. This is also having the conjugation. Observe now, conjugation, double bond, single bond, positive charge. Double bond, single bond, positive charge, having the conjugation. Conjugation means it involves in resonance. So, that is why bond is shifting like this. Then what happened to you? This bond as it is, this bond as it is. What is the charge here? Positive charge. This will get negative, negative and positive. What happened? Bond is formed, that is called double bond. Again, it is having the conjugation like this. That means this benzene ring is involving resonance. The total how many resonance structures will get it you already you know, total 4 resonance structures. In this two, which one is the more stable? This one. Why? Because it is having the more number of resonance structure. Here 4 resonance structures, here 2 resonance structure. These both are involving in SN1. Right? This more SN1, this one only now compared to this. Why? Because this is involving in resonance, this also involving in resonance. So, it is more number of resonance structure, this less number of resonance structure. That is why more number of resonance structures, more stable. More stable intermediate is the more reactive. Which one is the more reactive? Benzyl halide. Benzyl halide is the more reactive than allyl halide. That is case of SN1. Right? Next one. Next, some other questions. Next one. Reactivity order of SN1 and SN2. So, sometimes they will be SN2, sometimes they will ask SN1. So, that is why first we do not know, because what we do not know, they are asking SN2 means this type of question, first you have to write the SN1 order. After SN1 order, exactly reverse say SN2 order, because why I am saying now, SN1 intermediate is carbocation, SN2 intermediate is no intermediate, that is why. So, no intermediate means that totally purely depends on steric-kindred. So, somewhat difficult to identify the steric-kindred, that is what you have to write. First SN1 order followed by SN2. So, SN1, observe now. So this halogen, this is also halogen. This halogen atom attached to primary carbon, that means primary carbocation. Halogen is eliminated halide ion. Same as it is, every concept like this only. Remove the halogen, you will get the carbocation. Here also you will get the carbocation. These both are having which carbocation? Primary carbocation. So both are having the primary carbocation means we can't decide SN1 which one is more. So that time what you have to do depends on halide ion. Halide ion is what now? Iodine, here is chlorine. In these two, which one is the good leaving group? Good leaving group is iodide. Why? Because of iodide is large size. Large size means what happened? What about attraction? Less attraction. Less attraction means we can break down very easy. That's why halide is a good leaving group. So in case of alkylates Ri, RBr, RCl and RF. One of the time they ask the question. What is the reactivity order of SN1 and SN2? Both are same. So Ri, RBr, RCl and RF. Because alkyl group are same. So reactivity order decided by only halide ion. Iodide, bromide, chloride and fluoride. Which one is the good leaving group? Good leaving group means this one only because of large size. Why this is not good leaving group? Because of small size. Small size means more attraction. More attraction means we cannot break down bond very easy. That's why it is less reactive. It is large size, less attraction. We can break very easily based on the size. That's why Ri is the more reactivity. In case of both SN1 and SN2, one of the time they ask the question. Based on this, we can decide this which one is highest SN1. SN1 and SN2 both are same, that one only. That is the question. Next one. So write the increasing order or decreasing order of SN2. I am asking question. So SN2 means you can easy then first observe SN2 intermediate we don't know. SN1 intermediate we know. SN intermediate is carbocation. Remove this. Remove this halogen means this is then I am getting like this. What I am getting? CH2 plus primary carbocation. I am getting like this. This is secondary carbocation. This is primary C plus. This is secondary C plus. Which carbocation is more stable? Secondary carbocation more stable than primary. That's why which one is the more SN1? SN1 is this one is more. Right? SN2 exactly reverse. This is SN2. Like this you have to do the questions now. Next one. Next very important. C6H5 CH2Br C6H5 CH C6H5 Br. Next one C6H5 CH CH3Br. Last one C6H5 C CH3 C6H5 and Br. Write the increasing or decreasing order of both SN1 and SN2. One of the time they ask the question, this one only now. Right? First one, same as it is, same concept. So, first one eliminate Br, that is means C6H5 that is called benzene. Right? Okay, C6H5 CH2 plus. Here also. This is the within the parenthesis. Parenthesis means that is meaning of substituent. C6H5 CH C6H5 means substituent. Then Br is eliminated. That is meaning plus charge. Now C6H5 CH, this is substituent, positive. Br is eliminated. Next this one C6H5 C substituents, C6H5 1, 2 substituents are there, CH3, this is Br, that's all. Right? Now after removing this halogen ion, then I am getting the carbocation. So which carbocation? Simply, so we don't know names, leave it now. This is the primary carbocation, our understanding. This is secondary carbocation. This is also secondary carbocation. This is what? Tertiary carbocation. So remaining benzenes are there, that will leave it now. If you don't know, carbocation simply primary, secondary and tertiary. In these two, which one is the more stable? Carbocation, tertiary. This is the tertiary more stable. Tertiary carbocation. Next one, tertiary after secondary. This is also secondary. This is also secondary. So which one is more stable? Secondary first tertiary. In this secondary, two are the secondary means how to decide? Two secondary carbocation, how to decide? So one point I told you, steric hindrance. Steric hindrance is more SN1. First I am saying SN1, later SN2. Steric hindrance is more, reactivity is more. Observe now. Here two bulkier groups are there. C6H5, C6H5, two bulkier groups. That means here more steric hindrance. Here what is there now? Here also steric hindrance is there, but C6H5 and here CH3. Here somewhat less steric hindrance compared to this. How to know, sir? These two are the bulkier groups, C6H5, C6H5. That is called two benzene rings. Here one benzene ring, one methyl. That means somewhat less steric hindrance, here more steric hindrance. More steric hindrance means more reactivity. That's why the second one, 2, 3, 4, 1. So first one is 4. First one is 4. In this 2 and 3, which one highest? 2. Next one is 3. Last one is 1. This which one? SN1 order. SN1 order. So how I decide? Based on intermediate. In these two, which one is more? How I decide? Based on the steric hindrance. Steric hindrance is more. Reactivity is more in case of SN1. Now if you know the SN1, I am asking SN2 order. Exactly reverse. Reverse means which one highest? 1 is highest. Next one 3. Next one 2. Next one is 4. So which are highest, that is the least. Which one is the lowest, that is the highest in case of SN2. Right? This is called as increasing order. Increasing order. Don't get confused. They are asking increasing order, decreasing order. This is increasing order in case of SN1 and SN2. So this is the one of the question. One of the year they ask the question. Right? Next one. This is the information about SN1 and SN2 questions. Okay, right? Next question. Next one. Boiling point order. I want boiling point order. Observe concept I will explain once again. I will remind you. One is bromomethane. Second one is bromoform. Third one is chloromethane. Fourth one is dibromomethane. These are the 4 compounds. Write the increasing order of boiling point. Right? First point. Boiling point totally depends on 3 factors. So 3 different points I am going to say, just I will remind you. Boiling point depends upon molecular mass. So molecular mass increases, boiling point increases. That is the first point. What is the point? Boiling point is directly proportional to molecular mass. Molecular mass means carbon chain increases. Carbon chain increases means automatically carbon chain increases means carbon number increases, atomic number increases. Atomic number increases, atomic mass also increases. Atomic mass increase means total compound molecular mass increases. For example, 1 carbon, 2 carbon, 3 carbon, 4 carbon. So number of carbon atom increases. Number of carbon atom increases, what happened? Carbon means atomic mass will be increases. So atomic mass increases means total molecular mass increases. So molecular mass increases, what about boiling point? Increases. That is the first point. Second point, important point. In case of isomers, what is meant by isomer? So isomers which are in the same molecular formula means compounds which are in the same molecular formula but different structural arrangement or different physical and chemical properties is called isomers, and that property is called as isomerism. Okay, simple isomers means compounds are in the same molecular formula but different structural arrangement, just our understanding point of view. So that time isomers are there, that time boiling point depends upon carbon chain. Boiling point depends upon what? Carbon chain. Carbon chain increases. carbon chain increases. What is increases? This is the carbon chain, this much carbon chain, this much carbon chain. Carbon chain increases, what is increases? This much surface area will be increases. That means carbon chain increases, what is increases? Surface area. Surface area increases, that means boiling point directly proportional to surface area. More surface area is there, it required more boiling point. That means this total surface area you want to cover, it required more temperature. Temperature in terms of boiling point. That means what? Boiling point directly proportional to carbon chain. Carbon chain increases, boiling point increases. Why? Because of surface area increases. Surface area increase means what will increases? VF. What is VF? Van der Waals forces are increases. Why van der Waals forces? For example, 1 carbon, 2 carbon, simple I will write. Carbon, 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 like this. 1 carbon, 2 carbon, 3 carbon. That means carbon chain increases. Carbon chain increase means what happens? Surface area is also increases. Surface area increase means what is increases? Van der Waals force. Why I am saying van der Waals force? Carbon, carbon, what type of interactions will be present? What type of interaction means this carbon, carbon, there is no charge separation. No charge separation means what you call? Non-polar. Non-polar interaction. Non-polar interactions are called induced dipole, induced dipole. Induced dipole, induced dipole interactions. That is induced dipole is called weak force of interaction. That weak force of interaction is called as what you call? Van der Waals force. More van der Waals force, more boiling point. So that's why finally boiling point directly proportional to carbon chain, that is directly proportional to surface area, that is directly proportional to van der Waals force. In case of branching, boiling point inversely proportional to branching. Right? Third point is there. Third point I will tell you in alcohol chapter. That means different functional groups are there. That time I will tell you. Wait. So boiling point increases. Branching increases. Boiling point decreases. Branching increases means what happens? Surface area decreases. This point keep in mind. So based on this I am going to say this one. First one. Bromomethane structure you have to know. Bromomethane structure. CH3Br, that is called bromomethane. Bromoform like a chloroform. CHCl3 is called chloroform. CHBr3 is called bromoform. Next one, chloromethane, that is called CH3Cl. Next one, dibromomethane, that is called CH2Br2. These are the compounds. Right? Based on this I am going to say the boiling point. So these are not isomers. So that's why second point is not applicable for this. First point, molecular mass increases, boiling point increases. This which are highest molecular mass? Carbon, 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 carbon. Only one carbon. So we can't decide now. Decide by halogen. Here one bromine, here 3 bromines, here 2 bromines, here chlorine. First, bromine and chlorine which one highest atomic mass? Bromine. Okay. That bromine which one is the more number of bromines? Second one. So more bromines, more atomic mass. More atomic mass total is more molecular mass. More molecular mass means more boiling point. So second one. Next one. 1, 2, 3, 4 number. So 3 bromines. Next 2 bromines, that is called 4. Next one. Bromine and chlorine, bromine only now. 1. Next one is 2. This is called increasing order of boiling point. Right? This is the question. One of the time they asked. Next one. One bromobutane, first one. Second one is the 2 bromobutane. Third one is 2 bromo 2 methyl propane. These are the compounds. These three compounds, they are what they are asking here, boiling point order, one of the question once again. So, first I am going to draw the structures. 1-bromobutane, butane means first 4 carbons. 1-bromo, first position Br, remaining you have to fill the hydrogens. Next 2-bromobutane, so 2-bromobutane, 4 carbons, second place Br. Now first again propane, 3 carbons first, second position methyl and second position is Br. Observe now, these are all are having how many carbon, check it, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, total 4 carbons, okay. How many bromines? 1, 1, 1, that means all are in the same molecular formula but different structural arrangement. That means this is called, these are called, not this is, these are called isomers. So isomers, how to know? Same molecular formula, there are not, we have to check. Same molecular formula but different arrangement. Those are called isomers. That time boiling point depends on carbon chain. More carbon chain, more boiling point. Now I told now. More branching, less boiling point. Right? Which one is the more carbon chain? This is straight chain. This is also straight chain. But this straight chain is straight chain with 1 bromine, first carbon. Straight chain with 1 bromine, second carbon. That's why this is somewhat branching compared to this. This is a straight chain. So that's why straight chain is more boiling point. So in these two, which one highest? 1 is highest, then 2. Next one is 3. Why 3? Third one is least because of more branching. More branching is there, less boiling point. Why? Because of less surface area. So that's the boiling point order. This is called as what you call decreasing order. Decreasing order. Before I told increasing order. Don't get confused. This is the information about boiling point concept. Now we will do some other points. CH3F, CH3Cl, CH3Br and CH3I. That is what? Alkyl halide, chloride, bromide, iodide and chloride. So write what are the question now? Bond length, bond enthalpy, dm. What is dm? Dipole moment. Dipole moment representation is mu. Bond length, bond enthalpy, dipole moment order. One of the time. This also match the following type question they ask. Bond length. Bond length means the distance between the center of the nucleus to outermost orbit. That is called bond length. Bond length, that is also called the distance between the center of the nucleus to outermost orbit is called atomic size, also called atomic radius, also called length. Right. So here methyl all are same. We can't decide. We can decide by halide ion, fluoride, chloride, bromide, iodide. And this is called group, fluorine, chlorine, bromine, iodine. A group, top to bottom, atomic size will be increases. Atomic size will be increases means what about radius? Radius also increases. Radius increase means what about distance? Distance also increases. That is called length also increases. So which one highest length? Iodine, like this. So iodine, next bromine, next chlorine, next chlorine. Bond enthalpy means bond energy. The amount of energy is required to break the 1 mole of the bond. What is called bond enthalpy? The amount of energy is required to break the 1 mole of the bond is called as bond enthalpy, also called bond energy. So in this fluorine, carbon and fluorine and carbon iodine, which one is required highest bond enthalpy, highest bond energy? This one. Why? Because it is a small size. Small size means what will happen? More attraction. More attraction means we cannot break down very easy. We cannot break down easy means we have to supply more energy than this. We can break very easy because large size. Large size means less attraction. We can break very easy, but it required less energy. It required more energy. So bond enthalpy is reverse order. That means what you can say, bond length and bond enthalpy, which relation? Inversely proportional. Next, dipole moment. Dipole moment, already I told the concept in the chemical bonding chapter. Dipole moment purely depends on electronegativity. Electronegativity. Fluorine, chlorine, bromine, iodine. Which is highest electronegativity? Fluorine. We can expect like this. First, CH3F, CH3Cl, CH3Br and CH3I because of electronegativity. Fluorine, chlorine, bromine, iodine. We can expect like this, but experimental values are showing like this: CH3Cl, CH3F, CH3Br, CH3I. This is the order, exact order of which one? Dipole moment, small x. Small exception, that is exception is based on size only now. That's why this is the order we have to follow. This is the information about what you call bond length, bond enthalpy and dipole moment, right? These are the physical properties related that completed now. Now you have to solve the conversion, some questions now. Previous, these all are previous year say. Now what I asked the question, now still more questions we have to solve. 1,2 dibromo cyclohexane. This is the question. 1,2 dibromo cyclohexane, right? This is reacting with 1 alcoholic KOH, 2 NaNH2, that is called sodamide, 3 Hg2 plus followed by H plus, 4 zinc amalgam followed by HCl, otherwise H plus. They are not given HCl, they are given H plus. H plus is coming from HCl. So this is the conversion. First you should know the structure. This is one of the year they ask the question. 1,2 dibromo cyclohexane structure first. Cyclohexane means ring, cyclic ring. Okay. 1,2, any carbon is 1. Okay. 1,2 dibromo cyclohexane. 1, 2. Sir, why you are consider this one? I can consider. Okay, you can, your choice. 1,2 dibromo cyclohexane. Reacting with what? Alcoholic KOH. What is the use of the alcoholic KOH? Dehydrohalogenation. Dehydrohalogenation means what you call elimination reaction. Elimination means compulsory we should follow on beta elimination. Beta elimination. Observe. In these two carbons, any one is called alpha. Okay, this is alpha. This is what? Beta. This is beta. This also beta. This also beta. Leave it now. Now this is the beta now. Right? Hydrogen atom is eliminated from beta carbon. Hydrogen atom is eliminated from beta carbon. Halogen is eliminated from alpha carbon. So what I can get? Double bond here Br. That means what I removed? Halogen, because here halogen hydrogen will be there compulsory because total tetravalency. Here also hydrogen will be there. Halogen atom is from alpha carbon. Hydrogen atom is from beta. That's why this is called beta elimination. Main role is hydrogen. That is the product. That is first alcoholic KOH. This again reacting with sodamide, NaNH2, not soda lime. Soda lime is NaOH plus CaO. That is called decarboxylation. This is called sodamide, NaNH2. What is the role of this one? Same role. What is the role? Sodamide role is, what is the role of alcoholic KOH? Alcoholic KOH is dehydrohalogenation. Same as NaNH2 also. That means NaNH2 role is dehydrohalogenation. Dehydrohalogenation means same. That is called elimination. Which elimination? Beta elimination. Beta na alpha na beta. Right. So that means this is alpha. Now this is beta. Here one hydrogen will be there. Hydrogen atom is eliminated from beta. Hydrogen atom eliminated from alpha. Then what I can get? Triple bond. Already double bond is there. This is called, that is called alkyne. This is called cyclohexane. X one ion or hexane. Now that is the second one. Reacting with third. Third one is what? Mercury sulfate and H plus. That is the meaning. I told this one. These alkynes reacting with HgSO4 in the presence of Hg coming from HgSO4, mercury sulfate. H plus is coming from H2SO4. That is the meaning. What is the meaning of this? Alkyne compulsory. This is there means adding of water. Adding of water. Sir, your water they are not given, sir. Then how to decide, sir? That's mercury sulfate and H2SO4 only for alkyne, because alkynes are less reactive. alkyl will not dissolve in water. So, want to dissolve means we have to add some external agent, that is what, mercury sulfate and H2SO4. This is their mean, that is the meaning of adding of water. Adding of water means this unsymmetrical alkane is there, then you have to follow Markovnikov rule. So, this is not unsymmetrical alkane, this is symmetrical only. That is why anyone you can add, any side. Then what I can get, observe now, that product I am writing here. Triple bond is there, then one bond I remove, here one OH, here H. Symmetrical. Unsymmetrical is there, follows Markovnikov rule. Negative part will be added to the carbon containing less number of hydrogen. This is symmetrical. Anywhere you can add OH here, H here. Sir, why sir? I will add OH. Okay, you can OH here, OH you have to add, here can add H. Then this is vinyl alcohol. Vinyl is highly unstable, already I told you. That's why it is undergo isomerization. Undergo what? Isomerization. Isomerization means unstable alkene is unstable enol, that is called enol. Double bond means en, OH is called enol. Enol is unstable. Unstable is isomer is converted into stable isomer. That process is called what? Isomerization. Then what happened? This bond come to here. This bond is shifting to like this. That means double bond becomes single bond. This hydrogen will be add. Then what I can get? This one. This is called ketone. What you will get? Ketone. I told already clearly. Alkyne, 2 carbon alkyne with mercury sulfate product is aldehyde. Other than alkyne, that is called other than ethine. Any ethine is there. Other than ethine, any ethine with mercury sulfate you will get D, ketone, direct ketone, right? Ketone. Now this is the third one. First one, second one, third one completed. Fourth one. Zinc followed by mercury in the presence of H plus acid HCl. This is called, what is the reaction? Zinc amalgam in the presence of concentrated HCl is called Clemmensen reduction. Clemmensen reduction. Clemmensen reduction means what happened? Carbonyl compounds are converted into alkanes. Clemmensen reduction. There only name reduction. What is the meaning of reduction? Removal of oxygen, addition of hydrogen. So you have to remove oxygen. How many? Oxygen you have to remove means how many bonds you have to remove? 2 bonds. 2 bonds means total how many hydrogens you have to add? 2 hydrogens you have to add. The 2 hydrogens I added now. That hydrogens is supplied by H plus. That H plus is coming from acid. Then what is the final product? Benzene. That is not benzene. Cyclohexane. That is the answer. This is the conversion. Right? Next one. CH3 CH2 Cl reacting with NaCN X, nickel followed by H2 Y, then acetic anhydride, that is Z. What is XYZ? Next question. Tolling reacting with first one Cl2 followed by heating, second one Cn, that means KCN, third one hydrolysis H2O followed by H plus. That is the question. Next question. Br bromobenzene with SO3 H2SO4, that is X. Br2Fe, that is called Y. So first these three, later will remaining. Any other is there? First one, CH3Cl reacting with NaCN or KCN, that means K plus and CN, that is called ionic form. So Cl is replaced by Cn, that means halide ion replaced by nucleophile replaced by another nucleophile, that is called what? Nucleophilic substitution reaction. And what I can get? CH3, CH2, C triple bond N, that is X. Reacting with nickel with hydrogen, so that is called catalytic hydrogenation, that is also called reduction. Strong reducing agent, this is called strong reducing agent. So then what happened? Reduction means, so CH3, CH2, C triple bond, CH2, NH2. That means that bonds are removed by adding up hydrogen. That means nitrile is converted to amine. Nitrile is converted to amine. Which amine? Primary amine. That is called reduction. What happened from to this to this? Adding up hydrogen. This is called reduction. What do you call? Reduction. Reduction means this is called oxidizing agent. From here to what happened? Reduction. Addition of hydrogen, that is called reduction. The reduction is done by catalyst, that is called catalytic hydrogenation, adding of hydrogen. So reduction, which is undergo reduction? Nitrile undergo reduction. This is called oxidizing agent. This oxidizing agent means what about this one? Reducing agent, that is called strong reducing agent. Then followed by what? Acetic anhydride. Anhydride structure you have to know. CH3, C double bond O, O, C double bond O, CH. This is called acetic anhydride. Anhydride, C double bond O, O, C double bond. That is called anhydride. Then what I have to do? In this anhydride is there. Any side you can break the bond. Your choice. This side or this side. Between oxygen and carbonyl. So I broken this bond this side only now. Right. Then what happened? CH3, C double bond O, O with H. That is the byproduct. CH3, C double bond O, O with H, that is called acetic acid byproduct. Remaining we have to add. Combine. CH3, CH2, CH2, what is there here? NH. Remaining what is there now? C double bond O, CH3. This is called amide. Which amide? Secondary amide. Amide. That is the product. Now, next one. Toluene. Reacting with the chlorine. This is not there. That is not there means, then what is undergo? It undergo electrophilic substitution reaction. Yesterday I told. But here heating is there. What I told? That is called condition. Sunlight, heat means high temperature, peroxide, UV, anyone is there, that is called condition. This condition is there. Undergo what? Condition is there means bond is breaking, homolytic. That is called substitution, that is called free radical substitution reaction. And what I can get? First one, benzene, CH2Cl. So one of the hydrogen replaced by Cl, that is means that is called free radical substitution. Then followed by KCN. This one anyway you know. CH2, C triple bond N. Then followed by what? Third one, hydrolysis. Yesterday I told you clearly. Cyanide and hydrolysis directly converted to acid. But 3 bonds you have to break down, 3 water molecules you have to add. So byproduct is ammonia. So answer is CH2 is converted to COOH. Byproduct is ammonia. That is the product. Next one. This one. Bromine means bromobenzene. This what it is the meaning of? This is called sulfonation. What do you call? Sulfonation. Sulfonation means what is electrophile? SO3. So actually electrophile is SO3 plus R. So electrophile is positive, correct. But here in case of sulfonation, electrophile is SO3. That is called neutral electrophile. There is no charge. Neutral electrophile. So sometimes they will give you, instead of this H2SO4 they will give you. Otherwise sometimes they will give you mixture of H2SO4 plus SO3, that is called H2, S2, O7, H2, 2S2, O4 and O3, O7. This is called as oleum. Sometimes they will give the oleum. That is also same. Oleum they are giving me, that oleum is mixture of SO3 and H2SO4. That is the meaning of sulfonation A. So what I can get here, benzene is there, okay. Benzene is there, that means bromobenzene is there. This bromobenzene is, this group will be decided incoming electrophile where will attack. Br is, in case of inductive effect is minus I, in case of mesomeric effect is plus M, means electron releasing and electron withdrawing. So which one is dominating factor? Plus M is than minus I. That means electron releasing group present on the benzene ring. Incoming electrophile attacks at which position? Ortho and para. Yesterday I told. So that's why it is called para-bromo benzene sulfonic acid. Otherwise ortho also will get it to ortho-bromo benzene sulfonic acid. But here major product I want para-bromo benzene sulfonic acid. This is treated with what? Br2 and Fe. Br2 and Fe. Now two groups are there. That means this also what is called halogenation. Two groups are there. The two groups are there. Which group will be decided? Incoming electrophile. Which one is the strong activating group is there in case of these two? Which one is strong activating group is there? SO3H or Br? What is that now? Br is the activating group than SO3H. SO3 is the strong electron withdrawing group. This is activating group, that means weakly activating group. This group will be decided incoming electrophile. So incoming electrophile will attack Br, SO3H. Where will attack? Ortho and para. So this is ortho, this is meta, this is para. Already para is there. So chance is there, ortho. So answer is Br here. This is the answer for this compound. Right? Okay, ma. Today I will stop. Tomorrow I will continue remaining other topic. Okay. Thank you.
So good morning students. Yesterday we are done the discussion related to this respiration in plants part. We have done with relation to glycolysis, Krebs cycle and electron transport system. In brief to say, first glucose is the most favored respiratory substrate. In the glycolysis part, the product is going to be the pyruvic acid. During this conversion, it is releasing 2 ATP molecules. Along with that, it is releasing 2 NADH molecules. So, NADPH generally we can see in the photosynthesis, NADH we can see in the respiratory part. So, the products of this glycolysis is 2 molecules of pyruvic acid, 2 NADH and 2 ATP. Now, this pyruvic acid from the cytoplasm, it is now entering into mitochondria. In the mitochondria, it undergo a reaction called as link reaction, so that it is going to form a 2-carbon compound, that is acetyl coenzyme A. Acetyl coenzyme A is a 2-carbon compound. This is a 3-carbon compound and glucose is a 6-carbon compound. Now, this acetyl coenzyme A going to enter into the next cycle, and one more thing before saying that pyruvic acid going to form acetyl coenzyme A, there is a releasing of 2 NADH by the releasing of carbon dioxide. As we are considering one pyruvic acid, I am saying these calculations now. Whereas, if we consider for the 2 pyruvic acids, 2 carbon dioxides are released, here 4 NADH is released. Now, from here this acetyl coenzyme A, not 4, here is going to be the 2 NADH. 2 NADH is released for each one for 1 pyruvic acid. Now, this acetyl coenzyme A entering into the Krebs cycle, here there is releasing of 2 NADH, and from alpha ketoglutaric acid to succinyl coenzyme A, it is going to release 2 NADH. From succinyl coenzyme A to succinic acid, it will release GTP, later converted into ATP. Later on, this here there is a synthesis of 2 FADH2 from succinic acid to fumaric acid. Fumaric acid is converted into malic acid. Malic acid is converted into oxaloacetic acid. Here also there is a releasing of 2 NADH. So, totally output you take, how many number of NADH will be synthesized from one glucose molecule. So, 2 plus 2 4 plus 2 6 8, total 10. 10 NADH will be synthesized. Whereas FADH, how many FADH will be synthesized? 2 FADH. How many ATP are directly synthesized in this particular scenario? Here 2 and here 2, total 4 ATP. Suppose the question come, how many ATP synthesized directly? Just like that, we can say it as 6. Why? Because here 4 are synthesized, here 2 synthesized, totally we can say it as 6. But if they ask you final net production of ATP, we can consider it as 4 ATP. And there is a specific reaction I told you, substrate level phosphorylation is there. Now, by saying this entire process, let we consider this in the electron transport system. In the electron transport system, 1 NADH going to produce, yesterday we have discussed 3 ATP, and 1 FADH will produce total in the case of 2 ATP. So, that is the thing. Now, with this if you consider 10 into 3, total how many ATP? 30 ATP will be synthesized, whereas FADH 2 into 2 equals to 4 ATP will be synthesized, and already 4 ATP is there. Total how many ATP are synthesized? 38 ATP will be synthesized. I have said you earlier itself, one glucose molecule going to synthesize 38 ATP molecules. So, this in the form of a balance sheet if you consider, respiratory balance sheet if you consider. So, it is going to be like this, table we can draw. In this first process, direct ATP synthesis, next ATP from NADH, next ATP from FADH, next ATP which are utilized in the process. After that, total, how many are synthesized. So the balance sheet, 3 processes are there here. One is a glycolysis, another one is a Krebs cycle, another one is link reaction. Okay. So glycolysis is the first pathway, link reaction, and third one is going to be the Krebs cycle. Now if you observe, glycolysis, how many ATP are directly synthesized? 4. That is the question. How many ATP are synthesized in the glycolysis directly or through the substrate level phosphorylation are the 4. And how many ATP which are produced from NADH? If you observe here, how many NADH produced? 2 NADH. So 2 NADH are produced in case of glycolysis. Each NADH can form 3 ATP. So totally how many ATP? 6 ATP will be synthesized in the glycolysis from the NADH part. Next, ATP from FADH. There is no ATP synthesis, it is not applicable here, 0. And how many ATP are synthesized in this glycolysis, utilized in this glycolysis part? 2. What is that reaction? Glucose to glucose 6 phosphate and fructose 6 phosphate to fructose 1, 6 phosphate. These 2 reactions where ATP utilization happens, 2 ATP will be synthesized. So totally 4 plus 6, 10, 10 minus 2, 8. So how many ATP are synthesized by total glycolysis process? It is going to be 8. Based on the question, the number differs. Carefully you have to go through the question. Next, link reaction. What is link reaction? Pyruvic acid after entry into mitochondria, there is a formation of acetyl coenzyme A which is entering into Krebs cycle. The formation of this entire process we can call it as a link reaction. But this link reaction happens in the mitochondria. Do you remember the enzyme? Pyruvate dehydrogenase, and it requires magnesium cations. Along with that, it requires the coenzyme A, and also it requires the NAD+. 3 cofactors are required. Yesterday we have discussed. Sorry. This link reaction, is there any direct ATP synthesis focus here? No, 0. How many ATP from NADH? How many NADH synthesized? 2 NADH into each can form 3 ATP. So totally 6 ATP will be synthesized directly from here in the link reaction. Next, any FADH synthesized? No. Any ATP utilized? No. So total link reaction product is 6. That is the thing. Next, Krebs cycle. The Krebs cycle, direct ATP synthesis of the Krebs cycle. Any is there? Any is there? You can observe here, there is one place substrate level phosphorylation. Do you remember that reaction? Succinyl coenzyme A converted into succinic acid. There is a formation of this 2 ATP. Actually it is GTP, later converted into ATP part. Now, this Krebs cycle direct ATP synthesis R2. Remember, we are considering these numbers based on one glucose molecule. Next, ATP from NADH. How many NADH produced in this Krebs cycle? 2, 4, 6. So 6 into 3. 6 NADH produced, each can form 3 ATP. Totally 18 ATP will be formed. And ATP from FADH. How many FADH? 2 FADH. 2 into 3 or 2 into 2? It is going to be 2 into 2 ATP. So ultimately 4 ATP will be synthesized. 2 FADH produced, each can form 2 ATP. I have already mentioned here. Next, Krebs cycle, any ATP utilization? No. So totally combine it, 18, 2 plus 18, it is going to 20, 20 plus 4, 24. 24. Now, total process, how many direct ATP synthesis? 4 plus 2, 6. How many ATP synthesized from NADH in the total process? 6 plus 6, 12, 12 plus 18, 30. Next, How many ATP totally synthesized from FADH? It is going to be 4. How many ATP utilized in the entire process? 2. It is minus 2. So if you count from in this direction or in this direction, number will be same. Let me see. 8 plus 6 is going to be 14. 14 plus 24, it is going to be 38. And here 6 plus 30, 36. 36 plus 4, 40. 40 minus 2, 38. So this is the respiratory balance sheet. Everyone has to remember this entire as it is. Many different kinds of question we can expect from this particular area. Next, after saying this, differences between aerobic respiration and fermentation or anaerobic respiration. Aerobic respiration is a partial complete breakdown. Aerobic respiration is a complete breakdown process. Complete breakdown process, whereas it is a partial breakdown and it releases large number of ATP, whereas here only 2 ATP will be synthesized. How come that 2 ATP? I told you in the fermentation concept, less than 7% of energy is released in the fermentation, as there are 2 NADH produced in glycolysis which are subsequently used in the fermentation process. So only 2 ATP are synthesized in this fermentation, whether it be a lactic acid fermentation or it may be a alcohol fermentation. Next, large number of ATP in the aerobic respiration means just now we have seen 38 ATP will be synthesized from one glucose molecule. Next, after saying this, there is NADH breakdown of NADH is very rapid, vigorously going to happen. In this, the rate of breakdown of NADH or oxidation of this NADH is very slow. And aerobic respiration generally occurs in the eukaryotes, which are multicellular eukaryotes, whereas fermentation occurs in unicellular eukaryotes and prokaryotes generally. Prokaryotes and unicellular eukaryotes. Do you remember the example? Yeast, which is Saccharomyces cerevisiae, belongs to Ascomycetes. That is a part. So this is the differences between aerobic respiration and fermentation procedure. And after saying this, the last another concept which is remaining is amphibolic pathway. Where should I write it? I will write it here by erasing that. Amphibolic pathway. So you might have heard about this particular word called as metabolism. Metabolism means total reactions which are happening in the body, we can consider in the name of metabolism. That metabolism is of two types. One is a construction process, another one is a destructive process. So metabolism one is a catabolism, another one is anabolism. So construction process is anabolism, destructive process is called as catabolism. Generally, respiration in common way we are considering it as a catabolism, which is a breakdown process or oxidative process to release the energy. But there is another name for this respiration, it is an amphibolic pathway. Respiration is an amphibolic pathway. How come? How come this is an amphibolic pathway? Let me consider the first respiratory, most favored respiratory substrate as carbohydrates. Carbohydrates are the most favored respiratory substrate. Any kind of carbohydrate, there are simple carbohydrates are there, complex carbohydrates are there. Any kind of carbohydrate first converted into simple sugars. Simple sugar, there are many kinds of simple sugars are there, glucose, fructose, different things are there. For example, most of them are undergoing the glucose. The point here everyone has to remember is the glucose is a compound which can enter into the respiratory pathway from the first step. From the first step it is going to enter. This glucose undergo glycolysis. There are many intermediates are there, glucose 6-phosphate, fructose 1,6 bisphosphate. Later it was broken down into DHAP and G3P, which is also called as this PGAL, phosphoglyceraldehyde, PGAL or G3P. this G3P will enter into next further reaction forming the pyruvic acid. Pyruvic acid is converted into acetyl coenzyme A in the link reaction and it is undergoing Krebs cycle. Later on it is undergoing ETS also, which is going to release the water and it is going to absorb this oxygen and everything, and it is releasing carbon dioxide also. Now, other than carbohydrates, any other respiratory substrates are there. We can consider the fats. Fats also acts as the respiratory substrates. These fats will, before entering into respiratory pathway, they are break down into fatty acids and the glycerol. Remember one thing, the respiratory substrate which is entering into the process of respiration from the step 1, that is going to be the glucose. Whereas fats and even if you consider the proteins, they are entering not from the first step. They cannot enter the first step of the respiratory pathway. So, fats will be broken down into fatty acids and the glycerol. But this glycerol cannot enter at the first step, it is entering at the step of the DHAP. In the textbook diagram they have shown glycerol is entering into DHAP at this step, from this step it is entering. But in the textbook statements they have mentioned that glycerol will be converted into PGAL. Because there is a logic you have to remember, both of these are isomers. This can become that can become this, isomers. So, simultaneously we can use this. So, glycerol will be entering into the respiratory pathway by entering at the step of DHAP or G3P, even PGAL. Next, fatty acids will enter at the respiratory pathway from the step of acetyl coenzyme A. Next, this protein directly cannot enter, it will be broken down by the enzyme protease. By the enzyme protease, it will be broken down to release the individual amino acids. These amino acids undergo next process called as deamination. Removal of the amino group. After removal of amino group, carboxylic group will be there. Based on the structure of this, it will enter at so many other steps. It may enter at the step of pyruvic acid, it may enter at the step of acetyl coenzyme A, or it may enter some stages within the Krebs cycle. Textbook statement. So, pyruvic acids, proteins are broken down into individual amino acids by the process of protease enzyme action, and these amino acids, after undergoing deamination, that means the removal of amino group, they are entering at the different stages of this respiratory pathway based on their chemical nature. Some are entering at pyruvic acid, some are entering at acetyl coenzyme A, even some are entering at some stage of the Krebs cycle. Now, this is going to be the catabolism, breakdown process. All fats, proteins, carbohydrates, all are going to get broken down in this entire process. But now the reverse can also be possible. Suppose the body is running out of fatty acid, body requires fatty acids, but the storage was not there. Then what the body do? In this particular pathway which is going on to break down, the acetyl coenzyme A will be withdrawn for the synthesis of fatty acid. When the body wants to synthesize the fatty acid, acetyl coenzyme A will be withdrawn and will be synthesized, used for the synthesis of fatty acids. Similar, if glycerols are needed, PGAL, DHAP or G3P will be removed and will be useful for the synthesis of glycerol. Next, after saying this, even if the body wants the proteins, what it can do? It can remove either pyruvic acid, acetyl coenzyme A or some element which is present in the Krebs cycle useful for the synthesis of amino acid. Later it can be formed as what? Protein. So, this direction, if you consider this direction, this is synthesis process, we can call it as a anabolism. We can consider it as anabolism. So, breakdown process and also construction process. This respiratory pathway is undergoing, it can undergo both catabolism and also anabolism. We can consider it ultimately as amphibolic pathway. Here how can we expect the questions? DHAP is becoming what? Is entering into which stage? How it is becoming? And there is a common question, what is a common respiratory substrate for all these three types of respiration? What is a common intermediate for all these three types of respiratory substrates? So, remember acetyl coenzyme A is a common intermediate compound for all these three respiratory substrates, like even fats, carbohydrates or the proteins, all of them are passing through what acetyl coenzyme A, but remaining are not the common compounds. Pyruvic acid is common for carbohydrate and protein, but not for the fatty acids. That is the logic here. And the last concept in this chapter will be discussed in the name of respiratory quotient. So this respiratory quotient is a value. So RQ, ultimately what we can say, RQ is a volume of carbon dioxide released, evolved by volume of oxygen utilized or consumed. RQ is volume of carbon dioxide evolved by volume of oxygen consumed. This is going to be called as respiratory quotient. Generally students confuse us, they will exchange these words or they will exchange these gases. Numerator become denominator, denominator will become numerator. There you have to very careful. So numerator will be volume of carbon dioxide evolved by volume of oxygen consumed. This is called as respiratory quotient. Respiratory quotient. See this RQ value, there is an assertion. RQ value varies with the different kinds of respiratory substrates. Yes, it is correct. How can we say? If the respiratory substrates are carbohydrates, its RQ value is 1. For carbohydrates, RQ value will be 1. Whereas for fats, it is less than 1. For example, there is a fatty acid, tripalmitin, they had given the example. Tripalmitin is a kind of fatty acid. Its RQ value is 0.7. Next, proteins, the RQ value will be, it is also less than 1, we can consider it as 0.9. And the last final, it is not mentioned in the textbook, organic acids. So I told you most favored respiratory substrates are carbohydrates, second most favored fats, third one is protein, and the last one, which is least considered in special situations only in the plants, that is organic acids. Malic acid, aspartic acid, oxaloacetic acid, fumaric acid, succinic acid, alpha ketoglutarate acid, citric acid, all these are acids which are organic acids. Their RQ value will be more than 1. Their RQ value will be more than 1, greater than 1. Its RQ value is less than 1. That is the logic. So this is all about the respiratory pathway. There are some important points we have to keep remembering on. First thing, how many ATP are synthesized from one glucose molecule? That is 38. So this breakdown process occurring in a single step? No, it is occurring in a series of small stepwise reactions. And how many steps are there in the glycolysis? 10 steps are there. Name the first enzyme present in the glycolysis. That is going to be the hexokinase. And name the enzymes involved in alcohol fermentation. First, there is a formation of acetaldehyde which is done by the pyruvate decarboxylase and alcohol dehydrogenase. Whereas lactic acid fermentation process, the enzyme is lactate dehydrogenase. And most common question, many students confuse also, carbon dioxide is a product of fermentation in case of dash. Which fermentation procedure? It is going to be lactic acid or it is going to be alcohol. What? It is going to be alcohol, formation of the alcohol. Remember, pyruvic acid contains 3 carbons. Ethyl alcohol contains 2 carbons. 1 carbon dioxide has to be removed. That is the logic. And in fermentation, who is the reducing agent? The reducing agent will be NADH. How much of energy will be released from glucose during the alcohol fermentation or lactic acid fermentation? It is only 2 ATP. We can consider it as less than 13%. Yeast poison itself to death when alcohol concentration reaches up to 13%. And these numbers you have to keep in mind. These are the basic things. And name the enzyme involved in pyruvate, or do you say link reaction? The enzyme involved in link reaction is going to be the pyruvate dehydrogenase. I told you yesterday alcohol fermentation is done by pyruvate decarboxylase, whereas in the link reaction the enzyme is going to be pyruvate dehydrogenase. Keep in mind. And then after saying this, let me go for the next chapter, that is in the physiology concept itself, plant growth and development. This plant growth and development concept, there are many discussions to have in this. To be simple to start, first there is a concept called development. What is meant by development? Development is the sum of growth and differentiation. Development is the sum of growth and differentiation. Now, in this chapter, first we are going to discuss the details about the growth. Later on at the end, we are going to see the details about the differentiation. But what we can say, development is the development, growth, differentiation. These three are very closely related terms in case of the plant world. And you can see a diagram that is the first seed, seedling, plantlet and the mature plant. This is the pattern of development. Seed, seedling, plantlet and the mature plant. Sorry. Let me go one by one. First one, discussion related to growth. All the aspects of the growth we have to discuss here. So, what is a growth? Growth is an irreversible permanent increase in the size. Irreversible permanent increase in the size of an organism or size of a part, we can consider it as a growth. It is an irreversible thing. Now, this is accompanied by expenditure of energy, we can call it as metabolism. Metabolism. It is accompanied by both catabolism and also anabolism, occurs with the expenditure of energy. And this growth in the plants occur in specialized regions, we can call it as a localized growth. At the same time, the growth of a wood when placed in water. Growth of wood when placed in water, is it considered as a growth? Increase in size. So, suppose a piece of wood was placed in water, after some time size of the wood will be increased. It cannot be considered as growth because that is a reversible increase. So, that is not considered as a growth. Any process to consider it as a growth, it should be irreversible permanent increase in the size of an organ. Then next point to say growth of the plant. So, plant growth is indeterminate. Plant growth is indeterminate. Indeterminate. What do you mean by this? So, in the plants, the growth is of two types. One is going to be the primary growth, another one is going to be the secondary growth. One is primary growth, another one is going to be the secondary growth. What is meant by this primary growth? Primary growth is increase in the length of the organism. Increase in the length of an axis is called as primary, whereas increase in the girth, horizontal increase, that is going to be considered as secondary growth. And the primary growth is done by the meristems which are present from the beginning of the plant life. We can call them as a primary meristems. Whereas secondary growth is done by which meristems? Secondary meristems. One is a primary meristem, another one is a secondary meristems. Then these primary meristems, examples of this, One is apical meristems like as a shoot apical and root apical meristems, and intercalary meristems are there. Intercalary meristems, primary and apical and intercalary meristems are there, whereas secondary meristems example lateral meristems. See, these lateral meristems are not found in the earlier stage of the plant body, these are formed in the later stages. We can consider them as secondary meristems. And secondary meristems contribute to increase in the girth of the plant, primary meristems contribute to increase in the length of the plant. With the small diagram, let we understand this. Suppose this is the plant body, imaginary plant body, this is the soil level, so that we can consider it as a root, and above part we can consider it as a shoot. Now, at the tip of the shoot, meristems will be there, that is going to be called as a SAM, shoot apical meristem, and at the base we can see the meristems are there, those are called as RAM. RAM will be called as root apical meristems. Both are going to add the cells to increase the length of the organism. That's why those are apical meristems, primary meristems increase in the length. In the middle, intercalary meristem is also there. Intercalary meristem is also there. Between node to node, internode part contains this intercalary meristem. It also helps in increase in the length of the plant. Then after that, there are secondary meristems. Secondary meristems that contribute to increase in the girth of the plant body. These meristems are going to be called as vascular cambium and the cork cambium. So, example for the lateral meristems, vascular cambium and cork cambium. Vascular cambium and cork cambium are the two meristems which helps in the girth of the plant body, increase in the girth of the plant body. And these primary growth can be found in all plants, but secondary growth is found in only dicotyledons and gymnosperms. So, the statement will be like this, secondary growth we can observe in all angiosperms. No, false. Angiosperms are having monocots and dicots. Monocots cannot undergo secondary growth. In the chapter anatomy again we are going to discuss this. So, secondary growth is a possibility of only dicotyledons and the gymnosperms, not possible in case of the monocotyledons. Primary growth is found in all plants, which we can observe. Next, these primary growth, because of this presence of these meristems at certain locations, plant growth is a continuous process. We can consider it as an open form of growth. Open form of growth. What do you understand by open form of growth? New cells are always being added. That's why plant growth is an open form, and it is indeterminate. It is go on increasing again and again, over and again. So, this is the information related to primary and the secondary growth, and plant growth is indeterminate. Remember, secondary growth occurs in only dicotyledons and the gymnosperms. Very important. Next, after saying that plant growth is measurable. Growth is measurable. How come? So, this growth at the level of a cell, cellular level, growth at the cellular level leads to increase in the amount of protoplasm. Increase in amount of protoplasm. Growth at the cellular level is increase in the amount of what? Protoplasm. See, this increase in the protoplasm which is difficult to measure, which is very difficult to measure. As it is difficult to measure, we are considering this in another perspective, which are parallel to the amount of increase in the protoplasm. The parallel methods is increase in fresh weight, dry weight, increase in cell number, increase in the length, increase in the area, increase in the volume, etc. So, the point is very clear, growth can be measurable, but it is not directly. Growth at the cellular level is increase in the amount of protoplasm, which is difficult to measure. So first everyone has to remember what is protoplasm. A cell which is covered by cell wall, cell membrane, having cytoplasm and cell organelles, it is a complete cell. If you remove the cell wall, after that what is remaining? Cell membrane, cytoplasm and the cell organelles, it is going to be called as a protoplast without the cell wall. Then if you remove the cell membrane also, cytoplasm, cell organelles, combinedly we can consider it as what? Protoplasm. When the cell was growing, there is an increase in the amount of protoplasm, which is not easy to measure. That is why we are using another methods which are parallel to this. That is increase in the fresh weight, increase in dry weight, increase in number, increase in length and increase in the area. Even you can consider value. Suppose for increase in the number, that given the number 17,500 new cells are formed per hour by single root apical meristem of maize. Single root apical meristem of maize can produce 17,500 new cells within 1 hour. This we can consider increase in the number. Whereas increase in the size, watermelon cells, the cells of the watermelon can increase their size 3,50,000 times. 3,50,000 times in their entire lifespan. So they can increase the size. Next, after that, length. Length we can take the example, the growth of a pollen tube. Where we can see this pollen tube? Pollen tube growth we can see on the stigma. When the pollen grain is compatible, the stigma accepts it and pollen tube will come out of the walls of the pollen grain and will grow through the stigma style and reaches the ovary and enter into ovule into the embryo sac. Now, a small question. Which layer helps in the formation of the pollen tube? Layer I mean by, it is intine. And the exine, what is the role of exine? Exine at some places sporopollenin is absent, that gaps are called as germ pores. Through the germ pores this pollen tube will be grown. Okay. Next, after that increase in the area increase example is going to be the increase in the dorsiventral leaf, surface area of the dorsiventral leaf. Remember dorsiventral leaf means dicot leaf. Dicot leaf is having another name, a broad leaf. It is a broad leaf. So generally it is like this, it is going to extend like this. Area, surface area of the leaf will be increased. That is, you can say the increase in the area. Whereas monocot leaf does not much increase in the surface area, it increases the length. Remember that. So these are the examples. Here in this area we have seen previous year questions. This is an important area. 17,500 new cells per 1 hour, not 1 year. 1 hour from the maize, single maize root apical meristem. Remember this logic. So this is plant growth is measurable. Plant growth is measurable. Next, after saying that, the next concept is phases of growth. Phases of growth. There are different phases are there. Let me draw the diagram. I am taking the example as a root, the growing root as an example to understand this particular thing. At the root, as in the morphology chapter, there are 3 reasons are there. First, reason of meristematic activity. We can call it as a meristematic phase. Next, reason of elongation. We can call this phase as a phase of elongation. And the third one is a phase of maturation. So 3 phases of the cell is there. The cell which is present in meristematic stage. The cell is small and the cell wall is thin. Actually the cell wall we can consider it as a primary. Cell wall is primary means what? It is thin, made up of cellulose and having abundant plasmodesmatal connections. Abundant plasmodesmatal connections are there. So the cells are small and the cell wall is a primary in nature. That means what is meant by primary cell wall? The cell wall is thin and made up of cellulose having abundant plasmodesmatal connections. What do you understand by plasmodesmatal connections, ma? These are the connections between one cell wall, one cell to another cell in case of the plants. Whereas in the animals, intercellular junctions are there. These plasmodesmatal connections are formed by the middle lamella and the cell wall. This part we can see in the cell the unit of life chapter, ma, and it is the connections of the cytoplasm. These plasmodesmatal, another way also we have seen these plasmodesmatal connections. In case of the C4 plants, bundle sheath cell and the mesophyll cell are connected by plasmodesmatal connections. That is the thing. And cell wall is primary, means there are two types of cell wall is there, ma, primary cell wall and the secondary cell wall. First formed cell wall which is capable of growth, that is the primary. Later formed cell wall we can call it as a secondary cell wall, and the secondary cell wall was unable to grow. Next. And these are having abundant protoplasm. Large amount of the protoplasm is there with conspicuous nuclei. Conspicuous nuclei, clearly visible nucleus will be there, ma. Abundant protoplasm, clearly visible nucleus, thin cell wall having plasmodesmatal connections, and the size is small, and the main function of this particular what do you say, phase, ma, cell division. Cell division. The moment you have seen the word meristem, you have to remember it is belongs to cell division. Next, the phase of elongation. In this phase, ma, increased vacuolation. Increased vacuolation. What is meant by increased vacuolation? Because of entry of water into the vacuole, the size of the vacuole will be increased and also number of the vacuole will be increased. Because of this increase in size and also number of the vacuole, the cell will undergo enlargement. Cell enlargement and cell elongation. Cell enlargement and cell elongation going to happen during the phase of elongation. And at the same time here, new cell wall deposition. New cell wall deposition is there, ma. So, cell elongation, cell enlargement, new cell wall deposition are the characteristics of phase of elongation, and this phase is proximal to the meristematic phase. Remember, ma, the proximal and distal. Proximal means basal part. Proximal means basal. Distal means tip part. Distal is tip part. So, region of elongation is proximal to meristematic. More proximal to meristematic, who is there, ma? Maturation. And this phase is near to the stem. It is related to the regions of root. I am covering both, ma. But the phases are meristematic phase, elongation phase and the maturation phase. In the maturation phase, cell will undergo maximal development. Cell will undergo maximal development in terms of cell wall, and protoplasmic modifications. Protoplasmic modifications. So, if you observe, ma, cell wall is very primary and thin in case of the meristematic phase. New cell wall deposition happening in the elongation phase. The cell wall deposition was completed. Completely secondary cell was formed in case of the meristematic phase. Sorry, maturation phase. In this maturation phase, cell will undergo maximum development in case of the cell wall and also with the protoplasmic modifications. That is the thing. So, these are the three phases of the growth, ma. And there is a technique, ma, in the textbook you can see there is a bean seed diagram they are placing here. This is the earlier bean seed, later after some time it was grown like this. And they are saying that the regions, ma, this is A, B, C, D, F like that. These are the regions cell is undergoing the elongation. This technique is called as a parallel line technique. Parallel line technique. Parallel line technique to observe the phases of elongation. That is the thing. So, this is growth. Growth is indeterminate, growth is measurable, and these are the phases of the growth. Let we enter into the next concept of discussion, ma, that is growth rates. So what is mean by this? Growth rates. So growth rate means increased growth per unit time. Increased growth per unit time. We can consider it as a growth rate. But this growth rate, there are two particular dimensions are there. In detail, let we discuss. One is qualitative comparison. Qualitative comparison. And the next one is going to be the quantitative comparison. Qualitative and the quantitative. In this qualitative mode of growth rate, the growth rate comparison, there are two particular comparisons you can see. One is the arithmetic growth rate. Arithmetic growth rate. Another one is the geometric growth rate. Geometric growth rate. One is geometric growth rate, another one is the arithmetic growth rate. So this arithmetic growth rate means what? Following the mitotic cell division. Suppose this is a cell, meristematic cell undergoing the cell division. Following the mitotic cell division, two cells are formed. Among these two cells, one cell cannot able to divide. One cell cannot able to divide. It will become differentiate and it will become mature. Differentiate and mature. The another cell will be still meristematic. It can divide and it can form two new cells. This cell is already like that. So the definition of the arithmetic growth rate, following mitotic cell division, only one cell continue to divide, another cell stops dividing, it will differentiate and mature. So that the growth is constant, 1 will become 2, 2 will become 3, 3 will become 4, like that. Whereas in the geometric growth rate, following the mitotic cell division, the two cells retain the capacity to divide, so that the growth will be very rapid. Initially it may be slow, but later on it will be very rapid. So that it will become 1, 2, 4, 8, 10, like that. The growth will be very rapid in case of the geometric growth rate. Initially the growth is slow, later on it is very fast in case of geometric. Constant growth rate we can see in the arithmetic growth rate. So this arithmetic growth rate graph, if you observe, we can take the height of the plant against the time factor t. So 1, 2, 3, 4, 5, like that. The growth is a linear curve. The curve what we can observe in case of the arithmetic growth rate is linear. And the example what we can say, root elongation. Root elongation at constant rate. Root elongation at constant rate, it is there. The formula here is equals to LT equals to L naught plus RT. LT equals to L naught plus RT. What is mean by LT? LT is equals to length at time t. Length at time t. This is length at time 0 and it is a growth rate. R means the growth rate and t is going to be the time t. So following the mitotic cell division, only one cell continue to divide, another cell stop dividing, become differentiate and mature in case of the arithmetic growth rate. And the formula here is LT equals to L naught plus RT, and the consideration here example root elongation at the constant rate, and the graph if you observe time is there on the x axis, it is compared with the y axis height of the plant. For example here length we are taking, height of the plant. So the graph what we are getting, the curve is going to be the linear curve because of the growth is a constant rate of growth is there. Next, if you consider this and comparison with the growth rate, which is a geometric growth rate, following the mitotic cell division, both cells continue to divide. So that we can take the example living organisms which are growing in natural environment. Living organisms growing in the natural environment. That is example for this growth rate. And the tree showing the seasonal activities also we can consider in the geometric growth rate. And the curve if you consider, On the x-axis we are taking time, on the y-axis we are going to take the size of the organelle, So if you consider this, initially the growth was very slow. We call it as a lag phase. Slow growth phase, we can call it as a lag phase. This lag phase later on undergo rapid growth. This rapid growth rate we call it as a log phase or exponential phase. Log or the exponential phase we can see here. Later on, because of the limited nutrient supply, it is not going to further increase. We can consider as a stationary phase. So, in the geometric growth rate, there are three phases of growth is there. Starting initial slow growth rate, we call it as a lag phase. Later rapid growth phase is there, we can call it as a log or exponential phase. And the final, because of limited nutrient supply, the stationary phase will be arised. So, which is the fastest growth phase? That is a log phase. Slowest growth phase, that is the lag phase. Which phase arised because of limited nutrient supply? That is going to be the stationary phase. And the formula here is W0 equals to W1 equals to W0 e power RT. W1 is equals to W0 e power RT. What is meant by W1? W1 is a final size. Then W1 is the initial size. It is a natural logarithm, and R is having so much of importance here. The R here is, we can consider in a different perspectives. One is going to be the growth rate, also considered as relative growth rate, and also we can consider it as a efficiency index. What is meant by efficiency index? It is a measurement of plant to produce new plant material. That efficiency we can consider it as what na? Efficiency index. So T will be the time T. So W1 equals to W0 e power RT is the formula. W1 is the final size, W0 is the initial size, E is the base of natural logarithm, and R is going to be the growth rate, relative growth rate, or the efficiency index, and the T will be the time T. So if you properly observe this, generally confusion comes because of these two formulas. This is a slow growth, we can add it, and it is a fast growth, that's why we are using the multiplication part. Remember this. So both of these phases of growth or the growth rates comes under qualitative growth rate. We are not measuring its quantity, how it is dividing, that is we are looking at, so that we can call it as a qualitative growth rate. Let we compare it with the quantitative growth rate part. How much growth is happening, we are going to see in this. The quantitative growth rate is of two types. One is absolute growth rate, another one is going to be the relative growth rate. So to be simple, with the help of two leaves we are taking, there is a leaf A, has after time t it has grown somewhere, you can call it as a leaf A dash. Next there is a leaf B, after some time it has grown into B dash. With the help of these leaves, try to understand this absolute and relative growth rate. Absolute growth rate means measurement and comparison of total growth per unit time. Measurement and comparison. Let me measure this. First, leaf A initially 5 centimeter square. Finally, after growth, it became 10 centimeter square. First, we are measuring it. After that, we are comparing. How to comparing final minus initial? So that final is 10 minus initial, it is going to be 5 centimeter square. This is absolute growth of the leaf A. Leaf B, initially it is a 50 centimeter square, after time t it became 55 centimeter square. So that we can consider leaf B 55, which is final, minus 50, it is going to be 5 centimeter square. So that what we can assume here, leaf A and leaf B having the same absolute growth rate. I am repeating, absolute growth rate means measurement and comparison. First we are measuring that, after that we are comparing final minus initial. Next, relative growth rate if you observe. This relative growth rate is a total growth per unit time. Total growth per unit time, and we are comparing that with the initial parameter. Initial parameter. So this relative growth rate of leaf A. What is the total growth? Already we have considered final minus initial. This is the total growth. Total growth by initial one. What is the initial ma? Initial it is 5 into 100. So leaf A relative growth rate is around 100%. How it is arised ma? So total growth per unit time divided by initial parameter. That is a relative growth. We are relating total growth with the initial growth. So initially it is 5, final also it is 5. 5 divided by 5 into 100, we can get it as 100% growth. Whereas leaf B, what is the final growth ma? It is 5 centimeters. Initial it is already 50 centimeters square into 100. We will get around, it is only 10% of growth. It is only 10% of growth. So the leaf B has lesser relative growth than the leaf A. So ultimately what we can say, absolute growth is same for leaf A and leaf B. Relative growth is not same for leaf A and leaf B. Leaf A is having more relative growth than the leaf B. We will stop my here related to the growth rates. One is qualitative, another one is the quantitative part. Tomorrow we will go with the remaining part of discussion that ends with the chapter. Maximum will try to complete this by the end. And one more thing to say ma, the weekend syllabus, this weekend syllabus have placed 2 biotechnology chapters along with photosynthesis and respiration, which are already completed. This plant growth and development concept I can give for the next weekend examination. Thank you.
Good morning dear students, and today we will continue from the same chapter, biodiversity and conservation. So today topic, biodiversity conservation. Okay. So here, why should we conserve biodiversity? Why should we conserve biodiversity? That is the topic. So what is the importance and what purpose we need to conserve biodiversity means because of 3 benefits. For these 3 benefits, every person on the earth, they must try to conserve biodiversity. So these 3 benefits are: number 1, narrowly utilitarian. Narrowly utilitarian benefits. So, why should we conserve biodiversity means the first purpose is what ma? Narrowly utilitarian benefits. Here narrowly utilitarian benefits in the sense we get limited, I mean less benefits from the nature. What kind of benefits we get it from the nature means, you know that everyone, from the animals and plant species present on the earth, we get countless direct economic benefits in different manner. We get beneficial from the plant species and animal species and microorganism species are also. So, that purpose we need to conserve biodiversity. So, in that first one, under narrowly utilitarian benefits we get countless direct economic benefits from the nature. So, we are getting countless direct economic benefits from the nature means for that purpose at least we have to conserve biodiversity. If we not conserve such type of plants and animals from which we are getting benefits, we do not get any kind of economical benefits. And second one, we get food from the nature. Here food giving plants, food giving animals are comes under the biodiversity only. Biodiversity is nothing but what ma? All the variety of living organisms present on the earth comes under the biodiversity. That may includes wide variety of plant species and wide variety of animal species. Here, so the food is we obtained from the several different variety of species of plants and animals. Especially when we talk about food, you can take cereals, right? We get cereals from the plant species. And second one, pulses we get from the plant species, different varieties of plant species. And also vegetables we are getting from the plant species, and also fruits, etc. So, here dear students, if we not conserve the plant species which are giving cereals as a food, pulses as a food, vegetables as a food, fruits as a food, you won't get these benefits if you not conserve such type of plants, right? For that purpose, for food purpose, we need to conserve biodiversity. It will comes under narrowly utilitarian benefits or broadly utilitarian benefits means narrowly utilitarian benefits, okay? And second one, we get firewood from the nature. So, firewood is one of the essential component for many rural area people. They will use wide variety purpose of flame, right? So, that purpose we need to conserve such type of plant species which are used as a firewood. And also next one, fibrae or fiber. Dear students, fibrae we get from the nature. So, fibrae is used in various purpose like making bags and so-called biodegradable materials now prepare ಮಾಡೋದಕ್ಕೆ ಈ ಫೈಬರ್ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಈ ಫೈಬರ್ some different varieties of plants ಇಂದ ನಮಗೆ ಸಿಗುತ್ತೆ. So, such type of plants we need to conserve, then only we will get fiber, okay? So, this is also comes under the narrowly utilitarian benefits ma. And next one, construction material. So, for construction purpose we will cut and cleared many trees, right ma? So these construction purpose, whatever the tree wood we required, such kind of plants we need to protect them, we need to conserve them, then only we will get a construction material to construct different kind of shelters, right? So for that purpose we need to conserve biodiversity. It is also comes under the narrowly utilitarian benefits. And next one, importance of, production of medicinal products. To produce medicinal products. Yeah. So the plants which are having medicinal values, you know that currently 25% of medicines in the market sold out. So all that 25% of medicines will be prepared by the medicinal plants only, plant sources only. Then if you do not protect such type of medicinal plants, you won't get such kind of medicine value to treatment purpose of a human being. So medicinal products, the plants which are having medicinal importance, the plants products which are using for the production of some medicines, so such kind of plants we need to protect them, then only we will get medicinal benefits. Okay ma? So here how much percentage of currently sold out in the market which are prepared by the plants means 25%. 25% of drugs currently sold out in the market which are prepared by the plant species only. And you know one more thing, nearly 25,000 species of plants used in the preparation of traditional medicines. Okay ma? So how many thousands of plants are used in the preparation of traditional medicines ma? Nearly 25,000 species of plants used in the preparation of traditional methods, that means Ayurvedic medicines. Okay, today namge market alli sigo Ayurvedic medicines ella ee plant species indane obtained madiro products. ಒಂದು ವೇಳೆ ನಾವು ಆ ಥರ ಮೆಡಿಸಿನಲ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಇರೋ ಪ್ಲಾಂಟ್ಸ್ನ ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಿಲ್ಲ, ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಿಲ್ಲ, ಸೇವ್ ಮಾಡಿಲ್ಲ ಅಂದ್ಕೊಳ್ಳಿ, ನಮಗೆ ಆ ಪ್ಲಾಂಟ್ಸಿಂದ ಬರೋ ಬೆನಿಫಿಟ್ಸ್, ಆ ಪ್ಲಾಂಟ್ಸಿಂದ ಬರೋ ಮೆಡಿಸಿನಲ್ ವ್ಯಾಲ್ಯೂಸ್ ನಮಗೆ ಸಿಗಲ್ಲ. ದೆನ್ ನೋ ಮೋರ್ ಟ್ರೆಡಿಷನಲ್ ಮೆಡಿಸಿನ್ಸ್ ಆರ್ ಅವೈಲೇಬಲ್ ಇನ್ ದ ಮಾರ್ಕೆಟ್ ಆಗೋಕ್ಕೆ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಆ ಥರ ಮಾಡಬಾರ್ದು. ಈ ಥರ ಮೆಡಿಸಿನಲಿ ಇಂಪಾರ್ಟೆನ್ಸ್ ಇರೋ ಎಲ್ಲ ಪ್ಲಾಂಟ್ ಸ್ಪೀಸೀಸ್ನ ನಾವು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಬೇಕು. ಯಾಕಂದರೆ ಅದನ್ನು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅದು ನಮಗೆ ಹೆಲ್ಪ್ ಮಾಡೋಕ್ಕೆ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಅದರಿಂದ ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಒನ್ ಆಫ್ ದ ಮೆಥಡ್ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಬಯೋಡೈವರ್ಸಿಟಿ. ಸೊ ವೈ ಶುಡ್ ವಿ ಕನ್ಸರ್ವ್ ಬಯೋಡೈವರ್ಸಿಟಿ ಮೀನ್ಸ್ ಫಾರ್ ದಿಸ್ ಪರ್ಪಸ್. For this purpose, in the sense, we have a lot of medicinal benefits from the plants. So nearly 25% of drugs currently in the market sold out, which are all prepared by the plant species only. And how many plant species are involved in the preparation of traditional methods or Ayurvedic medicines? Andre nearly 25,000 species of plants are used in the preparation of traditional methods. And also another important products which is also used in the narrowly utilitarian benefits, that is industrial products. Industrial products. Here ma, industrial products in the sense the products from the plants we prepared in industries in a large scale. Then what type of benefits we get from the plants which are prepared in industries means number one, you can take tannins. So tannins are the industrial product which is obtained from the plant species. So we are getting tannins. So for that purpose we need to conserve biodiversity. Second one, resins. Resins also one of the industrial product but which is also obtained from the plants only. And next, dyes. Various type of dyes also prepared in industries. These dyes preparing components also obtained from the plant species. So such type of plants we need to conserve, then only we get dyes. And also lubricants. Lubricants. No, today in the automobiles are various mechanical friction reduce ಮಾಡೋದಕ್ಕೆ ವೇರಿಯಸ್ ಟೈಪ್ ಆಫ್ ಲುಬ್ರಿಕೆಂಟ್ಸ್ನ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅವೆಲ್ಲ ಲುಬ್ರಿಕೆಂಟ್ಸ್ ಪ್ರಿಪೇರ್ ಮಾಡಬೇಕು ಅಂದರೆ ಈ ಪ್ಲಾಂಟ್ ಸ್ಪೀಸಿಸಿಂದ ಈ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನೋದು ಸಿಗಬೇಕು, ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಓಕೆ. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಒನ್, perfumes etc. So here for the preparation of perfumes also we need some special product which are obtained from the plant species. ಅಂದರೆ ಇಂಡಸ್ಟ್ರೀಸ್ ಅಲ್ಲಿ ಏನೇನು ಇಂಡಸ್ಟ್ರಿಯಲ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ನಾವು ಪ್ರಿಪೇರ್ ಮಾಡ್ತಿರೋ ಆಲ್ ದಟ್ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ವಿಚ್ ಆರ್ ಕಮಿಂಗ್ ಫ್ರಮ್ ದ ಪ್ಲಾಂಟ್ ಸ್ಪೀಸೀಸ್, ಅಂಥ ಪ್ಲಾಂಟ್ ಸ್ಪೀಸೀಸ್ನ ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಯಾಕಂದರೆ ಮೆನಿ ಪ್ಲಾಂಟ್ ಸ್ಪೀಸೀಸಿಂದ ಈ ಥರ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ನಮ್ಗೆ ಸಿಗ್ತಾ ಇದೆ. ಅವಾಗೆ ಆ ಪ್ಲಾಂಟ್ ಸ್ಪೀಸೀಸ್ನ ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಇದು ಸಿಗುತ್ತೆ. ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ದೋಸ್ ಪ್ಲಾಂಟ್ಸ್ ಆರ್ ಬಿಕಮ್ಸ್ ಎಕ್ಸ್ಟಿಂಕ್ಟ್. ಇಫ್ ದಟ್ ಪ್ಲಾಂಟ್ಸ್ ಬಿಕಮ್ಸ್ ಎಕ್ಸ್ಟಿಂಕ್ಟ್ ವಿ ಡು ನಾಟ್ ಗೆಟ್ ಎನಿ ಬೆನಿಫಿಟ್ಸ್ ಫ್ರಮ್ ದ ನೇಚರ್. ಓಕೆ. ಫಾರ್ ದಿಸ್ ಪರ್ಪಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಕನ್ಸರ್ವ್ biodiversity which is comes under narrowly utilitarian benefits. Okay ma. And next one, bioprospecting. Recently in 2026 NEET examination they asked a question, they framed a question on bioprospecting definition. So what is bioprospecting means? The exploring molecular level or genetic level or species level of diversity for the economically important products is called bioprospecting. So here exploring molecular level, comma, genetic level. Molecular level means like molecules, DNA, RNA, so called. Okay. Genetic level means at gene level, and also species level of biodiversity. For what purpose? To produce economical beneficial products. Yeah, this is called bioprospecting. ಅಂದರೆ ಇವಾಗ ಯಾವುದಾದ್ರೂ ಒಂದು ಪ್ಲಾಂಟಿಂದ ಸಮ್ ಎಕನಾಮಿಕಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ ಅಂದ್ಕೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ರಾವುಲ್ಫಿಯಾ ವಾಮಿಟೋರಿಯಾ. Raulfia vomitoria plant produces one chemical called reserpine. It is economically very important product. So now by bringing out a genetic level, molecular level, species level of diversity, that means by changing a molecules, by changing a gene level, by changing species level alli now different species, different genetic strains na now obtain madodrinda instead of one Raulfia vomitoria 5 ml of reserpine produce ಮಾಡೋ ಪ್ಲೇಸಲ್ಲಿ ಅದೇ ಪ್ಲಾಂಟಲ್ಲಿ ನಾವು ಜೆನೆಟಿಕಲಿ ಚೇಂಜ್ ಮಾಡೋದ್ರಿಂದ 10 ml of reserpine ನಾವು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಬೋದು. ದಟ್ ಈಸ್ ಬೆನಿಫಿಷಿಯಲ್ ಓನ್ಲಿ. ಓಕೆ. ಆ ಥರ ಯಾವ ಪ್ಲಾಂಟ್ಸಿಂದ ಎಕನಾಮಿಕಲಿ ಬೆನಿಫಿಷಿಯಲ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಬರೋಕ್ಕೆ ಚಾನ್ಸ್ ಇರುತ್ತೋ ಅದ್ರ ಕರೆಂಟ್ ಪ್ರೊಡಕ್ಷನ್ನ ಇನ್ನೂ ಸ್ವಲ್ಪ ಎನ್ಹ್ಯಾನ್ಸ್ ಮಾಡೋದಕ್ಕೆ ನಾವು ಮಾಲಿಕ್ಯುಲರ್ ಲೆವೆಲ್, genetic level, species level of ಡೈವರ್ಸಿಟಿನ ಇನ್ಕ್ರೀಸ್ ಮಾಡೋ ಪ್ರಾಸೆಸ್ನೇ ಬಯೋ ಪ್ರಾಸ್ಪೆಕ್ಟಿಂಗ್ ಅಂತೀರಿ. ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ಕಮ್ಸ್ ಅಂಡರ್ ನ್ಯಾರೋಲಿ ಯುಟಿಲಿಟೇರಿಯನ್ ಬೆನಿಫಿಟ್ಸ್. ಐ ರಿಪೀಟ್ ಒನ್ಸ್ ಅಗೇನ್ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, we need to conserve biodiversity. What purpose? Why we should conserve biodiversity means because of first one, narrowly ಯುಟಿಲಿಟೇರಿಯನ್ ಬೆನಿಫಿಟ್ಸ್ಗೋಸ್ಕರ. ಯಾಕೆಂದರೆ ನೇಚರಲ್ಲಿ ನಮಗೆ ಕೌಂಟ್ಲೆಸ್ ಡೈರೆಕ್ಟ್ ಎಕಾನಮಿಕ್ ಬೆನಿಫಿಟ್ಸ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ಫ್ರಮ್ ದ ನೇಚರ್, ಲೈಕ್ ಫುಡ್, firewood, fiber or construction material, medicinal products and also industrial products, bioprospecting. All these are comes under the examples for narrowly utilitarian benefits. You must take a clarity which comes under narrowly utilitarian, which comes under broadly utilitarian. And also note this point. So currently how much percentage of drugs are sold out in the market? Andre 25% ma. And also how many species of plants currently used in the preparation of Ayurvedic medicines or traditional medicines means the correct answer is 25,000 ma. Okay na? 20,000 species of plants are used in the preparation of traditional methods. This is the ಫಸ್ಟ್ ಬೆನಿಫಿಟ್ಸ್. ಇದಕ್ಕೋಸ್ಕರ ಆದರೂ ನಾವು ಬಯೋಡೈವರ್ಸಿಟಿನ ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಸೆಕೆಂಡ್ ಒನ್, ಬ್ರಾಡ್ಲಿ ಯುಟಿಲಿಟೇರಿಯನ್ benefits purpose. Broadly utilitarian benefits, because from the nature we get very huge benefits. That huge benefits are coming from the animal species and the plant species. Those are the part of biodiversity, right? Then the plants and animal species which are giving huge benefits to the human beings, at least for such type of species we need to conserve. Then only we get such type of huge benefits. What are those broadly utilitarian benefits from the nature means? The first one is, you know, Amazon rainforest, where it is located? In the South America. Where it is located, ma? In the South America. We all know that yesterday we discussed it is considered as lungs of the planet. Why? Because these Amazon rainforest produce 20% of oxygen to the world. That means released into the atmosphere. I repeat ma, Amazon rainforest produces nearly 20% of oxygen into the atmosphere. Just imagine, just from one Amazon rainforest 20% of oxygen is released into the atmosphere. That 20% of oxygen may helpful for many human beings in the respiration. Just imagine if no Amazon rainforest. Okay, so present current namge availability iro oxygen alli 20% minus adre, it is huge problems it will created in the breathing of human beings. Okay, so called here Amazon rainforest is one of the part of biodiversity, because there wide variety of plant species are there. Okay, these plant species will give 20% of oxygen. 20% of oxygen is not a narrow thing, it is a broad thing, it is the huge benefits from the nature. ಅದಕ್ಕೋಸ್ಕರ ಆದರೂ ಅಂಥ ಪ್ಲಾಂಟ್ ಸ್ಪೀಸೀಸ್ನ ನಾವು ಅಂದರೆ ಅಮೆಜಾನ್ ರೈನ್ ಫಾರೆಸ್ಟ್ನ ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು, ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಸೆಕೆಂಡ್ ಕ್ಯಾಟಗಿರಿ. ಓಕೆ, ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಒನ್, you all know that pollination is very very important to produce a wide variety of benefits like cereals, pulses, vegetables, fruits, any other products whatever we taken as a food materials. How they will come, ma? So that is because of pollination only. So how pollination is done? So pollination is done by pollinators. Pollination is done by pollinators. Andre illi pollinators nu one type of animals, biodiversity. ಈಗ ನಾವು ಆ ಪಾಲಿನೇಷನ್ಗೆ, ಪ್ಲಾಂಟ್ ಪಾಲಿನೇಷನ್ಗೆ ಹೆಲ್ಪ್ ಆಗೋ ಪಾಲಿನೇಟರ್ಸ್ ಏನೇನಿದೆಯೋ ಅವೆಲ್ಲ ಆರ್ಗಾನಿಸಮ್ಸ್ನ ನಾವು ಕಾಪಾಡಬೇಕು. ಅದನ್ನು ಕಾಪಾಡಿದ್ರೇ ಆ ಆರ್ಗಾನಿಸಮ್ಸ್ ಬಂದುಬಿಟ್ಟು ನಮ್ಮ ಕ್ರಾಪ್ ಪ್ಲಾಂಟ್ಸ್ನ ಪಾಲಿನೇಷನ್ ಆಗೋದಕ್ಕೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಆ ಪಾಲಿನೇಷನ್ ಆದ್ರೇ ನಮಗೆ ಆ ಪ್ಲಾಂಟ್ ಪ್ರೊಡಕ್ಷನ್ ಅನ್ನೋದು ಸಿಗುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ಒನ್ ಕೈಂಡ್ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಕಮ್ಸ್ ಅಂಡರ್ ವೆರಿ ಬ್ರಾಡ್ ಥಿಂಗ್, ಬಿಕಾಸ್ ಪಾಲಿನೇಷನ್ ಇಸ್ ನಾಟ್ ಅ ಸಿಂಪಲ್ ಪ್ರಾಸೆಸ್, ಇಟ್ ಈಸ್ ಅ ಹ್ಯೂಜ್ ಪ್ರಾಸೆಸ್. ವರ್ಲ್ಡ್ ವೈಡ್ ಆ ಪಾಲಿನೇಷನಿಂದನೇ ಟುಡೇ ನಾವು ನೋಡ್ತಿರೋ ಎಲ್ಲ ಪ್ರಾಡಕ್ಟ್ಸ್, ಫುಡ್ ಪ್ರಾಡಕ್ಟ್ಸ್ we are getting from that. Okay, so what type of animals are acts as pollinators are andre like bees, comma bumblebee bees, comma beetles, comma birds, etc. Still many is there. So here pollination is also comes under a broad thing, ma, huge benefits from the nature. So such type of pollination is done by the in the presence of pollinators. So what are pollinators? Acts as pollinators andre bees, bumblebees, beetles and birds. Simply you can remember B4. As a result of pollination, what we get? We get cereals. Cereals are produced by the pollination of plants. That pollination is done by pollinators. Second, fruits. We obtain fruits from the pollination only. For pollination, pollinators are required. Third, pulses. So variety of pulses we obtain by the pollination only. That pollination is done by pollinators. ಅಂದರೆ ಇಲ್ಲಿ ನಾವು ಪ್ಲಾಂಟ್ಸ್ನು ಮತ್ತು ಪಾಲಿನೇಟರ್ಸ್ನು ಇಬ್ಬರೂ ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು, ಅವಾಗೆ ನಮಗೆ ಈ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಒನ್, ಆ್ಯಂಡ್ ವೆಜಿಟಬಲ್ಸ್ ಎಕ್ಸೆಟ್ರಾ. ವೆಜಿಟಬಲ್ಸ್ ಎಕ್ಸೆಟ್ರಾ. ಸಿ ದಿಸ್ ಇಸ್ ದ ಅನದರ್ huge benefit from the nature. Okay, and the last one, the third broadly utilitarian benefits example is aesthetic pleasure. Aesthetic pleasure. Here ma, aesthetic pleasure means here we are not getting any direct or any benefits from the nature, but we get aesthetic pleasure from the nature. For example, see, aesthetic pleasure means inbuilt happiness. Okay, manasika happiness, ಏನಂತಾರೆ ಸೌಂದರ್ಯ ಆನಂದ. I mean now when we see the blooming flowers, a valley of blooming flowers, or in the early morning by hearing different kinds of bird sounds, when we see the beautiful amazing birds, amazing flowers and greenery and thick woods and forestry. Okay, all these are the part of biodiversity only. ಇವೆಲ್ಲ ನಾವು ನೋಡಿದಾಗೆ ನಮಗೆ ಗೊತ್ತಿಲ್ದರ ನಮಗೆ ಇನ್ಬಿಲ್ಟ್ ಹ್ಯಾಪಿನೆಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಅಂದರೆ ಆ ಥರ ಆ ಹ್ಯಾಪಿನೆಸ್ ನಮಗೆ ಸಿಗಬೇಕು ಅಂದ್ರೂ ನೇಚರ್ನ ಕಾಪಾಡಬೇಕು. ಸೊ ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ಒನ್ ಆಫ್ ದ ಬ್ರಾಡ್ಲಿ ಯುಟಿಲಿಟೇರಿಯನ್ ಎಕ್ಸಾಂಪಲ್ ಬರುತ್ತೆ. ಓಕೆಮಾ, ಸೊ ದಿಸ್ ಈಸ್ ದ ಸೆಕೆಂಡ್ ರೀಸನ್ ವೈ ಶುಡ್ ವಿ ಕನ್ಸರ್ವ್ ಬಯೋಡೈವರ್ಸಿಟಿ. ಆ್ಯಂಡ್ ದ ಲಾಸ್ಟ್ ಥರ್ಡ್ ರೀಸನ್ ಈಸ್ ethical issues, illandre ethical arguments, ethical purpose we need to conserve biodiversity. What is this ethical arguments? Andre every species on the earth has its own intrinsic value. Even that plant and animal species may be not useful for you, may be not produce any benefits for you, but still you have to conserve it. ಯಾಕೆಂದರೆ ನಿನಗೆ ಈ ಭೂಮಿ ಮೇಲೆ ಬದುಕಬೇಕು ಅನ್ನೋದು ಎಷ್ಟು ಆಸೆ ಇರುತ್ತೋ, ಏನು ರೈಟ್ ಇರುತ್ತೋ, ಎವ್ರಿ ಪ್ರಾಣಿಗೂ ಅದೇ ಥರ ಬದುಕಬೇಕು ಅನ್ನೋ ರೈಟ್ ಇರುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಆ್ಯಂಡ್ ನಂಬರ್ 2, ಆ್ಯಸ್ ಅ ಹ್ಯುಮ್ಯಾನಿಟಿ ಆ್ಯಂಡ್ ಆ್ಯಸ್ ಅ ಪರ್ಸನ್ ಹೂ ಬಿಲೀವ್ಸ್ a kind of humanity, you must conserve different types of species. ಯಾಕಂದರೆ ಎಲ್ಲ ಸ್ಪೀಸೀಸ್ಗೂ ಬದುಕೋ ರೈಟ್ಸ್ ಇರುತ್ತೆ. ಮೇ ಬಿ ಅದರಿಂದ ನಿನ್ಗೆ ಯೂಸ್ ಇಲ್ದಿರ ಇರ್ಬೋದು, ಬಟ್ ಇಟ್ ಇಸ್ ಅ ಪಾರ್ಟ್ ಆಫ್ ದೇರ್ ರೈಟ್ to live on this earth. That is called ethical argument. So these are the 3 purpose we need to conserve biodiversity. And just remember, for 3 purpose we need to conserve biodiversity. Number 1, narrowly utilitarian benefits, because we are getting less benefits from the nature. Direct economic benefits from the nature like food, firewood, industrial products, construction materials, and also economically, medically, medicinal importance products, etc., and fibre, etc., even bioprospecting. And second one, we are getting broadly utilitarian benefits from the nature like 20% of oxygen coming from the Amazon rainforest. And second one, pollination by pollinators, we obtain all these products. Third one, and aesthetic pleasure. And third reason, ethical issue. Andre every living organism has its own, their intrinsic value, and also they have a right to live on this earth. So you have to support that ಅನ್ನೋದೇ ಇದ್ರ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆಮ್ಮ. ದೆನ್ ಹೌ ಡು ವಿ ಕನ್ಸರ್ವ್ ಬಯೋಡೈವರ್ಸಿಟಿ? ಯಾಕೆ ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಗೊತ್ತಾಗಿದೆ, ಹೇಗೆ ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಈಗ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. Yeah. Next, how do we conserve are nothing but strategies. Strategies for conservation of biodiversity. Biodiversity. Strategies for conservation of biodiversity. What strategies we will follow conservation of biodiversity? Very, very, very important, ma. Even in every NEET examination, in alternative year, in every examination, they will frame a question on this topic. Be careful with strategies for conservation of biodiversity. In that first one, first strategy is in situ conservation. In situ conservation. In situ conservation. In situ conservation is also known as on situ conservation. In situ conservation is also known as what, ma? On situ conservation. Here in situ andre site, region. In andre within anta artha. Within the region andre ಯಾವುದಾದ್ರೂ ಪ್ಲಾಂಟ್ಸ್ ಆ್ಯಂಡ್ ಅನಿಮಲ್ ಸ್ಪೀಸೀಸ್ ಅದು ಎಲ್ಲಿರುತ್ತೋ ಅಲ್ಲೇ, ಅದಿರೋ ಪ್ಲೇಸಲ್ಲೇ. ಕನ್ಸರ್ವೇಷನ್ ಮೀನ್ಸ್ ವಿ ನೀಡ್ ಟು ಪ್ರೊಟೆಕ್ಟ್ such type of organisms within their natural habitat is called in situ conservation, also known as on situ. On situ andre on the spot where the living organism is present is called in situ conservation. Then why should we conserve, sir? Andre some species of organisms may be in the endangered or may be in the threatened in the sense, if we not protect them, if we not conserve and protect them, soon they will be extinct from the nature. No more such kind of species. So such type of species are called threatened species or endangered species we call it. So such type of species we need to identify and we need to conserve and give protection to them, then that species population will be continues into the next generation. So such type of conservation is called in situ conservation. I repeat ma, andre illi ಒಂದೊಂದು ಸತಿ ನೋಡ್ರಿ ಒಂದು ಟೈಗರ್ನ ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡೋದಕ್ಕೆ ನಾವು ಕಂಪ್ಲೀಟ್ ಫಾರೆಸ್ಟ್ಗೆ ಪ್ರೊಟೆಕ್ಷನ್ ಕೊಡಬೇಕಾಗೋ ಸಿಚುವೇಶನ್ ಬರುತ್ತೆ. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಒನ್ ಆಫ್ ದ ಇನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್ ಅಂತ ಕರಿಬೋದು. ಒಂದು ಫಾರೆಸ್ಟಲ್ಲಿ ಎ ಹ್ಯೂಜ್ ಫಾರೆಸ್ಟ್ and tiger species are present, only one tiger is there, that is a rare species, and in threatened condition ಅದನ್ನು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಿಲ್ಲ ಅಂದರೆ ಅದ್ರ ಸ್ಪೀಸೀಸ್ ಫ್ಯೂಚರಲ್ಲಿ ನಮ್ಗೆ ಸಿಗೋಕ್ಕೆ ಚಾನ್ಸ್ ಇರಲ್ಲ. ಅಂಥ ಸಂದರ್ಭದಲ್ಲಿ ನಾವು ಆ ಒನ್ ಟೈಗರ್ನ ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡೋದಕ್ಕೆ ನಾವು ಕಂಪ್ಲೀಟ್ ಆ ಟೈಗರ್ ಇರೋ ಫಾರೆಸ್ಟ್ಗೆ ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು, ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸಚ್ ಟೈಪ್ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಈಸ್ ಕಾಲ್ಡ್ ಇನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್, ವಿ ಕಾಲ್ ಇಟ್. ಓಕೆ, ಡೆಫಿನೇಷನ್ ಮಾ, ವಾಟ್ ಈಸ್ ಇನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್ ಮೀನ್ಸ್ the conservation of a threatened species, conservation of threatened species. Here threatened species what ma? All the plants and animal species which are in endangered or nearly going to be extinct within their natural habitat, within their natural habitat. So organism ಎಲ್ಲಿ ಇರುತ್ತೋ ಅದು ಇರೋ ಪ್ಲೇಸ್ಗೆ ನಾವು ಪ್ರೊಟೆಕ್ಷನ್ ಕೊಡ್ತೀವಿ. ಸೊ ಆ ಆರ್ಗಾನಿಸಮ್ ಇರೋ ಪ್ಲೇಸ್ಗೆ ನಾವು ಪ್ರೊಟೆಕ್ಷನ್ ಕೊಟ್ಬಿಟ್ಟು ಅದನ್ನು ಕನ್ಸರ್ವ್ ಮಾಡೋ ಪ್ರಾಸೆಸ್ನ ಇನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್ ಆರ್ ಆನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್ ವಿ ಕಾಲ್ ಇಟ್. ದೆನ್ ವಾಟ್ ಆರ್ ದ ಎಕ್ಸಾಂಪಲ್ಸ್ ಫಾರ್ ಇನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್? ನಂಬರ್ 1, ನ್ಯಾಷನಲ್ ಪಾರ್ಕ್ಸ್. National parks, all the national parks comes under the in situ conservation, because some, national parks may be having nearly 100 to more than 100 hectares huge area. So in that national parks, some species of like tigers, some other endangered species, whatever present, so such kind of organisms ನಾವು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಎಂಟೈರ್ ನ್ಯಾಷನಲ್ ಪಾರ್ಕ್ಸ್ನ ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡ್ತೀರಿ. ಸೊ ದಟ್ ಕೈಂಡ್ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಇನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್. ಸೊ ನ್ಯಾಷನಲ್ ಪಾರ್ಕ್ಸ್ ಕಮ್ಸ್ ಅಂಡರ್ ಇನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್ ಆರ್ ಎಕ್ಸ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್? ಇನ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್. ಯಾಕೆಂದರೆ ನ್ಯಾಷನಲ್ ಪಾರ್ಕ್ಸ್ನ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡಲ್ಲ, ಅದಿರೋ ಪ್ಲೇಸ್ಗೆ ನಾವು ನ್ಯಾಷನಲ್ ಪಾರ್ಕ್ಸ್ ಅಂತ ಕೇಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿಬಿಟ್ಟು ಆ ನ್ಯಾಷನಲ್ ಪ್ರೊಟೆಕ್ಷನ್ ಅನ್ನೋದು ಕೊಡ್ತೀರಿ. ಸೊ ಹೌ ಮೆನಿ ನಂಬರ್ ಆಫ್ ನ್ಯಾಷನಲ್ ಪಾರ್ಕ್ಸ್ ಪ್ರೆಸೆಂಟ್ in India andre 90. How many number of national parks are present ma? 90. And second one, biosphere reserves. Biosphere reserves is the second examples for in situ conservation, where also we protect the threatened species within their natural habitat. How many number of biosphere reserves present andre? 14. How many ma? 14 biosphere reserves are present. And the third one, wildlife sanctuaries. Wildlife sanctuaries are another example for in situ conservation. Here also we will protect the threatened species within their natural habitat only. So how many number of wildlife sanctuaries are present means 448. 448 wildlife sanctuaries are present. And next one, sacred groves. Sacred groves. Sacred groves are also an example for in situ conservation. So what are sacred groves means? The traditionally conserved forest patches where all the plants and wildlife, animal species are well protected by the some tribals. The people because of their religious beliefs is called sacred groves. Okay, for example, you kelu tribals, a group of tribal peoples living on a hill regions, okay, where a thick forest and wildlife will be existed. ಅಲ್ಲಿ ಅವ್ರು ಏನು ಮಾಡ್ತಾರೆ, ಅಲ್ಲಿರೋ ಯಾವ ಟ್ರೀಸ್ನು ಅನಿಮಲ್ಸ್ನು ಅವ್ರು ಸಾಯಿಸಲ್ಲ. ಯಾಕಂದರೆ ಅವ್ರ ಟ್ರೆಡಿಷನ್ ಪ್ರಕಾರ ಎವ್ರಿ ಪ್ಲ್ಯಾಂಟ್ ಆ್ಯಂಡ್ ಅನಿಮಲ್ ಸ್ಪೀಸೀಸ್ನ ಅವರು ಗಾಡ್ ಥರ ಬಿಲೀವ್ ಮಾಡ್ತಾರೆ. ಆ ಬಿಲೀವಿಂದ ಅವ್ರು ಏನು ಮಾಡ್ತಾರೆ, ಅವರು ಆ ಪ್ಲಾಂಟ್ಸ್ನ ಕಟ್ ಮಾಡಲ್ಲ, ಬೇರೆಯವ್ರು ಯಾರಿಗೂ ಆ ಪ್ಲಾಂಟ್ಸ್ನ ಕಟ್ ಮಾಡೋಕ್ಕೆ ಕಟ್ ಮಾಡೋದಕ್ಕೆ ಅವಕಾಶ ಕೊಡಲ್ಲ. ಅಂದರೆ ಇದರಲ್ಲಿ ಅವ್ರ ಬಿಲೀಫ್ ಏನೇ ಆಗಲಿ ನಮಗೆ ಇಲ್ಲಿ ಅಲ್ಲಿರೋ ಸ್ಪೀಸೀಸ್ ಡೈವರ್ಸಿಟಿನ ಕಾಪಾಡ್ತಾರೆ. ಸೊ ಅಂಥ ಟ್ರೈಬಲ್ಸ್ ಪೀಪಲ್ಸಿಂದ ಪ್ರೊಟೆಕ್ಟ್ ಆಗಿರೋ ಫಾರೆಸ್ಟ್ ಏರಿಯಾನ ಪ್ಯಾಚಸ್ನ ಸ್ಯಾಕ್ರೆಡ್ ಗ್ರೂವ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆಮ್ಮ, ಸ್ಯಾಕ್ರೆಡ್ ಗ್ರೂವ್ಸ್ ಅಂದರೆ ದ ಟ್ರೆಡಿಷನಲಿ ಬಿಕಾಸ್ ದಟ್ ಈಸ್ ದೇರ್ ಟ್ರೆಡಿಷನ್ ಟು ಕನ್ಸರ್ವ್ ಆಲ್ ದ ಪ್ಲಾಂಟ್ಸ್ ಅಂಡ್ ವೈಲ್ಡ್ ಲೈಫ್ ಬಿಕಾಸ್ ಆಫ್ ದೇರ್ belief, religious beliefs. So such kind of protection is called sacred groves. There are different sacred groves present in India. So what are those, we'll see now. Okay na? So sacred groves examples ma, example number 1, Kasi and Jain Shia hills of Rajasthan. Kashi and Jain Shia hills of, sorry ma, Kashi and Jain Shia hills of Meghalaya. And second example, Aravali hills of Rajasthan and Western Ghats of Maharashtra and Karnataka and Sarguja. I repeat ma, Western Ghats present in Maharashtra. In Maharashtra also Western Ghats is one of the sacred grove where the tribals are protecting the plants and animal species. And the same Western Ghats present in the Karnataka also considered as sacred grove, and Sarguja too. Okay, and next Bastar and Chanda area of Madhya Pradesh. In Madhya Pradesh, Bastar area and Chanda area are also comes under examples for sacred groves where these places are well protected by the tribals. And even Aravali hills present in the Rajasthan, and also Kasi and Jain Shia hills of Meghalaya. You know, in the Meghalaya, some of the rare species of plants present in Meghalaya, so that is not available in any other states in India. Okay, Meghalaya is one of the highest, rarest species containing state ma, where we obtain very rare plant species. So all these are the examples for sacred groves. Okay, so sacred groves are traditionally conserved forest patches where all the plants and animal species are well protected. Why they will protect that plants and animal species? Andre because of their religious beliefs. So such kind of sacred groves present in India like Meghalaya, Rajasthan, Maharashtra, Karnataka, Sarguja and Madhya Pradesh. And last insight example, Last insight example, biological hotspots. Biological hotspots. Yeah, here ma biological hotspots means biological means the living organisms. Hotspots means a region with highest species richness. Species richness in the sense wide variety of species, not number of species, not in a same species, not more number. So different species like amphibians, frogs, snakes, lizards, tortoise, birds, plant, different like this. Variety, wide variety of different plant species present in a same region, within a same region. So such type of places are highly endangered for the extinction. Why? Because suppose this is the area in some states, it is an area ankoli. Within this small area, almost 200 species of variety of species of organisms are present. In the rest of the country, 200 species are present. Only in one state, in one forest, in one region, 200 species of organisms are present. In the remaining entire country, 200 species are present ankoli. Now, it is very difficult to extinct all the 200 species present in the entire India, but it is very easy to destroy this 200 species within a single geographical area. ಯಾಕಂದರೆ ಇದೊಂದು ಪ್ಲೇಸ್ನ ನಾವು ಎಕ್ಸ್ಟಿಂಕ್ಟ್ ಮಾಡಿದರೆ ಅಂದ್ಕೊಳ್ಳಿ, ಅಂದರೆ ಬಿಕಾಸ್ ಆಫ್ ಡಿಫಾರೆಸ್ಟೇಷನ್ ಅಥವಾ ಫೈರ್ ಆರ್ ಸೋ ಕಾಲ್ಡ್ ರೀಸನ್ಸಿಂದ ಅದೊಂದು ಪ್ಲೇಸ್ ಎಕ್ಸ್ಟಿಂಕ್ಟ್ ಆದರೆ ಆ ಪ್ಲೇಸಲ್ಲಿರೋ ಇಷ್ಟೊಂದು ಹ್ಯೂಜ್ ರಿಚ್ ಸ್ಪೀಸೀಸ್ ಎಲ್ಲ ಡೆತ್ ಆಗುತ್ತೆ. ಸೊ ಎಷ್ಟು ಇಂಪಾರ್ಟೆನ್ಸ್ ಇರುತ್ತೋ ಅಷ್ಟೇ ಡೇಂಜರ್ ಝೋನಲ್ಲಿ ಇದಿರುತ್ತೆ. ಅದಕ್ಕೆ ದ ಗವರ್ನಮೆಂಟ್ ಆಫ್ ಇಂಡಿಯಾ ಆರ್ ನಾಟ್ ಓನ್ಲಿ ಇಂಡಿಯಾ, ಎನಿ ಕಂಟ್ರಿ, ದೇ ವಿಲ್ ಗಿವ್ highly important protection to such type of areas to save, to conserve biodiversity. So I can define what are biological hotspots means the region with high level of species richness and high degree of endemism. I repeat ma, a region with a high level of species richness means wide variety of different variety of species are present in that region, and also they show high degree of endemism. Endemism means the organisms which confined to their original location or geographical area, and they do not found in anywhere else. ಅಂದರೆ ಯಾವ ಜಿಯೋಗ್ರಾಫಿಕಲ್ ಏರಿಯಾ ಒಳಗಡೆ ವೈಡ್ ವೆರೈಟಿ ಆಫ್ ಸ್ಪೀಸೀಸ್ ಇದ್ದು ಆ ಸ್ಪೀಸೀಸ್ ಎಲ್ಲ ಒಂದೇ ಜಿಯೋಗ್ರಾಫಿಕಲ್ ಏರಿಯಾಗೆ ಕನ್ಫೈನ್ಡ್ ಆಗಿದ್ರೆ, ರೆಸ್ಟ್ರಿಕ್ಟ್ ಆಗಿದ್ರೆ, ದೇ ಡು ನಾಟ್ ಫೌಂಡ್ ಇನ್ ಎನಿ ಅದರ್ ಪ್ಲೇಸಸ್. ಸೊ ಸಚ್ ಟೈಪ್ ಆಫ್ ಕಂಡೀಷನ್ ಈಸ್ ಕಾಲ್ಡ್ biological hotspots ಅಂತ ಕರೀತಾರೆ. Here the term endemism refers to the species which are present in only one geographical area, do not present in anywhere else in the world. Such type of species are called endemism or endemic species ಅಂತ ಕರೀತಾರೆ. For example, you can take Royal Bengal tiger in India. ಸೊ ಈ ರಾಯಲ್ ಬೆಂಗಾಲ್ ಟೈಗರ್ ಅನ್ನೋದು ಇಂಡಿಯಾದಲ್ಲಿ ಮಾತ್ರ ಸಿಗುತ್ತೆ, ಬೇರೆ ಯಾವ ಕಂಟ್ರಿಯಲ್ಲಿ ಸಿಗಲ್ಲ. ಸೊ ರಾಯಲ್ ಬೆಂಗಾಲ್ ಟೈಗರ್ ಈಸ್ ಒನ್ ಆಫ್ ದ ಎಂಡಮಿಕ್ ಸ್ಪೀಸೀಸ್ ಆಫ್ ಇಂಡಿಯಾ. ಸಿಮಿಲರ್ಲಿ ಕ್ಯಾಂಗರೋ ಫ್ರಮ್ ಆಸ್ಟ್ರೇಲಿಯಾ. Kangaroo is endemic species of Australia, do not found in any other country. Third one, kiwi from New Zealand. Kiwi is one of the, kiwi bird is one of the endemic species to the New Zealand. Adanna endemism anta karitare. Okay. Then how many biological hotspots present in the world and present in India? We'll see now. So in the world, how many number of biological hotspots are identified means 34 ma. How many? 34. Actually, initially they identified 25 biological hotspots. Later they added 9. So together 34 biological hotspots were discovered up to now in the world. Itara, the region with highest species richness and more endemism containing places are 34 are there. So initially they identified how many biological hotspots in the world andre 25, and later newly 9 biological hotspots are identified. So together 34 biological hotspots are present. Okay. In India 3 biological hotspots are present ma. How many ra? 3 biological hotspots are present. So they are number 1 Indo-Burma. Burma means Bangladesh. So Indo-Burma is one of the biological hotspot. It is present at the border between India and Burma. And second one, Western Ghats of India and Sri Lanka. It is the border of India and Sri Lanka forest. So Western Ghats is also one of the biological hotspot in India. Third one, Himalayas is the third biological hotspot present in the India. Okay. So these are biological hotspots present in India and in the world. You can go through this carefully. So this is about in situ conservation. Andre one organism, one threatened species of plants and animals adellirutto adiro place ke ನಾವು protect ಮಾಡಿ conserve ಮಾಡೋ process na in situ conservation we call it. All these are comes under in situ conservation. And the second one is ex situ conservation. Here ex situ conservation means the conservation of threatened species out of their natural habitat. That means, suppose in a forest a tiger population is in a threatened zone, threatened condition ankoli. If we not protect such kind of tiger population, soon no more tigers in India. Anta conditions alli navu ಏನು ಮಾಡ್ತೀರಿ, ಆ ಟೈಗರ್ಸ್ ನ ಅಲ್ಲಿಂದ ತಗೋಬಂದು ನಾವು ಹ್ಯೂಮನ್ಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿರೋ ಒಂದು ಕೇಜ್ ಅಥವಾ ಒಂದು ಪ್ರೊಟೆಕ್ಟೆಡ್ ಎನ್ವಿರಾನ್ಮೆಂಟ್ ಒಳಗಡೆ ಅದನ್ನ ಇಟ್ಬಿಟ್ಟು ಅದಕ್ಕೆ ಬೇಕಾಗಿರೋ ಪ್ರೊಟೆಕ್ಷನ್, ಅದಕ್ಕೆ ಬೇಕಾಗಿರೋ ಫುಡ್, ಎವ್ರಿಥಿಂಗ್ ಕೇರ್ ವಿ ವಿಲ್ ಗಿವ್ ದೆಮ್. So such type of conservation is called ex situ conservation. You know that many zoological parks, botanical parks, ಈ zoological parks ಎಲ್ಲ ಏನು ಮಾಡ್ತೀರಿ, ಡಿಫ್ರೆಂಟ್ ಟೈಗರ್ಸ್ ಇವೆಲ್ಲದನ್ನ ಒಂದು ಕೇಸಸ್ ಅಲ್ಲಿ ಅದನ್ನು ರೆಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡಿಬಿಟ್ಟು ಅದಕ್ಕೆ ಮೆಡಿಕೇಶನ್ಸ್ ಆಗಿರ್ಬೋದು, ಫುಡ್ ಆಗಿರ್ಬೋದು, ಕೇರ್ ಆಗಿರ್ಬೋದು, ಎವ್ರಿಥಿಂಗ್ ಹ್ಯೂಮನ್ ಕನ್ಸರ್ನ್ ಅಲ್ಲಿ ಆ ಆಕ್ಟಿವಿಟಿ ನಡೆಯುತ್ತೆ. ಸೊ ದಟ್ ಕೇಸ್ ಇಸ್ ನಾಟ್ ದೇರ್ ಒರಿಜಿನಲ್ ಹ್ಯಾಬಿಟ್ಯಾಟ್, ಅದಿರೋದು ಎಲ್ಲೋ ಅಲ್ಲಿಂದ ನಾವು ತಗೊಬಂದು ಇಲ್ಲಿ ಪ್ರೊಟೆಕ್ಷನ್ ಕೊಡ್ತಾ ಇದ್ದೀವಿ. ಸಚ್ ಟೈಪ್ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಕ್ಸ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್. ಓಕೆಮಾ. ಸೊ ಎಕ್ಸ್ ಸೈತು ಕನ್ಸರ್ವೇಷನ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ Off-site conservation. Off-site conservation. Off-site andre not their original habitat, out of their natural habitat. We protect, conserve threatened species out of their natural habitats. Natural habitat. That is called ex situ conservation. So ex situ conservation example, you can take zoological parks. All the zoological parks comes under ex situ conservation. Alliro animals, plants alla ಅದಕ್ಕೆ ನ್ಯಾಚುರಲ್ ಹೋಮ್ ಅಲ್ಲ, ನಾವು ಎಲ್ಲಿಂದ ತಗೊಬಂದು ಕಲೆಕ್ಟ್ ಮಾಡಿ ಅಲ್ಲಿ ನಾವು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಿರ್ತೀರಿ. ಸೆಕೆಂಡ್, ಬೊಟಾನಿಕಲ್ ಗಾರ್ಡನ್ಸ್. So in the botanical gardens, plant species, wide variety of plant species, we will collect from their natural habitat and we are giving protection and care in the botanical gardens. Third one, wildlife safari parks. Don't confuse with wildlife sanctuaries. Wildlife sanctuaries are in situ conservation. And wildlife safari parks are man-made created. All these are man-created environments, habitats. All in situ conservation examples are natural habitats. So these are man-created habitats. So zoological parks, botanical gardens, and wildlife safari parks are the some examples for ex situ conservation. Remember, very important that in the ex situ conservation recently added some advanced techniques also. Some advanced techniques also comes under ex situ conservation. What are those advanced techniques comes under ex situ conservation means, number 1, cryopreservation. Cryopreservation is one of the examples for advanced technique. An advanced technique, an example of ex situ conservation. Sir, what is cryopreservation? Cryopreservation means some gametes of extinct species of plants or animals. Suppose ಯಾವುದಾದ್ರೂ ಒಂದು ಪ್ಲಾಂಟ್, ಯಾವುದಾದ್ರೂ ಒಂದು ಅನಿಮಲ್ ಸ್ಪೀಸೀಸ್ ಇನ್ನು ಕೆಲವು ದಿನಗಳಲ್ಲಿ ಅದು ನಮಗೆ ಸಿಗೋಲ್ಲ, ಎಕ್ಸ್ಟಿಂಕ್ಟ್ ಆಗುತ್ತೆ, ನಂಬರ್ ತುಂಬ ಕಡಿಮೆ ಇದೆ ಅಂತ ಸಿಚುವೇಶನ್ ನಮಗೆ ಗೊತ್ತಾದರೆ, ಅದು ಬದುಕಿರೋ ಸಮಯದಲ್ಲಿ ಆ ಅನಿಮಲ್ಸಿಂದ ಅಥವಾ ಆ ಪ್ಲಾಂಟ್ಸಿಂದ ನಾವು ಗ್ಯಾಮೆಟ್ಸ್ನ ಕಲೆಕ್ಟ್ ಮಾಡ್ತೀರಿ. ಲೈಕ್ ಸ್ಪೋಮ್ಸ್ ಆಗಿರ್ಬೋದು, ಓವಾ ಆಗಿರ್ಬೋದು, ಪೊಲೆನ್ ಗ್ರೈನ್ಸ್ ಆಗಿರ್ಬೋದು. ಸೋ ಕಾಲ್ಡ್ ದ ಗ್ಯಾಮೆಟ್ಸ್ ಆಫ್ ಥ್ರೆಟೆಂಡ್ ಸ್ಪೀಸೀಸ್ ಬಿಕಮ್ಸ್ collected and that will be preserved in -196 degree Celsius in the liquid nitrogen medium alli, in viable conditions alli, viable and fertile conditions alli store mado, preserve mado process ne cryopreservation we call it. Cryopreservation means preservation of gametes of some threatened species in viable and fertile conditions for a long period of time in -196 degree Celsius in liquid nitrogen medium. Such type of preservation is called cryopreservation. Idunu ex situ conservation ge add madabodu. And the next one is tissue culture. Tissue culture. ನಿಮ್ಗೊಂದು ಡೌಟ್ ಬರ್ಬೋದು, ಸರ್ ಕ್ರಯೋಪ್ರಿಸರ್ವೇಷನ್ ಇಂದ ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಿರೋ ಗ್ಯಾಮೆಟ್ಸ್ ನಿಂದ ಆರ್ಗನಿಸಮ್ಸ್ ಹೆಂಗೆ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತೀರಿ ಅಂತ. ಬೈ ಇನ್ವಿಟ್ರೋ ಮೆಥಡ್ಸ್. ಓಕೆ, ಬೈ ಇನ್ವಿಟ್ರೋ ಮೆಥಡ್ಸ್ ಇನ್ ದ ಲ್ಯಾಬೊರೇಟರಿ ವಿ ವಿಲ್ fertilize that egg and develops into the new organism. So next one, tissue culture. You all know that many plant species are propagated by using tissue culture. Tissue culture is also one of the examples for ex situ conservation. And next one, seed bank. Seed banks. So in the seed banks, what we do? We collect some extinct or threatened species of plants. So those seeds will be stored in the seed banks in a proper method of techniques without losing that seeds viability and fertilizing capacity, germination capacity ಹೋಗ್ದಿರಾ ಆ ಲೈವ್ ಕಂಡೀಷನ್ಸ್ ಅಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡೋ ಪ್ರಾಸೆಸ್ನೇ ಸೀಡ್ ಬ್ಯಾಂಕ್ಸ್ ಅಂತಾರೆ. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ಕಮ್ಸ್ ಅಂಡರ್ ದ ಎಗ್ಸ್ ಆಯಿತು ಕನ್ಸರ್ವೇಷನ್. ಓಕೆ, ಈ ಎಕ್ಸಾಂಪಲ್ಸ್ ಎಲ್ಲ ಪ್ರಾಪರ್ ಆಗಿ ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರಮ್ಮ. ಆ್ಯಂಡ್ ಲಾಸ್ಟ್ ಒನ್, two conventional events occurs for the purpose of biodiversity. So that is one is Earth Summit, second one is World Summit. First was Earth Summit. Earth Summit was held in place Rio de Janeiro. Where it is happens ma? Earth Summit was held in Rio de Janeiro in the year of 1992. What is the year of held Earth Summit ma? So 1992. What is the place? Rio de Janeiro. For this purpose, how many countries in the world are attended? Andre almost all countries are attended for the Earth Summit. Okay, so in that Earth Summit, about what they discussed, what is the aim of Earth Summit means very simple, for the conservation of biodiversity. They discussed about ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಬಯೋಡೈವರ್ಸಿಟಿ. ಈಗಿರೋ ಸ್ಪೀಸಸ್ನ ನಾವು ಹೆಂಗೆ ಕಾಪಾಡಬೇಕು, ಹೆಂಗೆ ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಬೇಕು, ಯಾವ ಮೆಥಡ್ಸಿಂದ ನಾವು ಕನ್ಸರ್ವ್ ಮಾಡಬೇಕು ಅನ್ನೋ ವಿಷಯನ ಡಿಸ್ಕಸ್ ಮಾಡಿ ಎಲ್ಲ ಕಂಟ್ರಿ ಸೈಡಲ್ಲಿ ಅವರವರು ಅದನ್ನು ಅಪ್ಲೈ ಮಾಡೋ ಥರ ನೋಡ್ಕೊಂಡಿದ್ದಾರೆ. ಸೆಕೆಂಡ್, ಸಸ್ಟೈನಬಲ್ ಯುಟಿಲೈಸೇಷನ್ ಆಫ್ ನೇಚರ್ ಬೆನಿಫಿಟ್ಸ್. ಸಪೋಸ್ ಒಂದು ಸ್ಟೇಟಲ್ಲಿ ಎಕನಾಮಿಕ್ ಬೆನಿಫಿಟ್ಸ್ ಜಾಸ್ತಿ ಇರ್ಬೋದು, ಕಡಿಮೆ ಇರ್ಬೋದು, ಅದು ಒಂದು ಸ್ಟೇಟಿಗೆ ಒಬ್ಬರಿಗೆ ಮಾತ್ರನೇ ಸಿಗೋ ಥರ ಮಾಡಿದಿರ ಸಸ್ಟೈನಬಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಈ ಥರ ಮಾಡಬೇಕು ಅನ್ನೋ ವಿಷಯನ ಅವ್ರು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದಾರೆ. ಆ್ಯಂಡ್ ದ ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ ಕಾಲ್ಡ್ ವರ್ಲ್ಡ್ ಸಮಿಟ್. ವರ್ಲ್ಡ್ ಸಮಿಟ್ held place is Johannesburg in South Africa. Johannesburg of South Africa dalli World Summit was done, and in which year means in the year of 2002. How many countries are attended for this meeting? Andre 190 countries. And what is the aim of this summit? So in this summit they discussed about that the significant reduction of rate of biodiversity loss at global level, regional level and local level ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದಾರೆ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಆ್ಯಂಡ್ ದಿಸ್ ವೀಕೆಂಡ್ ಎಕ್ಸಾಮ್ ಸಿಲೆಬಸ್ ಸ್ಮಾಲ್ ಚೇಂಜ್ ಇರುತ್ತೆ. ಒನ್, ಎವಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್, ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಒನ್ ಆರ್ಗಾನಿಸಮ್ಸ್ ಆ್ಯಂಡ್ ಪಾಪ್ಯುಲೇಷನ್, ಆ್ಯಂಡ್ ಥರ್ಡ್ ಒನ್ biodiversity and conservation, and fourth one body fluids and circulation. Breathing and exchange of gases will be in the next week. Okay ma? So this week body fluids and circulation, and tomorrow we'll discuss some more complicated and important topics from the body fluids and circulation. Is it clear? Thank you.
Okay, Nama. Good afternoon, all of you. Okay, Nama. Yesterday, gravitation up to variation of the small g value. So, variation of the small g value is complete, Amma. Today, concept energies. So, energy of the satellites revolves around the planet, and orbital velocity and escape velocity. That three concepts are pending in the gravitation chapter. Now, one by one. First point, kinetic energy. Kinetic energy of the planet. For example, kinetic energy of the planet is revolves around the sun, or satellites are is revolving around the planet. Both are same. Now listen. This is the planet like mass m. This is the one satellite of mass small m is revolving in a circular orbit. Radius is r. That's why in between them, what is the force? Gravitational force. The gravitational force is acting toward the center. So that force is also known as a centripetal force. Therefore, gravitational force is known as a centripetal force. What is the gravitational force? Gmm by r square. Centripetal force mv square by r. One r value square cancel amma. Here mv square, here gmm by r. Take them two on both sides amma. Take them two amma is a denominator and take them on both sides. Half mv square is nothing but kinetic energy. So gmm by 2r. So kinetic energy is nothing but gmm by 2r. Very, very important point. Next, another point, potential energy. This is the mass m, this is the another mass m. In between them, what is the distance? Small r. What is the potential energy? That potential energy is equal to minus gm1 m2 by r. Minus gm1 m2 by r. Negative sign shows that gravitation is always attraction. Negative sign shows that gravitation is always attraction. So this is the potential energy. Now, total energy. Total energy. Total energy is equal to Ke plus Pe. Ke this value, Pe this value. Both are adding, we get so both are adding, we get the total energy minus gm1 m2 by 2r. Now we can observe them, the kinetic energy is equal to kinetic energy and the total energy, we can observe them both are same. But here total energy value minus, kinetic energy value plus. So kinetic energy is equal to minus of total energy. Total energy value minus of kada, minus of minus plus ega, we get the kinetic energy. Potential energy is equal to 2 times of the total energy. Potential energy like this one ega, this value multiplying and dividing by 2 amma. 2 into minus gm1 m2 by 2r minus gm1 m2 by 2r into total energy nega, like 2 times of the total energy, we get the potential energy. So these 2 points are is the very important. Sometimes is asking that when a planet or a satellite, anyone is revolving around the planet, satellites are is revolving around the planet, what is the kinetic energy and the potential energy ratio? Kinetic energy value here how much minus 1, no. Potential energy value 2. Minus total energy 2 into total energy. Total energy value cancel minus 1 is to 2. So that point are the important Already this concept is similar to that of atoms. In atoms, the electrons are is revolving around the nucleus. That case also kinetic energy is equal to minus of total energy. Potential energy is equal to 2 times of the total energy. All are same number. So this is the one of the important model. Now next point. This is the earth, mass m and radius capital R. When a small particle of mass m is placed on the surface, what is the gravitational potential energy U is equal to minus gm1 m2 by capital R. Because of the planet mass m, that total mass is acting at the center to center like capital R. Same question. M mass, radius is R amma, at a height h amma. This body mass is M at a height h. What is the gravitational potential energy? Minus G M1 M2 by R plus H. Okay, this is the another point. Now, one of the important example amma, previous NEET question minimum 2-3 times are given. A body mass M initially at the surface is towards or moving at a height h from the surface. What is the work done? What is the work done? Find the work done to move a particle from the surface to a height h amma. So the work done to move a particle from surface to height h from the surface. From the surface to height h over. That height value can be taken from the surface amma. What is the work done? Already we know that. What is the initial amma? Initial potential energy minus G M1 M2 by R ega. This is the initial. Final amma at a height h amma minus G M1 M2 by R plus H. What is the work done? That work done is equal to UF minus UI. UF minus UI. So final amma minus initial like this one gamma minus of minus plus. So G M value common 1 by R minus 1 by R plus H. R into R plus H amma, take the LCM ra, here ammo R plus H minus R. Both are cancel. So the amount of the work done to move a particle from the surface to a height h is nothing but W is equal to G M H by R into R plus H. Very important formula. This work done amma in terms of capital G. For example, that work done amma in terms of small g, how to solve that one? Here amma already here what is that? Gm. Already we know that small g is equal to Gm by R square ega. Therefore, Gm value amma Gr square ega. Gr square. What is the remaining value amma? Mh by R into R plus H. One R value square cancel amma. Mgh. This R value take them denominator amma. R plus H by R. 1 plus H by R. The amount of the work done is Mgh by 1 plus H by R. Very important formula amma. This formula in terms of capital G. This formula in terms of small g. So these two are the very important formulas. The amount of the work done to move a body from the surface to a height h. Mgh by 1 plus H by R. Or Gmmh by R into R plus H. Important formulas. Now, that previous question summa in that gravitational potential energy concept. Now listen carefully. That question is 2019 question. 2019 question. The work done to raise a mass m from the surface of earth to a height h. That height value is equal to radius of earth. Like initially body mass on the surface of earth to a height h, that height value is equal to how much amma? Radius of earth. How much of the work is done from the surface to a height h? Now what is the work done formula? Mgh by 1 plus H by R. Main this formula is the important compared to that one amma. Number of the problems is given by this formula. So Mg height value R. 1 plus height value R. R value one time. mgr by 2. So the work done is mgr by 2. Next model amma. Okay, 2016 question. 2016 question. What is the question is given? A satellite of mass m is orbiting of Earth to a height h from the surface. This is the planet. A satellite is revolving around the planet, height h. The total energy of the satellite in terms of G naught, right, is asking the total energy value, the total energy value in terms of G naught, where G naught is the acceleration due to gravity on the surface of Earth. Right. What is the formula, Namma? Already we know that. What is the total energy formula? Minus Gmm by, what is the value, Amma? 2r. Generally 2r, where r is the distance from the two bodies, kada. But this is the Earth, gamma. Earth radius is r, like a planet radius is r. This value height is h. That's where center to this body center, how much, Amma? Minus Gmm by 2 into r plus h. Problem over. But actually, that's the total energy value you can explain in terms of G naught. Already we know that where G naught is nothing but Gm by r square. Therefore, Gm is equal to G naught r square. Therefore, total energy is equal to minus this Gm value is how much, G naught r square into small m by 2 into r plus h over. So what is the total energy, minus mg naught r square by 2 into r plus h. So minus mg naught r square by 2 into r plus h. That is the problem. This is the given on 2016. Next one. Another question, 2013. 2013. A body of mass m is taken to a height from the surface of the earth is equal to twice the radius of the earth. Initially, a body is on the surface, is taken to a height is equal to twice the radius of earth. Then what is the change in potential energy? That's why is asking the change in potential energy. What is the meaning of change in potential energy, Final minus initial potential energy, final potential energy minus initial potential energy. That final potential energy minus initial potential energy like a work done. That's where how much value we get, mgh by 1 plus h by r. So mg height value, 2r. 1 plus 2r by r. 2mgr by 2mgr by 1 plus 2, 3. 2 by 3 mgr. 2 by 3 mgr. So this is the another important problem. Same model is repeated 2013 and another year same model. Now next, another model, okay, now another model is, now listen, now this satellite, this is the planet, Now this satellite is revolving around the planet. That's why the total energy remains constant. What is the total energy? Already they having the some velocity means they having the some kinetic energy. They having the some distance means they having the potential energy. So when a satellite is revolving around the planet whose total energy is conserved, already we know that total energy is always conserved. Okay, total energy is nothing but kinetic energy and potential energy. Okay, Nama. That is another important. Already we know that. One example. Now that is the 2024 question. 2024 question. The minimum energy is required to launch a satellite of mass m from the surface of Earth of mass m and a radius r in a circular orbit of altitude 2r from the surface of Earth. Now listen. This is the satellite. Mass m, radius is r. Radius is r. Initially one satellite is revolving on the surface . So once some energy is required due to that some energy it is moving to a height 2r. Moving to a height 2r from the surface . This is satellite like this one. What is the energy is required? What is the energy required to move a satellite of mass small m from the surface to 2r height? What is the energy required? Now listen carefully. From this point to this point, how much of the energy is required? Already we know that this satellite is revolving and the kinetic energy is there and having the potential energy is there. This is moving to another orbit. Here also total energy is conserved, but is asking the how much of the energy, like this one some velocity can be projected. That's why what is the kinetic energy is required. How much of the kinetic energy is required to move them from the surface to a height 2r? Law of conservation of energy. Now according to law of conservation of energy, total energy initial is equal to total energy final. What is the total energy? Here kinetic energy. We don't know. Our aim is to finding the kinetic energy. What is the potential energy on the surface? Minus Gmm by R. Kinetic energy plus potential energy. Now in this one, kinetic energy plus potential energy is known as total energy. What is the total energy? Minus Gmm1 m2 by 2r. 2r. R and like radius. What is the radius from center to that orbit? R plus 2r. Like 3r. The total radius is 3r. Therefore, that kinetic energy is equal to, take them on right side, minus Gmm by 6r. So Gmm by r value common. 1 minus 1 by 6. So we get 5 by 6. So Gmm by r. Therefore, the kinetic energy is 5 by 6 Gm1 m2 by r. That is the model is the given on the previous. So only kinetic energy and potential energy concept are based on some important points. Like next one, orbital velocity. Orbital velocity. What is the meaning of orbital velocity? Now this is the planet of radius r and mass m. The minimum velocity of the body is projected horizontally at a certain height. One body is projected horizontally certain velocity. By that velocity, it is moving in a circular orbit. It is moving in a circular orbit. That minimum velocity is nothing but orbital velocity. What is the value of orbital velocity? Root gr. Already derivation part we have the idea. Only I am explaining the concept that V value root gr. And also equal to root gm by r. And also equal to root gm by r. Small g is nothing but gm by r square ga. One r value cancel, we get gm by r. Here this satellite mass is there in that equation? No ga. So orbital velocity is independent of the mass of the satellite. V naught is independent of mass of satellite. Mass of the satellite. So that value already we know that capital G mass of the earth, and like G is the acceleration due to gravity 10, R is the radius of earth. Solve them, we get 8 km per hour per second. 8 km per second. Okay, number. So that is another important point. Now listen carefully. Now V naught is equal to root G by R. Mass value can be written as volume into density. Volume 4/3 pi r cube into density ga. This r value here cancel ga. 4/3 G pi r square d ga. 4/3 G pi all values are constant ra. Root r square means r root d. So orbital velocity directly proportional to r root d. One of the important point orbital velocity is directly proportional to root r into d. Sometimes is given. Find the ratio of the orbital velocity of the two different planets whose radius are r and 2r having the same density. Having the same density, this value constant to orbital velocity directly proportional to r. Only this formula can be used in a problem is the given in terms of density. Otherwise take them root gm by r, root gr, depending upon the numerical. So very, very important concept. Right, Amma? Another point, escape velocity. Escape velocity. Now listen, in this one very, very important concept, every time model is repeated in this one. Now this is the earth whose radius is r, mass is m. Radius is r, mass is m. Three different cases, very, very important cases. Now listen carefully. Here, one body is projected with a certain velocity. Now, let us assume gravitational field only up to here. After this, total is nothing but there is no gravitational field. So, the minimum velocity when a body can be projected, it escaping from the gravitational field. It escaping from the gravitational field. That velocity is known as escape velocity. That velocity is known as escape velocity, just to escaping from the gravitational field. That means this body just overcoming the gravitational field whose final velocity is 0. Whose final velocity is 0. Just gravitational field up to region here field is there this point is there field is not there just body crossed the gravitational field and velocity becomes 0 like ideal case that corresponding velocity is known as orbital velocity. This height that case take them infinity. So that's why what is the orbital velocity root 2gr. And also root 2 gm by r. Root 2 gm by r. Just by that velocity, the body just overcoming the field and velocity becomes 0. Both cases conditions are satisfied. That's why the escape velocity is nothing but 2gr and root 2 gm by r. Velocity value 0. Kinetic energy value is how much? 0. Just height value infinity minus g m1 m2 by r like r is nothing height kada. height value infinity, anything by infinity 0. What is the potential energy value amma? 0. That's where what is the total energy? Kinetic energy plus potential energy 0 nega. So when your body projected upwards amma, entire the path amma, the total energy value 0. The total energy value 0. One of the important theory point amma. So our escape velocity is root 2gr, root 2gm by r. And the total energy at any point in its path amma, the total energy value is always 0. Another important theory point. Now go to the another point. Now again this is the field region. Now this is the field region. Now here amma, the body projected with a certain velocity greater than escape velocity. Greater than escape velocity. What happens amma? In case of the greater than escape velocity amma, just escaping the velocity is given the final velocity 0. But given greater than escape velocity ga, in case of the greater than escape velocity, at this point they having the some velocity. At the infinity height they having the some velocity. That is known as velocity of the interstellar space. And interstellar space means the vacuum ega, and that vacuum they having the velocity v infinity. What is the value of that v infinity? Root of v square minus v square. Very, very important formula. V infinity at the point at height infinity. What is the velocity amma? Root of v square minus v square. Now listen amma, in this point amma, velocity is there gamma and the kinetic energy is there. But height value infinity ga, potential energy value 0. That's where what is the total energy? Kinetic energy plus potential energy. Potential energy value 0 and only kinetic energy nega. Kinetic energy value already we know that is the plus kada, and both are adding the total energy value positive. Total energy is positive. One of the theory point. Total energy value positive. And the velocity at the infinity root of v square minus v square. Another important point. Okay, now third case. When the projected velocity less than escape velocity. Exactly give the escape velocity amma, at infinity it going to infinity velocity becomes 0. But given velocity less than escape velocity means the body is not reaches to the infinity height. Maybe it is reaches to certain height amma, velocity becomes 0 nega. Velocity becomes 0 nega. Now that height is nothing but h. Height is nothing but h. That's why the projected velocity and height relation v square is equal to 2gh by 1 plus h by r. Very, very important formula. V is nothing but projected velocity. That projected velocity is compulsory less than escape velocity. At the case v and height h relation v square is equal to 2gh by 1 plus h by r. Very, very important formula. Now listen, here velocity becomes 0 means kinetic energy value 0 nega. Certain height is there means potential energy value is there ga. What is the total energy value? Kinetic energy 0, only potential energy ga. Already we know that potential energy value negative ga. And total energy means Ke plus Pe. Ke value 0 and total energy like potential energy. Potential energy means like negative and total energy is negative. Total energy is negative. So that's why these three cases are the very, very important. In the last 4-5 years 2-3 times is the given in this concept. When the projected velocity is greater than escape velocity, what is the velocity at the infinity place or velocity of the interstellar space, velocity of the body at the interstellar space, root of v square minus v square. Less than escape velocity amma, certain height velocity becomes 0. What is the maximum height amma? V square is equal to 2gh by 1 plus h by r. This height is nothing but maximum height. Just give the escape velocity when at the infinity velocity becomes 0. So these three cases are the important one. Now listen, that escape velocity 2gm by r or root 2gr, g value 10, R value 6400 kilometers. Value simplifying, we get 11.2 kilometer per second. So when a body is projected with 11.2 kilometer per second body is moving 11.2 kilometers, then it is escaping from the gravitational field. So that is the another point. In this one, is there any particle mass m is there, not there, gara. So VE also independent of the mass of the body. Escape velocity is independent of mass of the body. Escape velocity is independent of the mass of the body. Next, in this one projected, it reaches to the infinity region. For example, this body projected like this, vertical some angle theta. What happens, this body is projected, this body is projected, makes some angle with the vertical theta. That's why again the body reaches to the infinity. So escape velocity is independent of the angle of the projection. VE is independent of angle of projection. VE is independent of angle of projection. Now another point, VE is equal to root 2 by R G as it is. Mass means volume into density. Again, this R value, here R square times, then what is the value of VE is proportional to root R. VE is directly proportional to R into root rho. Rho is nothing but density. Orbital velocity and escape velocity, radius and density relation same. Because of here 2gm by r, orbital velocity gm by r, same relation proportionality. VE is directly proportional to R into root rho. So that's why all are the important cases. Okay, these points are the very, very important cases, right? So note them, final formulas are the important. Now we can explain the 2-3 models. Now listen, in a 2021 question, a particle of mass m is projected with a velocity kve, where k value less than 1 from the surface of the earth. What is the maximum height above the surface of the earth body reached them? Here k value less than 1. Less than 1 means V value is less than VE nega. In case of the VE value less than VE, it is not reaches to the infinity height. Third case, it is not reaches to the infinity. It is not overcoming the gravitational field. Certain height is above and its velocity becomes 0. V value less than VE. This is the gravitational field region up to here. This height is h how much? What is the formula I am asking? I am given V square is equal to 2gh by 1 plus h by r. What is the value of V is given, kve square, k square, k square, VE square. VE means escape velocity. Whole square gara 2gr. Okay, so kve, k into VE root 2gr. Whole square, k square into root 2gr. 2gh by 1 plus h by r. 2g cancel. Here only h k square r into 1, k square r. K square r into h by r. R value cancel only k square h. R k square is equal to this value, take them another side and h value is common. Therefore h is equal to r k square by 1 minus k square. R k square by 1 minus k square. That is the maximum height. if the projected velocity is nothing but less than escape velocity. The projected velocity is less than escape velocity. This is the formula, amma. Very, very important formula. In a problem, amma, is asking what is the height of the body from the surface, amma. From the surface, amma. Sometimes, what is the maximum height of the body from the center of the earth? Like this is the height h gamma. In case of the is asking the center of the earth, like r. What is the total height, amma? R plus h. So this r plus this height value, we can add them, we get the answer. Because of this question is also given on the previous year. So see them very carefully. Height value is asking go from the center of the earth, from the surface of the earth. From the surface of the earth means problem is over. From the center of the earth means r plus h. R plus this height value, amma, we can add them, we get. So this is the one of the model. Next one. (2023) question. 2023 question. The escape velocity of the body on the surface of the earth is how much, amma? 11.2 km per second. Already we know that. But the same body projected upwards with a velocity 22.4 km per second. Velocity is equal to 22.4 km per second. That's why what is the velocity of the body at infinity distance from the center of the earth? Here at infinity distance, what is the velocity? What is the velocity is asking. Now listen, the projected velocity 22.4, but escape velocity 11.2, and this value can be written as 2VE nega. 2 into 11.2, 22.4 and the projected velocity is how much, 2 times of the escape velocity. Already we know that projected velocity greater than escape velocity. What is the velocity at the infinity distance? Root of v square minus ve square. What is the value of projected velocity? 2ve. 2ve whole square 4ve square minus ve square. How much, 3ve square. How much? Root 3 into ve. Root 3 means 1.732 into 11.2. We get kilometer per second. Answer is the given root 3 into 11.2. So that's where problem is over. So 22.4 means 2 times of the escape velocity. 2 times of the escape velocity. So that's where v infinity is equal to root of v square minus ve square. What is the projected velocity, 2ve. 2ve whole square 4ve square minus ve square 3ve square. Root 3 into ve square means root kada ve. That value 11.2. Answer is the given like this one. Root 3 into 11.2. Okay. So that is the one of the model is the given on the previous one. Next another model. Now listen, 2021 question. 2021 question. The escape velocity from the surface of the earth is Vm. Already we know that escape velocity from the surface of the earth is V. Next, the escape velocity from the surface of the another planet. This is the earth mass m, radius r m. This is the another planet m. In another planet having the radius is 4 times of that of earth. Radius value is 4 times that of the earth, 4r, and having the same density, very good, and having the same density. That's why what is the escape velocity? That's where what is the escape velocity? Now this is the question. Already we know that. Here value, one term is given. Both planets are having the same density. In case of the same density, escape velocity is proportional to r into root rho nega. Already we know that. First case lo, what is the orbital velocity? V. Second case lo, V1, don't know. First one having the radius r, second one having the radius 4r, density value same a. Both are cancelled. Therefore, V1 is equal to 4V. What is the escape velocity, amma? 4 times of that of the earth. 4 times that of the earth. That's why this body go to the infinity height. Okay, nama. That is the another problem, 2021. Okay, Nama. Now, another, any questions are there, Amma? Right, Amma. Now, another question, 2016, Amma. 2016. The ratio of the escape velocity of the earth, the ratio of the escape velocity of the earth to that of planet. Okay, Nama. But whose radius? The planet radius is twice that of earth. Twice that of earth of same mean density. Of same mean density. Again, same model. Having the same mean density. What is the escape velocity of the earth? Already we know that r proportional to root rho. Rho value same. Escape velocity VE. Earth demo V. For a planet demo like radius 2r. This one escape velocity of the planet. This one r. For planet 2r. Ratio is 1:2. So, these all the questions on the given on the previous questions. Now, one more concept is remaining. Now, listen, another point. Kepler's laws. Kepler's laws. So, in Kepler's laws, there are the 3 laws are there, and that first one is, what is the first one, Amma? Right, all the planets are revolves around the sun in elliptical orbit when sun is at one of its focus point. For example, in ellipse, this is the ellipse, Amma. So, in ellipse, actually, they are having the 2 focus points are there, Amma. This is the 1 and 2. But take the 1 focus point, sun is there. All the planets are revolving around the sun in elliptical orbit when sun is at one of the focus point. Okay, that is known as Kepler's first law. Now, listen carefully, Amma. Planets are revolving, planets are revolving. This one is 2a, semi-major axis. Semi-major axis. This one is 2b. That one is the 2b, semi-minor axis. Semi-minor axis. Okay, now listen. Here in this side, the distance value small. In this side, the distance value large. This one R1, this one R2. Okay, where the planet is nearer to the sun, that is known as a perihelion. Perihelion position. Perihelion. Where the planet is a larger distance, where the planet from the sun larger distance are there, that is known as ephelion. That is the ephelion position. Nearer, that planet nearer to the sun is nothing but perihelion position, larger distance ephelion position. Okay, that is the another important point, amma. Right. This is the first law. Now, second law. Now listen, this is the sun location. This is the 2B. This is the 2A. When a planet is traveling the equal areas in equal intervals of time, or the line joining the planet to the sun sweeps equal areas in equal interval of time, that is known as Kepler's second law. For example, this is the planet position. Planet position, we can draw the one radius vector. In t seconds, reaches in this position. How much area is covered, this one, that planet is continuously moving, for example, in this position. It is moving like this point. How much area? This area, for example, here take them t1 time, here I am take them time t2. But if t1 is equal to t2, then a1 is equal to a2. This area a1, this area a2. The line joining the planet to the sun, and this line, like radius vector, sweeps equal areas in equal intervals of time. Here area A1 and A2 both are same, then times are also same. That is known as Kepler's second law. Now another important point. In that second law, the angular momentum is conserved. Angular momentum L is equal to mvr, that is the constant. So when a planet is revolves around the sun, whose angular momentum is conserved, so entire the patra mass value same, and only v is inversely proportional to r. That's why here this is the less distance, this is the larger distance. In this one they having the velocity v1. In this position the velocity is v2. Which one having the more velocity? Inversely proportional to distance. Less distance having the more velocity. More distance having the less velocity. So that's why here v1 is greater than v2. Less distance having the more velocity. More distance having the less velocity. v1 is greater than v2. That is the another important point. So when the sun, when a planet is reaches to the nearer to the sun, that speed is more. When the planet is reaches to the larger distance, whose speed is less, by the Kepler's second law. That is the another important point. Right. So these 2 points are the very important one. Now third rule. This is the sun location, this is the semi-major axis 2a. Now this is the planet. Planet is revolves around the sun in elliptical orbit. The square of the time period of the planet, is directly proportional to cube of the semi-major distance. Cube of the semi-major axis. Cube of the distance of the semi-major axis. T square directly proportional to a cube. That is the another important point. So Kepler's first law, second law, and third. So these 3 are the important points. So one question is the given on the previous NEET, we can explain them. 2 questions, 2 more questions are there. Now listen carefully. That is the 2018 we can check them. This is the elliptical path. This is the sun location. There are the 3 points are given, A, B, C. This is the sun position. That's why what is the ratio of the kinetic energy of the particles? What is the ratio of the kinetic energy of the particles at A, at B, at C? What is the ratio, not relation between the Ka, Kb and Kc? Now listen, actually in the total entire the path, point A is the least distance. Least distance having the more velocity and this one having the highest kinetic energy. Least distance having the more kinetic energy. Enter the path, this is the large distance. Large distance having the less velocity. Less velocity is nothing but less kinetic energy. Least one is nothing but Kc. But B compared to A value more compared to this value is less, like middle. So Ka greater than Kb greater than Kc. So this is the 2018 question. Now one more question. 2019 question. The time period of the geostationary satellite is 24 hours. Time period is 24 hours. Geostationary satellites whose time period value is 24 hours. At a height 6r from the surface of earth. This is the earth. At a height 6r. This is the satellite. Is revolving around the earth. What is the time period? 24 hours. That height value is given from the surface of the earth. Next, the time period of the another satellite whose height is 2.5 radius of the earth from the surface. Again radius r whose satellite height 2.5 r. What is the time period? What is the time period? Now this is another question. Now listen, already we know that the Kepler's third law, the square of the time period of the planet is directly proportional to cube of the semi-major axis. Not only on that one, in circular path is also it is applicable. So that's why t square is directly proportional to r cube. Here a and semi-major distance cube of the semi-major. Here am a radius. So both are same one. T1 by T2 whole square is equal to R1 by R2 whole cube. What is the initial time period? 24. Second one don't know. What is the first one? Radius. Actually distance is given from the surface. But R is nothing but a radius of the satellite. This is the circular orbit. Circular orbit radius can be taken from the center. Surface how much? 6r. From the center another r. Total is how much? 7r. Here this value name 2.5. From the center another r. 2.5 plus r. 3.5 r. That is the question, the important one. R value cancel 3.5 here 2 times 2 times. That's why how much 2 cube 8. 2 cube 8. Right, next apply the root on both sides. Root applying ante 24 by T2 negada root ante square root 2 cancel. Root ante root 8. How much 2 root 2. Therefore T2 value 24 by 2 root 2. Here how many times 12 by root 2. And also this value 6 into 2 6 2s are 12 this value how many times root 2 times. 6 root 2 hour. Option is given in terms of 6 root 2. So that is the another important model. Is given in 2019 question. So initially 6r that height value can be taken from the surface but actually radius value can be taken from the center like 7r. Here 2.5 from the surface. But a radius value can be taken from the center gamma like 3.5 r. In this problem, the main point are the 7 r and 3.5 r. So that is the another important model. Amma. So these two questions are is the given on the previous year. Next, another model. Now, all have see the another model. Actually, this question is the given in 2000 AIPMT 2012. AIPMT 2012 question. Now, what is that? The height at which the weight of the body becomes. The weight of the body at a height is 1/16th of weight of the body on the surface. The height at which the weight of the body is 1/16 times of the weight of the body on the surface. That's why what is the height value? What is the height? That is the question. AIPMT 2012. First, already we know that GH is equal to, now I am giving the options also. Because of options are the very important here 3R, 4R, 5R and 15R. Why I am giving the options? We can observe them each option height value is comparable to radius. That's where I am giving the option. GH is equal to G into R by R plus H whole square. The height value is comparable to radius of the earth. That's why take this formula. If height value is very less than r, GH is equal to G into 1 minus 2H by R. Comparable like this. Like this one, take them m value multiple here, value does not change. Value does not change. And this is nothing but weight of the body is nothing but at a height. Now listen, that WH value like this one. What is the condition is the given? Weight at H value is equal to 1/16th of the weight on the surface. What is that height value is how much? mg into R by R plus H whole square. This value like this one. 1/16th of what is the weight of the body on the surface like mg. Weight of the body on the surface mg. Here mg value cancel. Apply root on both sides. Root on both sides R by R plus H. Here 1/4. Take them cross multiplication. 4R is equal to R plus H. R value take them here. 3R is equal to H. Therefore, height H is equal to 3R. Height H is equal to 3R. That is the 2012 question. Already I am explaining. Previous NEET questions are also GH and a height at a depth problems is the given number of times. So that models do them number of times. Next another question 2012 same AIPMT in 2012 also another question is given. VE is the escape velocity and V0 is the orbital velocity of the satellite revolves around the earth. What is the relation between them? What is the relation? Already we know that escape velocity root 2gr, orbital velocity root gr. Therefore, VE take them root separate root 2 separate root gr. Root gr means V0. VE is equal to root 2 into V0. That is the another question is the given 2012. Now same question AIPMT 2011. A planet is revolving around an elliptical orbit. A planet is revolving along an elliptical orbit, is closest to the sun at r1 and farthest distance at a distance r2. Like this is the elliptical orbit, this is the sun location, closest distance r1, longest distance is r2. V1 and V2 are the velocity at this point. Here in this point velocity V1, in this point what velocity is V2. That's why what is the ratio of V1 by V2? What is the value of V1 by V2? Already we know that when the planet is revolves around the sun in elliptical orbit, angular momentum is constant. Angular momentum is nothing but mvr. So mass of the planet is remain same, that is leave it. Vr value constant means V1 R1 is equal to V2 R2 nega. Therefore, V1 by V2 is equal to R2 by R1. V1 by V2 is equal to R2 by R1. So, that is the 2011 question. Okay, Namma. On next class, Amma, we can continue, Amma. Right. So, on tomorrow class, Amma, oscillations. Oscillations, Amma, we can continue on tomorrow class. Okay, thank you. One 1:30 start chesina sir. అయ్యి ఖాళీగా ఉన్నాను.
Hello all. Today we shall start concepts from electrochemistry. Instead of discussing the synopsis again, I would like to continue with the same kind of question solving. The first question in electrochemistry is, we are given electrode potential of Fe plus 2 Fe as x volt and that of Fe plus 3 Fe is y volt, then E naught Fe plus 3 Fe plus 2 is how much is the question. ಎರಡು ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ಸ್ ಕೊಟ್ಟು ಬೇರೆ ಒಂದು ರಿಯಾಕ್ಷನಿನ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲನ್ನು ಕೇಳಿದ್ದಾಗ ನಾವು ಡೈರೆಕ್ಟಾಗಿ ಕಂಪೇರ್ ಮಾಡಲಿಕ್ಕೆ ಬರಲ್ಲ, ಇದಕ್ಕೆ ಹೆಸ್ಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಹೆಸ್ಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕಂದ್ರೆ ವೋಲ್ಟೇಜಸ್ಗೆ ಹೆಸ್ಲಾ ಅಪ್ಲಿಕಬಲ್ ಆಗಲ್ಲ, ಸೊ ನಾವು ಎನರ್ಜಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು ಇದನ್ನು. ಸೊ ವಿಲ್ ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ಗಿಬ್ಸ್ ಫ್ರೀ ಎನರ್ಜಿ ಈಕ್ವೇಷನ್ಸ್. ಫಸ್ಟ್ ನಾನು ಈಕ್ವೇಷನ್ಸ್ ಬರೀತೀನಿ. Fe plus 2 electrons gives rise to Fe. Fe plus 2 Fe ಆಗ್ತಾ ಇದೆ, ಸೊ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಗೈನ್ ಮಾಡಿಕೊಂಡು Fe ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ, ವಿಚ್ ಈಸ್ E naught Fe plus 2 slash Fe equals x. Whereas Fe plus 3 plus electron gives rise to Fe plus 2. ನಮಗೆ Fe plus 3ರಿಂದ Feಗೆ ಬರಬೇಕಂದ್ರೆ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡಬೇಕು, ಆ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ಗೆ ಅದು Fe ಆಗುತ್ತೆ. ದೇರ್ಫೋರ್ E naught Fe plus 3 slash Fe equals y. ನೆಕ್ಸ್ಟ್ ಒನ್, ಇವಾಗ Fe plus 3 Fe plus 2 ಆಗೋದನ್ನು ನೋಡಬೇಕು. ದೇರ್ಫೋರ್ Fe plus 3 plus ಎಲೆಕ್ಟ್ರಾನ್ gives rise to Fe plus 2 ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ. ಈ Fe plus 3 plus ಎಲೆಕ್ಟ್ರಾನ್ Fe plus 2 ಆದಾಗ E naught ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಅನ್ನೋದು ಇಲ್ಲಿ ಕ್ವೆಶ್ಚನ್. ಇದರಿಗೋಸ್ಕರ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದರೆ, ಫಸ್ಟ್ ಗಿಬ್ಸ್ ಫ್ರೀ ಎನರ್ಜಿಯನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ. ಫಸ್ಟ್ ರಿಯಾಕ್ಷನ್ಗೆ ಗಿಬ್ಸ್ ಫ್ರೀ ಎನರ್ಜಿಯನ್ನು -N1 Fe naught 1 ಅಂತ ಬರೀತಾ ಇದ್ದೀನಿ. ಇದಕ್ಕೆ -n, number of moles of electrons is 2, F into E naught value is x. That means it is -2xF. Whereas for the second reaction, delta G naught 2 equals -N2 Fe naught 2 ಅಂತ ಬರೀತಾ ಇದ್ದೀನಿ. ಇದಕ್ಕೆ ನಮಗೆ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದ್ದಾವೆ. 3 into F into value of y has to be written, so -2yF. ಇವಾಗ ಇದಕ್ಕೆ ಕೂಡ ಅಪ್ಲೈ ಮಾಡೋಣ. ಡೆಲ್ಟಾ G naught 3 equals -N3 NF E naught 3, 1 into F into E naught 3, the value of E naught 3 when we consider, which we do not know, so I am just writing it as -E naught 3F. ಇದಿಷ್ಟು ಬರೆದಿದ ಮೇಲೆ ನಾವೇನು ಮಾಡಬೇಕು, ಈ ಈಕ್ವೇಷನನ್ನು ಈ ಎರಡು ಈಕ್ವೇಷನ್ಸ್ದಿಂದ ತರಬೇಕು ಯೂಸಿಂಗ್ ಹೆಸ್ಲಾ. ಈ ಈಕ್ವೇಷನ್ನಲ್ಲಿ Fe plus 3 ಫಸ್ಟ್ ಇದೆ, 1 ಮೋಲ್ ಇದೆ, ಲೆಫ್ಟ್ ಸೈಡ್ ಇದೆ. Fe plus 3 ಯಾವ ಈಕ್ವೇಷನ್ನಲ್ಲಿದೆ ಅಂತ ನಾನು ಹುಡುಕಿದರೆ ಸೆಕೆಂಡ್ ಈಕ್ವೇಷನ್ನಲ್ಲಿದೆ. ಈ ಸೆಕೆಂಡ್ ಈಕ್ವೇಷನಲ್ಲಿರುವ Fe plus 3ಗೆ ನನಗೆ 1 ಮೋಲೇ ಕಾಣ್ತಾ ಇದೆ, ಇಲ್ಲಿ ಕೂಡ ಹಾಗೇ ಇದೆ. ಅಂದರೆ ನಾನು ಡೆಲ್ಟಾ G naught 3 ಬೇಕಂದರೆ ಡೆಲ್ಟಾ G naught 2 ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ತಗೋಬೇಕು. ಅಲ್ಲಿ Fe plus 3 Fe plus 3, 1 ಮೋಲ್ 1 ಮೋಲ್, ಲೆಫ್ಟ್ ಸೈಡ್ ಲೆಫ್ಟ್ ಸೈಡ್, ಅದಕ್ಕೆ ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ಡೆಲ್ಟಾ G naught 2 ಅನ್ನು ತಗೋಬೇಕು. ಪ್ಲಸ್ ನೆಕ್ಸ್ಟ್ ಒನ್, Fe plus 2 ಯಾವ ಈಕ್ವೇಷನಲ್ಲಿದೆ, ಫಸ್ಟ್ ಈಕ್ವೇಷನಲ್ಲಿದೆ. ಇದು ಎಷ್ಟು ಮೋಲ್ಸ್ ಇದೆ, 1 ಮೋಲ್. ಅದೆಷ್ಟು ಮೋಲ್ಸ್ ಇದೆ, 1 ಮೋಲ್. ಆದರೆ ಇದು ರೈಟ್ ಸೈಡ್ ಇದೆ, ಅದು ಲೆಫ್ಟ್ ಸೈಡ್ ಇದೆ. ಅಂದರೆ ನಾವು ಇದನ್ನು ಸೈಡ್ಸ್ ಚೇಂಜ್ ಮಾಡಬೇಕು. If we change the sides, if we reverse the reaction, ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ವ್ಯಾಲ್ಯೂ ಅನ್ನೋದು ಮೈನಸ್ ಆಗುತ್ತೆ. ದೇರ್ ಫೋರ್ ಮೈನಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 1 ಅಂತ ಬರೆಯಬೇಕು. ಬರೆದು ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 3 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಇ ನಾಟ್ 3 ಎಫ್ ಈಕ್ವಲ್ಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 2 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಮೈನಸ್ 2x ಎಫ್ ಮೈನಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 1 ಅದು ಕೂಡ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಮೈನಸ್ 2y ಎಫ್ ಬರುತ್ತೆ. ಇಷ್ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ ಮೇಲೆ ಎಫ್ ಇನ್ ಆಲ್ ಗೆಟ್ಸ್ ಕ್ಯಾನ್ಸಲ್ಡ್. ಮೈನಸ್ ಇ ನಾಟ್ 3 ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ 2x ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಇಸ್ ಪ್ಲಸ್ 2y ಅಂತ ಬರ್ತಾ ಇದೆ. ಸೊ ನಾನು ಇದು 3y ಆ್ಯಕ್ಚುಲಿ 2yf ಅಲ್ಲ 3y, ದೇರ್ ಫಾರ್ 3 ಅಂತ ಬರೀತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ. ಐ ವುಡ್ ಲೈಕ್ ಟು ಕರೆಕ್ಟ್ ಇಟ್ ಆಸ್ 3, ದೇರ್ ಫಾರ್ 3y ಬರ್ತಾ ಇದೆ. ಇವಾಗ ನಾನು ಇ ನಾಟ್ 3 ಅಪ್ಲೈ ಮಾಡಿದರೆ ಮೈನಸ್ ಆ ಕಡೆ ಹೋಗುತ್ತೆ. ದೇರ್ ಫಾರ್ ದಿಸ್ ಈಕ್ವೇಷನ್ ಬಿಕಮ್ಸ್ 2x ಮೈನಸ್ 3y. ಇದು ಇ ನಾಟ್ 3 ವ್ಯಾಲ್ಯೂ. ಕ್ವೆಶ್ಚನ್ ಇನ್ನೊಂದು ಸಲ ನೋಡೋಣ. ನಮಗೆ ಎಫ್ ಇ ಪ್ಲಸ್ 2 ಎಫ್ ಇಗೆ ಒಂದು ಪೊಟೆನ್ಷಿಯಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಫ್ ಇ ಪ್ಲಸ್ 3 ಎಫ್ ಇಗೆ ಒಂದು ಪೊಟೆನ್ಷಿಯಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಎಫ್ ಇ ಪ್ಲಸ್ 3 ಎಫ್ ಇ ಪ್ಲಸ್ 2 ಎಷ್ಟು ಪೊಟೆನ್ಷಿಯಲ್ ಬರುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಈ ತರಹ ಕೊಟ್ಟಿದ್ದಾಗ ನಾವು ಪ್ರತಿ ಒಂದಕ್ಕೂ ಈಕ್ವೇಷನ್ ಬರೆದುಕೊಂಡು ಗಿಬ್ಸ್ ಫ್ರೀ ಎನರ್ಜೀಸನ್ನು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಿ ಅದರ ಪ್ರಕಾರ ಇದನ್ನು ಅರೇಂಜ್ ಮಾಡ್ಕೋಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ ಎಫ್ ಇ ಪ್ಲಸ್ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಗೇನ್ ಮಾಡಿಕೊಂಡು ಎಫ್ ಇ ಆಗ್ತಾ ಇದೆ. ಸೊ ಇ ನಾಟ್ ಎಫ್ ಇ ಪ್ಲಸ್ 2 ಸ್ಲ್ಯಾಶ್ ಎಫ್ ಇ ಈಕ್ವಲ್ಸ್ ಎಕ್ಸ್ ಆಗಿದೆ. ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 1 ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ n1 ಎಫ್ ಇ ನಾಟ್ ಅಪ್ಲೈ ಮಾಡಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದ್ದಕ್ಕೆ 2fx ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಎರಡನೇದು 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದ್ದಕ್ಕೆ n2 ಬದಲು 3 ಬರೆದಿದ್ದೀನಿ, 3f ಇ ನಾಟ್ ಆಗಿದೆ. ಸೊ ಮೈನಸ್ 3fy ಆಗಿದೆ. ಸೊ ಆರ್ ಮೈನಸ್ 3yf ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಥರ್ಡ್ ಒನ್ಗೆ ಇ ನಾಟ್ 3 ಈಕ್ವಲ್ಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 3 ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ n3 ಎಫ್ ಇ ನಾಟ್ 3. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಒಂದೇ ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ವಾಲ್ವ್ ಆಗಿರೋದು. ಸೊ ನಾವು ಅದನ್ನು ಕೂಡ ಬರೆದಿದ್ವಿ. ಇವಾಗ ನಾನೇನು ಮಾಡಬೇಕು, ಈ ಈಕ್ವೇಷನನ್ನು ಈ ಎರಡರಿಂದ ತರಬೇಕು. ಅದನ್ನು ತಗೊಂಡು ಬರಲಿಕ್ಕೆ ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದರೆ ಎಫ್ ಇ ಪ್ಲಸ್ 3 ಅನ್ನೋದು ಫಸ್ಟ್ ಲೆಫ್ಟ್ ಸೈಡ್ ಇದೆ, 1 ಮೋಲ್ ಇದೆ. ಇದು ಕೂಡ 1 ಮೋಲ್ ಇದೆ, ಲೆಫ್ಟ್ ಸೈಡ್ ಇದೆ. ಸೊ ಈ ಈಕ್ವೇಷನ್ನ ನಾನು ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ತಗೋಬೇಕಾಗತ್ತೆ. ಅದಕ್ಕೆ ನಾನು ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 2 ಅನ್ನು ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ತೊಗೊಂಡಿದ್ದೀನಿ. ಆಮೇಲೆ ಎಫ್ ಇ ಪ್ಲಸ್ 2 ಏನಿದೆ ಅದು ಮೇಲಿನ ಈಕ್ವೇಷನ್ನಲ್ಲಿದೆ, ಅದು ಫಸ್ಟ್ ಇದೆ, ಇದು ಸೆಕೆಂಡ್ ಇದೆ. ಸೊ ರಿವರ್ಸ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ನಾನು ರಿವರ್ಸ್ ಮಾಡಿದ್ದೀನಿ ಅದನ್ನು. ಸೊ ಎಫ್ ಇ ಪ್ಲಸ್ 3 ಪ್ಲಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗಿವ್ಸ್ ರೈಸ್ ಟು ಎಫ್ ಇ ಪ್ಲಸ್ 2 ಆಗಿದೆ. ದೆನ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 3 ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ n3 ಎಫ್ ಇ ನಾಟ್ 3 ಅನ್ನೋದು ಅಲ್ಲಿ ಫಾರ್ಮುಲಾ. ಸೊ ನಾನೇನು ಮಾಡಿದ್ದೀನಿ, ಇದು ಎಫ್ ಇ ಪ್ಲಸ್ 2 ಇಲ್ಲಿದೆ ಅಲ್ವಾ, ಅದಕ್ಕೆ ರಿವರ್ಸ್ ಮಾಡಿದ್ದೀನಿ. ರಿವರ್ಸ್ ಮಾಡಿದಾಗ ಮೈನಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 1 ಬಂದಿದೆ. ಇವಾಗ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 3 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ, ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 2 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. ಆ್ಯಕ್ಚುಲಿ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 2 ಇಸ್ 3yf. ಸೊ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 2 ವ್ಯಾಲ್ಯೂ ಬಂದುಬಿಟ್ಟು ಮೈನಸ್ 3yf ಬರ್ತಾ ಇದೆ. ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ 1ನ ವ್ಯಾಲ್ಯೂ ಬಂದುಬಿಟ್ಟು ಮೈನಸ್ ಆಫ್ ಮೈನಸ್ 2xf ಬರ್ತಾ ಇದೆ. ಈ ಎರಡೂ ಕೂಡ ನಾನು ಅಪ್ಲೈ ಮಾಡಿದ್ದಾಗ ಮೈನಸ್ ಇ ನಾಟ್ 3 ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ 3yf ಪ್ಲಸ್ 2xf ಅಂತ ಬರ್ತಾ ಇದೆ. ಎಫ್ ಎಲ್ಲ ಕಡೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ಇ ನಾಟ್ 3 ಬಿಕಮ್ಸ್ 3y ಮೈನಸ್ 2x ಅನ್ನೋದು ಫೈನಲ್ ಆನ್ಸರ್ ಆಗುತ್ತೆ. So this is the answer to this particular question. So this is delta G naught 2 which is 3yf, delta G naught 1 which is 2xf. I just substituted in that and then got this answer as 3y minus 2x. Let's go to the next question. In the next question, we have this data. Electrolyte is BaCl2. BaCl2 do lambda naught m equals x1. Sulfuric acid do lambda naught m equals x2. HCl do lambda naught m equals x3. Barium sulfate is a sparingly soluble salt. If the conductivity of saturated barium sulfate, conductivity of barium sulfate equals x Siemens centimeter, then the solubility product of barium sulfate is, solubility product of barium sulfate is, consider lambda m equals lambda naught m. ನನಗೆ ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ಗೆ ಸಾಲ್ಯುಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಬೇಕು ಅಂತಂದರೆ ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ ಈಸ್ ಎ ಬಿ ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್, ಒಂದು ಕ್ಯಾಟಯಾನ್ ಒಂದು ಆನಯಾನ್. ಈ ಸಾಲ್ಟ್ಗೆ ಕೆ ಎಸ್ ಪಿ ಈಕ್ವಲ್ಸ್ ಎಸ್ ಸ್ಕ್ವೇರ್. ಕೆ ಎಸ್ ಪಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಎಸ್ ಖಂಡಿತ ಬೇಕು. ಎಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ದಿಂದ ಸಾಧ್ಯ. ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಈಕ್ವಲ್ಸ್ ಕೆ ಇಂಟು 1000 ಡಿವೈಡೆಡ್ ಬೈ ಸಾಲ್ಯುಬಿಲಿಟಿ ಅನ್ನೋದು ಫಾರ್ಮುಲಾ ಫಾರ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ಸಾಲ್ಯುಬಿಲಿಟಿ. ಈಗ ಫಸ್ಟ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಆಫ್ ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ ಬೇಕು, ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ ಇದ್ದೇ ಇದೆ, ಸಾಲ್ಯುಬಿಲಿಟಿಯನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ಅದು ತೊಗೊಂಡು ಹೋಗಿ ಆ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಹಾಕ್ಬೋದು. ಇದು ಪ್ಲ್ಯಾನ್. ಸೊ ಅದರಿಗೋಸ್ಕರ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಫಸ್ಟ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಆಫ್ ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೇನೆ. ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಆಫ್ ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಬೇರಿಯಂ ಪ್ಲಸ್ 2 ಸಲ್ಫೇಟ್ ಮೈನಸ್ 2. ಬೇರಿಯಂ ಪ್ಲಸ್ 2 ಎಲ್ಲಿದೆ? ಐ ಕ್ಯಾನ್ ಸಿ ದ್ಯಾಟ್ ಇನ್ ದ ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್. ಸೊ ಆ ವ್ಯಾಲ್ಯೂ x1 ಆ್ಯಡ್ ಮಾಡಬೇಕು. ಆದರೆ ನನಗಿದರಲ್ಲಿ ಬೇರಿಯಂ ಬೇಕು ಬಟ್ ಕ್ಲೋರೈಡ್ಸ್ ಬೇಕಾಗಿಲ್ಲ. ಸೊ ಅವು ಎಲಿಮಿನೇಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ನೆನಪಿಟ್ಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಸಲ್ಫೇಟ್ಗೆ ಹೋಗೋಣ. ಸಲ್ಫೇಟ್ಗೆ ಬಂದಾಗ ಇದು ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ x2 ಇದೆ, ವಿಚ್ ಈಸ್ x2, x1 ಪ್ಲಸ್ x2 ಅನ್ನೋದು ನಮ್ಮ ಹತ್ತಿರ ಇದೆ. ಈಗ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್ ತಗೋಬೇಕು. ಇದರಲ್ಲಿ ಕೂಡ ನನಗೆ ಸಲ್ಫೇಟ್ ಬೇಕು ಬಟ್ 2 H+ ಅಯಾನ್ಸ್ ಅನ್ನೋವು ಬೇಕಾಗಿಲ್ಲ ಅಂತ ನೋಡಿದ್ದಾಗ ಈ 2 H+ ಅಯಾನ್ಸನ್ನು ತೆಗೀತಾ ಇದ್ದೀನಿ. ಅದರಿಗೋಸ್ಕರ 2 ತೆಗಿಬೇಕಂದ್ರೆ HCl ಸಬ್ಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ 2 ಟೈಮ್ಸ್ x3, 2 HCl ಅಲ್ವಾ, ಅದಕ್ಕೆ 2 ಟೈಮ್ಸ್ x3 ಸಬ್ಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಈಗ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್, ಸೊ ಇಲ್ಲಿಗೆ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಬಂದುಬಿಟ್ಟಿದೆ, ಅದನ್ನೇ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. x1 ಪ್ಲಸ್ x2 ಮೈನಸ್ 2x3 ಈಕ್ವಲ್ಸ್ ಕೆ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, ಕಂಡಕ್ಟಿವಿಟಿ ವ್ಯಾಲ್ಯೂ x ಇಂಟು 10 ಕ್ಯೂಬ್ ಅನ್ಕೋ 1000 ಇದು ಎಸ್ ಸಾಲ್ಯುಬಿಲಿಟಿ. ದೇರ್ ಫಾರ್ ಸಾಲ್ಯುಬಿಲಿಟಿ ಈಕ್ವಲ್ಸ್ x ಇಂಟು 10 ಕ್ಯೂಬ್ ಡಿವೈಡೆಡ್ ಬೈ x1 ಪ್ಲಸ್ x2 ಮೈನಸ್ 2x3 ಅನ್ನೋದು ಸಾಲ್ಯುಬಿಲಿಟಿ ವ್ಯಾಲ್ಯೂ. ಈಗ ಅದಕ್ಕೆ ಸ್ಕ್ವೇರ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಕೆ ಎಸ್ ಪಿ ಈಕ್ವಲ್ಸ್ ಎಸ್ ಸ್ಕ್ವೇರ್ ಅಲ್ವಾ. ದೇರ್ ಫಾರ್ x ಇಂಟು 10 ಟು ದ ಪವರ್ 3 ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಬೈ x1 ಪ್ಲಸ್ x2 ಮೈನಸ್ 2x3 ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಅನ್ನೋದು ಆನ್ಸರ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಈಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಇಂಟು 10 ಪವರ್ 6 ಡಿವೈಡೆಡ್ ಬೈ x1 ಪ್ಲಸ್ x2 ಮೈನಸ್ 2x3 ಹೋಲ್ ಸ್ಕ್ವೇರ್ is the answer. ಇನ್ನೊಂದು ಸಲ ನೋಡಿ, what I am trying to tell you is ಬೇರಿಯಂ ಕ್ಲೋರೈಡಿನ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್, ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡಿನ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್, HClನ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದರಲ್ಲಿ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನದು ಕಂಡಕ್ಟಿವಿಟಿ, ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ ಕಂಡಕ್ಟಿವಿಟಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಾಲ್ಯುಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ ಕೇಳ್ತಿದ್ದಾರೆ. ಸಾಲ್ಯುಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಸಾಲ್ಯುಬಿಲಿಟಿ ಬೇಕು. ಸಾಲ್ಯುಬಿಲಿಟಿ ಬೇಕು ಅಂತಂದರೆ ಈ ಫಾರ್ಮುಲಾನ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಈ ಸಾಲ್ಯುಬಿಲಿಟಿಯನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಫಸ್ಟ್ ನಾನು ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಅದರಿಗೋಸ್ಕರ ಬೇರಿಯಂ ಫಸ್ಟ್ ಒನ್ನಲ್ಲಿದೆ, ಸೊ ಬೇರಿಯಂ ತೊಗೊಂಡಿದ್ದೀನಿ. ಸಲ್ಫೇಟ್ ಸೆಕೆಂಡ್ ಒನ್ನಲ್ಲಿದೆ, ಅದು ತೊಗೊಂಡಿದ್ದೀನಿ. ಬಟ್ ಫಸ್ಟನ್ನಲ್ಲಿ 2 ಕ್ಲೋರೈಡ್, ಸೆಕೆಂಡ್ ಒನ್ನಲ್ಲಿ 2 ಹೈಡ್ರೋಜನ್ಸ್ ನನಗೆ ಬೇಕಾಗಿಲ್ಲ. ಸೊ ನಾನು ಅದನ್ನು ಸಬ್ಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಮಾಡಿದ ಮೇಲೆ x1 ಪ್ಲಸ್ x2 ಮೈನಸ್ 2x3 ಈಕ್ವಲ್ಸ್ x ಇಂಟು 10 ಪವರ್ 3 ಬೈ ಎಸ್ ಅನ್ನೋ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಹಾಕಿದ್ದೀನಿ. ಯಾಕೆಂದರೆ ಕೆ ವ್ಯಾಲ್ಯೂ ಎಕ್ಸ್ 1000 10 ಕ್ಯೂಬ್ ಅಂತ ಬರೆಯಬೋದು. ಎಸ್ ಈ ಕಡೆ ಕಳಿಸಿದ್ದೀನಿ, x1 x2 2x3 ಆ ಕಡೆ ಬಂದಿದ್ದಾವೆ. ಈಗ ಎಸ್ ಅನ್ನು ನಾನು ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ದೀನಿ. ದೇರ್ ಫಾರ್ x ಇಂಟು 10 ಪವರ್ 3 ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಈಸ್ ದಿಸ್ ವಾಟ್ ಐ ಗೆಟ್ ಆ್ಯಸ್ ಅನ್ ಆನ್ಸರ್ ಟು ದಿಸ್ ಕ್ವೆಶ್ಚನ್. ಇದು ಸೆಕೆಂಡ್ ಕ್ವೆಶ್ಚನ್. ಲೆಟ್ಸ್ ಗೋ ಟು ಅನದರ್ ಕ್ವೆಶ್ಚನ್ ನಾವ್. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಏನಂದರೆ, 1/2 cell in a voltaic cell is constructed by dipping silver rod in silver nitrate. ಸಿಲ್ವರ್ ರಾಡನ್ನು ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್ ಸೊಲ್ಯೂಷನ್ನಲ್ಲಿ ಮುಳುಗಿಸಿದ್ದಾರೆ, ಅದು ಸಿಲ್ವರ್. ಜಿಂಕ್ ರಾಡನ್ನು ಜಿಂಕ್ ಸಲ್ಫೇಟ್ನಲ್ಲಿ ಮುಳುಗಿಸಿದ್ದಾರೆ. ಈಗ ಅದರ್ ಹಾಫ್ ಸೆಲ್ ಇಸ್ ಜಿಂಕ್ ರಾಡ್ ಡಿಪ್ಡ್ ಇನ್ 1 molar ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಜಿಂಕ್ ಸಲ್ಫೇಟ್. ಇದರಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ 1 molar. ಇದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗೊತ್ತಿಲ್ಲ ನಮಗೆ ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್ದು, ಅದೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಡೇಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ. ವೋಲ್ಟೇಜ್, ಟೋಟಲ್ ವೋಲ್ಟೇಜ್ ಅಂದರೆ ಈ ಸೆಲ್ ಈಕ್ವಲ್ಸ್ 1.6 ವೋಲ್ಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. E0 Zn+2 Zn minus 0.76 ಇದೆ. E0 Ag plus Ag 0.8 ವೋಲ್ಟ್ ಇದೆ. ಇಷ್ಟು ಡೇಟಾ ಇದೆ. ನಾವು Ag ಪ್ಲಸ್ ಅಯಾನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Ag ಪ್ಲಸ್ ಅಯಾನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಇದಕ್ಕೆ ನರ್ನ್ಸ್ ಈಕ್ವೇಷನ್ ಬರೆಯೋಣ. ನರ್ನ್ಸ್ ಈಕ್ವೇಷನಲ್ಲಿ ಈ ಸೆಲ್ ಈಕ್ವಲ್ಸ್ E0 cell minus 0.059/n log. ಇಲ್ಲಿ ಈಕ್ವೇಷನ್ ಬರೆದಿದ್ರೆ ಜಿಂಕ್ ಪ್ಲಸ್ Ag ಪ್ಲಸ್ ಗಿವ್ಸ್ ರೈಸ್ ಟು Ag ಪ್ಲಸ್ ಜಿಂಕ್ ಪ್ಲಸ್ 2 ಅನ್ನೋದು ಈಕ್ವೇಷನ್ ಆಗುತ್ತೆ. ಬಿಕಾಸ್ ಇದು ಕ್ಯಾಥೋಡ್ ಆಗುತ್ತೆ, ಇದು ಆ್ಯನೋಡ್ ಆಗುತ್ತೆ. ಕಾರಣ ಇದು ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್, ಇದು ಲೋವರ್ ಪೊಟೆನ್ಷಿಯಲ್. ಇದು ರೆಡ್ಯೂಸ್ ಆಗಬೇಕು, ಇದು ಆಕ್ಸಿಡೈಸ್ ಆಗಬೇಕು. ಅದಕ್ಕೆ ಈಕ್ವೇಷನ್ ಆ ಥರ ಬಂದಿದೆ. ಇವಾಗ ಲಾಗ್ Zn+2 ಕಾನ್ಸಂಟ್ರೇಷನ್ ಡಿವೈಡೆಡ್ ಬೈ Ag ಪ್ಲಸ್ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಅನ್ನೋದು ರಿಯಾಕ್ಷನ್ ಈಕ್ವೇಷನ್. ಈಗ ಈ ಸೆಲ್ ಈಕ್ವಲ್ಸ್ E0 ಸೆಲ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ವಿ. ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ E0 cell here, E0 cellನ ವ್ಯಾಲ್ಯೂ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಇದಂತೂ 1.6 ಬಂದಿದೆ. E0 cell ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ E0 ಸಿಲ್ವರ್ ಮೈನಸ್ E0 ಜಿಂಕ್ ಅಪ್ಲೈ ಮಾಡೋಣ. ಸಿಲ್ವರ್ದು 0.8 ಮೈನಸ್ ಆಫ್ ಮೈನಸ್ 0.76, ದ ಡಿಫ್ರೆನ್ಸ್ ಇಸ್ 1.56 ವೋಲ್ಟ್. ಸೊ ಇಫ್ ಯು ಆ್ಯಡ್ ಇಟ್ ಅಪ್ you will get 1.56. So 1.6, 1.56 minus 0.059. Number of moles of electrons is 2. Illi 1 into 2, 2. Log zinc plus 2 concentration is 1 molar. Ag plus whole square calculate ಮಾಡಬೇಕು. ಇದಕ್ಕೆ 1.6 minus 1.56 equals minus 0.059 ಅನ್ನು 0.6 ಡಿವೈಡೆಡ್ ಬೈ 2 ಅನ್ಕೊಳ್ಳೋಣ. ಈಗ ಲಾಗ್ Ag ಪ್ಲಸ್ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಇದೆ ಅಲ್ವಾ, ನಾನು ಇದನ್ನು ಲಾಗ್ Ag ಪ್ಲಸ್ ಹೋಲ್ ಪವರ್ -2 ಅಂತ ಬರೆದ್ರೆ ದೆನ್ ಡಿಫರೆನ್ಸ್ ಬಂದುಬಿಟ್ಟು 0.04 ಬರುತ್ತೆ, ಮೈನಸ್ 0.06/2 ಬರುತ್ತೆ, ಮೈನಸ್ ನಾನಿಲ್ಲಿ ಮ್ಯಾಲೆಗೆ -2 ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಆ -2 ಇಂಟು ಲಾಗ್ Ag ಪ್ಲಸ್ ಇಸ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಹಿಯರ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಸೊ ವಾಟ್ ವಿ ಗೆಟ್ ಹಿಯರ್ ಇಸ್ 0.04 into 2, or we can leave it like this, 0.06, 2 into 2 gets cancelled. So 0.06 log Ag plus. Actually question ನಲ್ಲಿ log Ag plus ಎಷ್ಟು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಲಾಗ್ Ag ಪ್ಲಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ಸಾಕು, ಆ್ಯಂಟಿಲಾಗ್ ಮಾಡುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಸೊ ಇಟ್ ಈಸ್ 0.04 ಡಿವೈಡೆಡ್ ಬೈ 0.06 ವಿಚ್ ಈಸ್ 2/3 ಬರುತ್ತೆ. ಈ 2/3ಗೆ ವಿಚ್ ಈಕ್ವಲ್ಸ್ ಲಾಗ್ Ag ಪ್ಲಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂತ ನಾವು ಬರೆಯಬಹುದು. ಇದು ಆನ್ಸರ್. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಯಾವ ಥರ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅನ್ನೋದು. ಸಿಲ್ವರ್ ಇನ್ ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್ ಒಂದು ಹಾಕಿದ್ದಾರೆ, ಜಿಂಕ್ ಇನ್ ಜಿಂಕ್ ಸಲ್ಫೇಟ್ ಒಂದು ಹಾಕಿದ್ದಾರೆ. ಈ ಎರಡನ್ನ ಕನೆಕ್ಟ್ ಮಾಡಿ ಗ್ಯಾಲ್ವಾನಿಕ್ ಸೆಲ್ ಒಂದು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ. ಅದರ ಈ ಸೆಲ್ 1.6 ವೋಲ್ಟ್ ಬಂದಿದೆ. ಇದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ 1 ಮೋಲಾರ್ ತಗೊಂಡಿದ್ದಾರೆ. ಇದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು ಅನ್ನೋದು ನಮಗೆ ಗೊತ್ತಿಲ್ಲ. ಬಟ್ E0 Zn + 2 Zn ವ್ಯಾಲ್ಯೂ, E0 Ag + Ag ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈಗ ಇದಕ್ಕೆ ನಾನೇನು ಮಾಡಿದ್ದೀನಿ ಅಂದರೆ ನರ್ನ್ಸ್ ಈಕ್ವೇಷನ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ನರ್ನ್ಸ್ ಈಕ್ವೇಷನಲ್ಲಿ ಈ ಸೆಲ್ ವ್ಯಾಲ್ಯೂ 1.6 ಹಾಕಿದ್ದೀನಿ, E0 ಸೆಲ್ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಿದ್ದೀನಿ, ಅದು 1.56 ಬಂದಿದೆ. ಆಮೇಲೆ -0.059/2 ಬಂದಿದೆ. ಲಾಗ್ 1/Ag + ಹೋಲ್ ಸ್ಕ್ವೇರ್, ಯಾಕೆಂದರೆ ಜಿಂಕ್ +2 ಕಾನ್ಸಂಟ್ರೇಷನ್ 1 ಹೇಳಿದ್ದಾರೆ. ನಾನಿಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಇದನ್ನು ಈ ಕಡೆ ತಂದಿದ್ದೀನಿ. ದಟ್ ಬಿಕಮ್ 0.04 ಆ್ಯಂಡ್ ದೆನ್ 2 ಈ ಲಾಗ್ Ag + ಹೋಲ್ ಸ್ಕ್ವೇರ್ -2 ಅನ್ನು ಮುಂದಕ್ಕೆ ತಂದಿದ್ದೀನಿ. ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಪ್ಲಸ್ ಆಗುತ್ತೆ, 2 × 2 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ದೇರ್ ಫೋರ್ ವಿ ಗೆಟ್ 0.06 ಆ್ಯಂಡ್ ಇಲ್ಲಿ 0.04. ರೇಷಿಯೋ ತೊಗೊಂಡ್ರೆ 2/3 ಬರುತ್ತೆ ಆ್ಯಸ್ ಲಾಗ್ Ag + ಕಾನ್ಸಂಟ್ರೇಷನ್. ಇದು ಇಷ್ಟು ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. Now we have certain statements to solve. So we are given FeOH twice, solid plus 2 electrons, Fe solid plus 2OH minus aqueous, E0 equals -0.88 volt. AgBr solid plus electron, Ag solid plus Br minus aqueous, E0 equals 0.07 volt. ಈಗ ಕ್ವೆಶ್ಚನ್ ಏನಂದರೆ which of the following options is correct with regard to this one. So ಇದರಲ್ಲಿ overall reaction ಕೊಟ್ಟಿದ್ದಾರೆ. Overall reaction is Fe solid plus 2OH minus aqueous plus 2AgBr solid. ಇದು first option where FeOH twice solid plus 2Ag solid plus 2Br minus aqueous. ಇದಿದೆ ನಮ್ಮ ಹತ್ರ. ಈ ಈಕ್ವೇಷನ್ ಓವರಾಲ್ ರಿಯಾಕ್ಷನ್ ಆಗತ್ತಾ ಆಗಲ್ವಾ ಅನ್ನೋದು ನಾವು ವೆರಿಫೈ ಮಾಡಬೇಕು. ಇದು ವೆರಿಫೈ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಎರಡನ್ನು ಕಂಪೇರ್ ಮಾಡೋಣ. ಇದು ರಿಡಕ್ಷನೇ, ಅದು ರಿಡಕ್ಷನೇ. ಅಂದರೆ ಕೊಟ್ಟಿದ್ವು ಎರಡು SRPಸೇ, ಆದರೆ ಇದು ಲೋವರ್ SRP, ಇದು ಹೈಯರ್ SRP. ಹೈಯರ್ SRPದೊಂದಿಗೆ ಏನಿದೆ ಅದು ಖಂಡಿತ ರೆಡ್ಯೂಸ್ ಆಗಬೇಕು, ಅಂದರೆ ಈ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕು. ಅದೇ ಲೋವರ್ SRP ಏನಿದೆ ಅದು ರಿವರ್ಸ್ ಆಗಬೇಕು. ಆ ಎರಡು ಸೇರಿಸಿದ್ರೆ ಓವರಾಲ್ ರಿಯಾಕ್ಷನ್ ಬರಬೇಕು. ನೀವು ನೋಡಿ, Fe2OH minus AgBr gives rise to FeOH twice 2Ag. ಸೊ ಒಂದು ಸ್ಪಾಂಟೇನಿಯಸ್ ಚೇಂಜ್ಗೆ ಏನೇನು ಬೇಕಾಗಿದ್ದಾವೆ ಅವೆಲ್ಲ ಕೂಡ ಈ ಈಕ್ವೇಷನಲ್ಲಿ ಅದಾವೆ. ಸೊ ಎಸ್, ದಿ ಓವರಾಲ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ದಿಸ್ ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ದಿ ಆನ್ಸರ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಪ್ಷನ್. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಈ ತರಹ ಎರಡು ಈಕ್ವೇಷನ್ಸ್ ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. ಆಪ್ಷನ್ಸ್ನಲ್ಲಿ ಯಾವುದು ಕರೆಕ್ಟ್ ಆಗತ್ತೆ ಅನ್ನುವ ಆಪ್ಷನನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದಕ್ಕೆ ಓವರಾಲ್ ರಿಯಾಕ್ಷನ್ ಇದು ಆಗತ್ತಾ ಆಗಲ್ಲ ಅನ್ನೋದು ನಾವು ವೆರಿಫೈ ಮಾಡಬೇಕು. ಜನರಲಿ ಈ ಎರಡು ಪೊಟೆನ್ಷಿಯಲ್ಸ್ನಲ್ಲಿ ಇದು ಹೈಯರ್, ಅದು ಲೋವರ್. ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ ದಟ್ ಹೈಯರ್ದು ಯಾವಾಗಲೂ ರಿಡಕ್ಷನ್ ಆಗಬೇಕು, ಅಂದರೆ ಹಿಂಗೆ ಆಗಬೇಕು. ಲೋವರ್ದು ಆಕ್ಸಿಡೇಷನ್ ಆಗಬೇಕು, ಬಟ್ ಇಲ್ಲಿ ರಿಡಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಸೊ ರಿವರ್ಸ್ ಆಗಬೇಕು. ಅಂದರೆ ಆ Fe2OH ಮೈನಸ್ ಇಲ್ಲಿರಬೇಕು, AgBr ಇಲ್ಲಿರಬೇಕು, AgBr ಮೈನಸ್ FeOH ಟ್ವೈಸ್ ಆ ಕಡೆ ಇರಬೇಕು, ಆ್ಯಂಡ್ ಹಾಗೆ ಅದಾವೆ. ದೇರ್ ಫೋರ್ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಸೇ ಇಸ್ ದ ಫಸ್ಟ್ ಆಪ್ಷನ್ ಈಸ್ ಅ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ಇನ್ನೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅವು ಕೂಡ ವೆರಿಫೈ ಮಾಡೋಣ. E0 ಸೆಲ್ ಈಸ್ ಮೈನಸ್ 0.95 ವೋಲ್ಟ್ ಅಂತಿದ್ದಾರೆ. ಈ ಚೇಂಜ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಚೇಂಜ್ ಇದು. ಈ ರಿಯಾಕ್ಷನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗಿರೋದ್ರಿಂದ ಹೈಯರ್ ಮೈನಸ್ ಲೋವರ್ ಮಾಡಿದರೆ ನೆಗೆಟಿವ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶನೇ ಇಲ್ಲ. E0 ಪಾಸಿಟಿವೇ ಬರುತ್ತೆ. ಡೆಲ್ಟಾ G0 ನೆಗೆಟಿವ್ ಆಗಬೇಕಂದ್ರೆ E0 ಪಾಸಿಟಿವೇ ಆಗಬೇಕಲ್ವಾ ಇಲ್ಲಿ. ದೇರ್ ಫೋರ್ ಇದು ತಪ್ಪಾಗತ್ತೆ. ಸಿ Fe is reduced in the electrochemical cell ಅಂತಿದ್ದಾರೆ. Fe ರೆಡ್ಯೂಸ್ ಆಗಿಲ್ಲ, ಆಕ್ಸಿಡೈಸ್ ಆಗ್ತಾ ಇದೆ. ಫೋರ್ತ್ ಸ್ಟೇಟ್ಮೆಂಟ್, E0 ಸೆಲ್ ಈಸ್ ಅನ್ ಎಕ್ಸ್ಟೆನ್ಸಿವ್ ಪ್ರಾಪರ್ಟಿ ಅಂತಿದ್ದಾರೆ. E0 ಸೆಲ್ ಎಕ್ಸ್ಟೆನ್ಸಿವ್ ಪ್ರಾಪರ್ಟಿ ಅಲ್ಲ, ಇಂಟೆನ್ಸಿವ್ ಪ್ರಾಪರ್ಟಿ. ಹಾಗಾಗಿ ಫಸ್ಟ್ ಆಪ್ಷನ್ ಇಸ್ ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನಲ್ಲಿ ಒಂದು ಚೇಂಬರ್ ಇದೆ. ಈ ಚೇಂಬರ್ನಲ್ಲಿ ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ, M ಪ್ಲಸ್ C2 X ಮೈನಸ್. ಇಲ್ಲಿ ಕೂಡ M ಪ್ಲಸ್ X ಮೈನಸ್ C1. ಅಂದರೆ ನಿನಗೆ ಎರಡೂ ಕಡೆ ಇದು ಮೆಟಲ್ M, ಇದು ಮೆಟಲ್ M, ಇದು M ಪ್ಲಸ್ X ಮೈನಸ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್, ಇದು ಕೂಡ M ಪ್ಲಸ್ X ಮೈನಸ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್. ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಸೇಮ್ ಅದಾವೆ, ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಸೇಮ್ ಅದಾವೆ, ಆದರೂ ಕೂಡ ಒಂದು ಗ್ಯಾಲ್ವಾನಿಕ್ ಸೆಲ್ ಬಂದಿದೆ ಅಂತಂದರೆ ಅದರ ಅರ್ಥ ಅದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೆಲ್ ಅಂತ. ಒಂದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೆಲ್ನಲ್ಲಿ ಯಾವಾಗಲೂ ಕೂಡ ಏನಿರಬೇಕು ಅಂತಂದರೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಿರುತ್ತೆ ಅದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಇದ್ದರೆ ಮಾತ್ರ E0 ಸೆಲ್ ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ಸೊ E0 ಸೆಲ್ ಬಿಕಮ್ಸ್ ಪಾಸಿಟಿವ್ ವೆನ್ C1 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ C2. ಇದು C1 ಕೊಟ್ಟರು, ಅದು C2 ಕೊಟ್ಟರು. ಸೊ C1 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ C2 ಅನ್ನೋದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಇವಾಗ ಪಾಯಿಂಟ್ ಏನಂತಂದರೆ, ಇಫ್ C1 ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಅಟ್ ಆ್ಯನೋಡ್ ದೆನ್ C1 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ C2 ಅಂತಿದ್ದಾರೆ. ಇವಾಗ C1 ಏನಿದೆ ಹೈಯರ್ ಅಲ್ವಾ, ಇದು ಹೈಯರ್ ಆಗಬೇಕಂದ್ರೆ ಇದು ಕ್ಯಾಥೋಡ್ ಆಗಬೇಕು. ಇದು ಲೋವರ್ ಅಲ್ವಾ, ಇದು ಆ್ಯನೋಡ್ ಆಗಬೇಕು. ಒಂದು ವೇಳೆ ಇದು ಹೈಯರ್ ಅನ್ಕೋ, ಇದು ಕ್ಯಾಥೋಡ್ ಆಗುತ್ತೆ. C2 ಇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ C1 ಆದರೆ ಅವಾಗ ಇದು ಕ್ಯಾಥೋಡ್ ಆಗುತ್ತೆ, ಇದು ಆ್ಯನೋಡ್ ಆಗುತ್ತೆ. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಯಾವುದು ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರುತ್ತೆ, ಇದರಲ್ಲಿ ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇರುತ್ತೆ, ಅದೇ ಇಟ್ ಬಿಕಮ್ಸ್ ಕ್ಯಾಥೋಡ್. ಯಾವುದು ಲೋವರ್ SRP ಅನ್ನೋ ಲೋವರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹೊಂದಿರುತ್ತೆ, ದಟ್ ಬಿಹೇವ್ಸ್ ಆಸ್ ಆ್ಯನೋಡ್. ಸೊ ಇವಾಗ ಆಪ್ಷನ್ಸ್ ಏನಂದರೆ, ಇಫ್ C1 ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಎಟ್ ಆ್ಯನೋಡ್ ಅಂತಿದ್ದಾರೆ. C1 ಆ್ಯನೋಡ್ ಆಗಬೇಕು ಅಂತ ಅನ್ಕೋ, ಅವ್ರು ಕ್ಯಾಥೋಡ್ ಅಂತ ಕೊಟ್ಟಿಲ್ಲ, ಬಟ್ ಇದು ಆ್ಯನೋಡ್ ಆಗಬೇಕು ಅಂತ ಅಂದರೆ ಇಫ್ ದಿಸ್ ಹ್ಯಾಸ್ ಟು ಬಿಕಮ್ ಆ್ಯನೋಡ್ ದೆನ್ C1 ಶುಡ್ ಬಿ ಲೋವರ್. ಬಟ್ ಆಪ್ಷನಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಇಫ್ C1 ಈಸ್ ಆಟ್ ಆ್ಯನೋಡ್ ದೆನ್ C1 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ C2 ಅಂತಿದ್ದಾರೆ. ಅದು ಫಾಲ್ಸ್ ಆಗುತ್ತೆ, ಯಾಕಂದರೆ ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದ್ದಿದ್ದು ಮಾತ್ರ ಲೋವರ್ ಕ್ಯಾಥೋಡ್ ಆಗುತ್ತೆ, ಲೋವರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದ್ದಿದ್ದು ಆ್ಯನೋಡ್ ಆಗುತ್ತೆ. ಇಲ್ಲೇನಂತಿದ್ದಾರೆ, C1 ಆ್ಯನೋಡ್ ಹತ್ತಿರ ಇದ್ದರೆ C1 ಹೈಯರ್ ಇರಬಾರ್ದು, C1 ಲೋವರ್ ಇರಬೇಕು ಆ್ಯನೋಡ್ ಆಗೋದಕ್ಕೆ. ಎರಡು, ಅದು ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಇಫ್ C1 ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಆಟ್ cathode then C1 is greater than C2 ಅಂದಿದ್ದಾರೆ. ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೊ ಇದನ್ನು ಈ ತರಹ ಡಯಾಗ್ರಾಮನ್ನು ನೋಡಿದ್ದಾಗ ನಮಗೆ ಅರ್ಥ ಆಗಬೇಕಾಗಿದ್ದೇನೆಂದರೆ ಇದು ಮೆಟಲಿಯಮ್, ಇದು ಕೂಡ ಮೆಟಲಿಯಮ್ಮೇ. ಇಲ್ಲಿ ಎಮ್ ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಅದಾವೆ, ಅಲ್ಲಿನೂ ಅವೇ ಅದಾವೆ. ಇಲ್ಲಿ ಎಕ್ಸ್ ಮೈನಸ್ ಇದೆ, ಅಲ್ಲಿನೂ ಎಕ್ಸ್ ಮೈನಸ್ಸೇ ಇದೆ. ಅಂದರೆ ಈ ಮೆಟಲನ್ನು ಆ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ, ಇಲ್ಲಿ ಅದೇ ಮೆಟಲನ್ನು ಈ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. ಆದರೆ ಇಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಆರ್ ಡಿಫ್ರೆಂಟ್. ಅಂಥ ಸಂದರ್ಭದಲ್ಲಿ ನಾವು ಈ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಏನು ಡಿಫ್ರೆಂಟ್ ಅದಾವಲ್ವಾ ಅವುಗಳನ್ನು ಅದರಿಂದ ಡಿಫರೆನ್ಸ್ ಬಂದರೆ ಅದನ್ನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೆಲ್ ಅಂತ ಇದ್ವಿ. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೆಲ್ಸ್ ಅಂದರೆ ಏನು? ಎರಡೂ ಕಡೆ ಸೇಮ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಇರುತ್ತೆ, ಎರಡೂ ಕಡೆ ಸೇಮ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಇರುತ್ತೆ. ಅಂತಹ ಒಂದು ಪಾಯಿಂಟ್ನಲ್ಲಿ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದೇನು, ಎರಡೂ ಕಡೆ ಸೇಮ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಬರಬೇಕಾಗಿದ್ದಾಗ ನಾವು ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ನಲ್ಲಿ ಮಾತ್ರ ಡಿಫ್ರೆನ್ಸನ್ನು ತೊಗೊಂಡು ಬಂದರೆ ಆವಾಗ ಅದನ್ನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೆಲ್ ಅನ್ನಬೇಕು. ಯಾವಾಗಾದರೂ ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಬರಬೇಕಂದ್ರೆ ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಇರಬೇಕು. ಅಂದರೆ ಕ್ಯಾಥೋಡ್ ಹತ್ತಿರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಇರಬೇಕು, ಆ್ಯನೋಡ್ ಹತ್ತಿರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಇರಬೇಕು. ಅದರ ಪ್ರಕಾರ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ನೋಡಿದರೆ C1 is at anode. If C1 is at anode, then C1 should be lower than C2. ಅದು ತಪ್ಪು. ಸೊ ಇಫ್ C1 is at cathode, then C1 should be greater than C2 ಅಂತಿದ್ದಾರೆ. ಅದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಇದು ಈ ಕ್ವೆಶ್ಚನ್ಗೆ ಆನ್ಸರ್. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಇಲ್ಲಿ ಕೆಲವು ಪೊಟೆನ್ಷಿಯಲ್ಸನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. Al+3Al. ಈಗ ಕ್ವೆಶ್ಚನ್ ಏನಂದರೆ ವಿ ನೀಡ್ ಟು ಅರೇಂಜ್ ದೀಸ್ ಇನ್ ದ ರೆಡ್ಯೂಸಿಂಗ್ ಪವರ್ ಆರ್ಡರ್. ಇದು ಎ, ಇದು ಬಿ, ಇದು ಸಿ, ಇದು ಡಿ ಅಂದ್ಕೊಂಡ್ರೆ ರೆಡ್ಯೂಸಿಂಗ್ ಪವರ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು SRP ವ್ಯಾಲ್ಯೂ. ನಾವು ಫಸ್ಟ್ ವೆರಿಫೈ ಮಾಡ್ಕೋಬೇಕು ಕೊಟ್ಟಿದ್ವೆಲ್ಲ SRP ಏನಾದರೂ SOP ಆಯಿತಾ ಅಂತ ಹೇಳಿ. +3 to Al ರಿಡಕ್ಷನ್, +3 to +2 ರಿಡಕ್ಷನ್, +3 to +2 ರಿಡಕ್ಷನ್, +3 to 0 ರಿಡಕ್ಷನ್, ಇವೆಲ್ಲ ರಿಡಕ್ಷನ್ಸೇ ಇಲ್ಲಿರೋದು. ಬಟ್ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದೆ ಏನಂತಂದರೆ ಇವೆಲ್ಲ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ಸೇ. ಸೊ ರೆಡ್ಯೂಸಿಂಗ್ ಪವರ್ ಈಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್. ಈ ವಸ್ತುರಲ್ಲಿ ಲೀಸ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರೋದು ಅಲ್ಯೂಮಿನಿಯಂ. ಹಾಗಾಗಿ ಅಲ್ಯೂಮಿನಿಯಂ ಈಸ್ ದ ಮೋಸ್ಟ್ ಪವರ್ಫುಲ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್. ಸೆಕೆಂಡ್ ಕೇಸ್ನಲ್ಲಿ CR ಬರುತ್ತೆ ವಿತ್ ದ ಸೆಕೆಂಡ್ ನೆಕ್ಸ್ಟ್ ಹೈಯರ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್. ಅದಾದ ನಂತರ Fe+2 ಬರುತ್ತೆ, ಲಾಸ್ಟಿಗೆ CO+2 ಬರುತ್ತೆ. Therefore, the order in which we have to arrange according to reducing power is the least one. First Al, then Cr, then Fe+2, then CO+2. ಇದರ ಪ್ರಕಾರ ಅರೇಂಜ್ ಮಾಡಬೇಕಾಗತ್ತೆ ರೆಡ್ಯೂಸಿಂಗ್ ಪವರ್ಗೆ. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಇನ್ ವಾಟರ್. ಇದಕ್ಕೆ ಆರ್ಡರ್ ಕೇಳ್ತಿದ್ದಾರೆ. ಈ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿಗೆ ಆರ್ಡರ್ ಕೇಳ್ತಾ H+, Na+, K+, Ca+2, Mg+2ಗಳನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದರಲ್ಲಿ ನಾವು ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆರ್ಡರ್ ಫಿಕ್ಸ್ ಮಾಡಬೇಕಂದ್ರೆ ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಯಾವಾಗಾದರೂ H+ ಹ್ಯಾಸ್ ದ ಹೈಯೆಸ್ಟ್. ಇದಾದ ನಂತರ ಹೈಯರ್ ಇಸ್ ದ ಚಾರ್ಜ್, ಹೈಯರ್ ಇಸ್ ದ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ. ಅಂದರೆ ಈ ಎರಡಕ್ಕೂ ಕೂಡ ಜಾಸ್ತಿ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ವ್ಯಾಲ್ಯೂ ಇರುವ ಅವಕಾಶ ಇದೆ. ದೇರ್ಫೋರ್ ಈ ಎರಡರಲ್ಲಿ ಯಾವುದಕ್ಕಿರುತ್ತೆ ಅಂತಂದರೆ ಲಾರ್ಜರ್ ಇಸ್ ದ ಸೈಜ್, ಹೈಯರ್ ಇಸ್ ದ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ. ಸೊ charge is directly proportional to lambda naught m, size is also directly proportional to lambda naught m with an exception of, ಇದಕ್ಕೆ ಎಕ್ಸೆಪ್ಷನ್ಸ್ ಯಾವ ಬರ್ತಾವಂದರೆ H ಪ್ಲಸ್ ಮತ್ತು OH ಮೈನಸ್, ಇವುಗಳನ್ನ ಎಕ್ಸೆಪ್ಷನ್ಸ್ ಆಗಿ ಇಟ್ಕೋಬೇಕು. ದೇರ್ ಫಾರ್ H ಪ್ಲಸ್ ತಗೊಂಡಿದ ಮೇಲೆ CA ಪ್ಲಸ್ ಟು ಲಾರ್ಜರ್ ಇರೋದ್ರಿಂದ ಹೈಯರ್ ಚಾರ್ಜ್ ಇರೋದ್ರಿಂದ ಅದನ್ನು ತಗೋಬೇಕು. ನೆಕ್ಸ್ಟ್ Mg ಪ್ಲಸ್ ಟು ಹಾಕಬೇಕು, ನೆಕ್ಸ್ಟ್ K ಪ್ಲಸ್ ತಗೋಬೇಕು, ಲಾಸ್ಟಿಗೆ Na ಪ್ಲಸ್ ತಗೋಬೇಕು. ಇದು ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಆರ್ಡರ್ ಬರುತ್ತೆ. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆರ್ಡರ್ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಿದ್ದಾರೆ, O2 ಗ್ಯಾಸ್ ವಿಲ್ ಬಿ ರಿಲೀಸ್ಡ್. O2 ಈಸ್ ರಿಲೀಸ್ಡ್ ವೆನ್ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಒನ್, ಆನ್ aqueous solution of silver nitrate using silver electrodes. ಇದು ಫಸ್ಟ್, ಇದರಲ್ಲಿ ಬರುತ್ತಾ ಬರಲ್ಲ ಅನ್ನೋದು ಹೇಳಬೇಕು. ಏಕ್ವಿಯಸ್ ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್ ತಗೊಂಡಿದ್ದಾಗ Ag ಪ್ಲಸ್ NO3 ಮೈನಸ್ H ಪ್ಲಸ್ OH ಮೈನಸ್, ಆಕ್ವಾ ವಾಟರ್ ಕೂಡ ತಗೋಬೇಕು. ಆ್ಯನೋಡ್ ಹತ್ತಿರ ರಿಯಾಕ್ಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ತಗೊಂಡಿದ್ದಾರೆ, ಸೊ Ag ಕೂಡ ತಗೋಬೇಕು. ನಮಗೆ O2 ಬರೋದು ಯಾವಾಗಲೂ ಆ್ಯನೋಡ್ ಹತ್ತಿರ, ಆ್ಯನೋಡೇ ಅನಲೈಸ್ ಮಾಡಬೇಕು. ಸೊ ಕ್ಯಾಥೋಡ್ ಕೂಡ ಜಸ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಾನು ಹಾಗೆ. ಇದು 0.8 ವೋಲ್ಟ್, ಇದು 0 ವೋಲ್ಟ್. ಕ್ಯಾಥೋಡ್ ಹತ್ತಿರ ಯಾವಾಗಲೂ ಕೂಡ ಹೈಯರ್ ವೋಲ್ಟೇಜ್ದು ಹೋಗುತ್ತೆ, ಅಂದರೆ ಇದು. ಸೊ Ag ಪ್ಲಸ್ ಪ್ಲಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗಿವ್ಸ್ ರೈಸ್ ಟು Ag ಡೆಪಾಸಿಟ್ ಆಗುತ್ತೆ ಕ್ಯಾಥೋಡ್ ಹತ್ತಿರ. ಈಗ ಆ್ಯನೋಡ್ ಹತ್ತಿರ ಇದರದ್ದು ಸುಮಾರು 1.54 ವೋಲ್ಟ್ ಇದೆ, ಇದರದ್ದು 1.23 ವೋಲ್ಟ್ ಇದೆ, ಇದು 0.8 ವೋಲ್ಟ್ ಇದೆ. ನಾವು 0.8 ವೋಲ್ಟ್ ಈಸ್ ದ ಲೀಸ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್. ಆ್ಯನೋಡ್ ಹತ್ತಿರ ಯಾವಾಗಲೂ ಲೋವೆಸ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್ದನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು, ಅದಕ್ಕೆ Ag ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಆ್ಯನೋಡ್ ಹತ್ತಿರ ಕ್ಯಾಥೋಡ್ ಹತ್ತಿರ ಕೂಡ Agನೇ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಇದರಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲವೇ ಇಲ್ಲ. ಎರಡನೇದು ತಗೊಳ್ಳೋಣ, ಬಿ. ಇದರಲ್ಲಿ ಏಕ್ವಿಯಸ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್ ಮತ್ತದೇ, ಆದರೆ ಈ ಸತ ಪ್ಲಾಟಿನಮ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಯೂಸ್ ಮಾಡಿ ತಗೋಬೇಕು. ಹಿಂಗೆ ತಗೊಂಡ್ರೆ AgNO3 Ag ಪ್ಲಸ್ NO3 ಮೈನಸ್ ಅನ್ನೋದು ಬರೆದಿದ್ದೀನಿ. ಆಮೇಲೆ H ಪ್ಲಸ್ OH ಮೈನಸ್. ಪ್ಲಾಟಿನಮ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಆಗಿರೋದ್ರಿಂದ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಡನ್ನು ತಗೊಳ್ಳುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. 0.8 ವೋಲ್ಟ್ ಆ್ಯಂಡ್ ದೆನ್ 0 ವೋಲ್ಟ್, ಎರಡರಲ್ಲಿ ಯಾವುದು ಬರುತ್ತೆ ಅನ್ನೋ ಕ್ವೆಶ್ಚನ್ ಬಂದಿದ್ದಾಗ ಖಂಡಿತ ಹೈಯರ್ SRP, ಸೊ Ag ಪ್ಲಸ್ ಹೋಗ್ತಾ ಇದೆ. ಈ ಎರಡರಲ್ಲಿ ಯಾವುದು ಹೋಗುತ್ತೆ ಅಂತಂದರೆ ಖಂಡಿತ OH ಮೈನಸ್. ಈಸಿಯೆಸ್ಟ್ ವೇ ಟು ರಿಮೆಂಬರ್ ಈ ಥರ, NO3 ಮೈನಸ್ನಲ್ಲಿ ಸೋ ಮೆನಿ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ಸ್ ಆರ್ ದೇರ್, ಸೊ ಇಟ್ಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಟು ಬ್ರೇಕ್ ಇಟ್. ವೆರಾಸ್ OH ಮೈನಸ್ನಲ್ಲಿ ಒಂದೇ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಇದೆ, ಇಟ್ಸ್ ಈಸಿಯರ್ ಟು ಬ್ರೇಕ್. ಆ ಥರ ಯೋಚನೆ ಮಾಡಿ. ಆ್ಯಕ್ಚುಲಿ ಅದು ಕರೆಕ್ಟ್ ಅನ್ನಲ್ಲ ನಾನು, ಬಟ್ ದಟ್ ಈಸ್ ಹೌ ಯು ಕ್ಯಾನ್ ರಿಮೆಂಬರ್ ಥಿಂಗ್ಸ್. ಇಟ್ಸ್ ಈಸಿಯರ್ ಟು ರಿಮೆಂಬರ್ ದ್ಯಾಟ್ ವೇ. ಸೊ OH ಮೈನಸ್ ಹೋಗುತ್ತೆ ಅಂದರೆ ವಾಟರ್ ಹೋಗುತ್ತೆ. ವಾಟರ್ ಹೋದಾಗ ಆಕ್ಸಿಡೈಸ್ ಆಗುತ್ತೆ. ಆಕ್ಸಿಡೈಸ್ ಆದಾಗ ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ಬರುತ್ತೆ, 2H ಪ್ಲಸ್ ಬರ್ತವೆ, 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರ್ತವೆ. ಅಂದರೆ ಬಿನಲ್ಲಿ ಖಂಡಿತ ನಮಗೆ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ದಿಸ್ ಗ್ಯಾಸ್ ಕಾಲ್ಡ್ ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್. ಈಗ ಕೇಸ್ ಸಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದಕ್ಕೆ ಹೋಗೋಣ. ಡೈಲ್ಯೂಟ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್, ಇದರ ಎಲೆಕ್ಟ್ರೋಲಿಸಿಸ್ ಮಾಡಿದ್ದಾರೆ ಯೂಸಿಂಗ್ ಪ್ಲಾಟಿನಮ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್, KC. ಸೊ ಡೈಲ್ಯೂಟ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡಿನ ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್ ಮಾಡಿದ್ದಾಗ H ಪ್ಲಸ್ ಡೈಲ್ಯೂಟ್ ಕೇಸ್ನಲ್ಲಿ ಈ ಥರ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಡೈಲ್ಯೂಟ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಕೇಸ್ನಲ್ಲಿ ವಾಟರ್ ಇದೆ, H+ ಇದೆ, ವಾಟರ್ ಇದೆ, ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಇದೆ. ಆದರೆ ಡೈಲ್ಯೂಟ್ ಅಂದರೆ ವಾಟರ್ ಮೋರ್ ಅಂತ ಅನ್ಕೋ. ಬಿಕಾಸ್ ವಾಟರ್ ಮೋರ್ ಇರುತ್ತಲ್ವಾ, ಅದಕ್ಕೆ ವಾಟರೇ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಎರಡು ಕಡೆ ಅನ್ನೋದು ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಆ ಥರ ಅನ್ಕೋ. ದೇರ್ ಫೋರ್ H+ ಹಿಂಗಾದರೂ ಎರಡೂರಲ್ಲಿ ಒಂದೇ. ದೇರ್ ಫೋರ್ H++ ಎಲೆಕ್ಟ್ರಾನ್ ½ ಬರುತ್ತೆ. ಅಥವಾ ನಾನು ವಾಟರಿಂದ ಕೂಡ ರಿಯಾಕ್ಷನನ್ನು ಬರೆಯಬಹುದು. ಬಟ್ ಸಲ್ಫೇಟ್ ಮತ್ತು OH- ಅಯಾನ್ಸ್ಗಳಲ್ಲಿ OH- ಅಯಾನ್ ಫಸ್ಟ್ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ದೇರ್ ಫೋರ್ ಮತ್ತೆ ವಾಟರ್ ತಗೋಬೇಕು. ವಾಟರ್ ತಗೊಂಡಿದ್ರೆ ½ O2 + 2H+ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋದು ಬರುತ್ತೆ. ಇದು ಈಕ್ವೇಷನಲ್ಲಿ. ದೇರ್ ಫೋರ್ ಇದರಲ್ಲಿ ಕೂಡ ಆಕ್ಸಿಜನ್ ಬರ್ತಾ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಡಿ, ಅ ಹೈ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಅಂತಿದ್ದಾರೆ. ಹೈ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ತಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ ಯಾವುದಿದೆ, ವಾಟರ್ ಜಾಸ್ತಿ ಆಯಿತಾ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಜಾಸ್ತಿ ಆಯಿತಾ? ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್. ದೇರ್ ಫೋರ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ನಲ್ಲಿರುವ H+ ಮತ್ತು ಸಲ್ಫೇಟ್ ಅಯಾನ್ಸೇ ರಿಯಾಕ್ಟ್ ಆಗ್ತವೆ, ವಾಟರ್ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ. ಸಲ್ಫೇಟ್ ರಿಯಾಕ್ಟ್ ಆಗಿ S2O8 - 2 + 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರುತ್ತೆ. ಇದರಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಬರಲ್ಲ. ಸೊ ಆಕ್ಸಿಜನ್ ಬರುವ ಯಾವ ಯಾವ ಆಪ್ಷನ್ಸ್ನಲ್ಲಿ ಬರ್ತಿದ್ದಾವೆ? ಎನಲ್ಲಿ ಬರಲ್ಲ, ಬಿನಲ್ಲಿ ಬರುತ್ತೆ, ಆಮೇಲೆ ಸಿನಲ್ಲಿ ಬರುತ್ತೆ. ದೇರ್ ಫೋರ್ ವಿ ನೀಡ್ ಟು ಕನ್ಸಿಡರ್ ಬಿ ಆ್ಯಂಡ್ ಸಿ ಆಸ್ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. ಇದರಲ್ಲಿ ವಿ ನೀಡ್ ಟು ಅರೇಂಜ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪ್ರಾಪರ್ಟಿ. ಸೊ E0 Sn+4 Sn+2 plus 1.15 volt, E0 Al+3 Al minus 1.66 volt, E0 Pb+4 Pb+2 1.67 volt, E0 thallium+3 thallium plus 1.26 volt. ಇವುಗಳಲ್ಲಿ ಇದರ ಪ್ರಕಾರ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪವರ್ ಪ್ರಕಾರ ಅರೇಂಜ್ ಮಾಡಬೇಕು ನಾನು ಇವುಗಳನ್ನು. ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪವರ್ ಪ್ರಕಾರ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪವರ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು SRP ವ್ಯಾಲ್ಯೂ. SRP ಎಷ್ಟು ಜಾಸ್ತಿ ಇದ್ದರೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪವರ್ ಕೂಡ ಅಷ್ಟು ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಫಸ್ಟ್ ಕೊಟ್ಟಿದ್ವೆಲ್ಲ ರೆಡ್ಯೂಸಿಂಗ್ ವ್ಯಾಲ್ಯೂಸ್ ಏನಂತ ನೋಡ್ಕೋಬೇಕು ನಾವು, ಅಂದರೆ ರಿಡಕ್ಷನ್ SRPs ಏನಂತ. +4 to +2 ರಿಡಕ್ಷನ್, +3 to 0 ರಿಡಕ್ಷನ್, 4 to 2 ರಿಡಕ್ಷನ್, 3 to 0 ರಿಡಕ್ಷನ್, ಎಲ್ಲ ರಿಡಕ್ಷನ್ಸ್. ಸೊ SRPs ಅವು. ಸೊ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪವರ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು SRP. ಹೈಯೆಸ್ಟ್ SRP ಇದ್ದಿದ್ದರಲ್ಲಿ 1.67, ಅಂದರೆ ಸಿ ಈಸ್ ದ ಫಸ್ಟ್ ಟಾಪ್ ಮೋಸ್ಟ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಒನ್. ಅಂದರೆ ಅದರಲ್ಲಿ ಯಾವುದು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗುತ್ತೆ? ಇದ ಅಂದರೆ ಆಕ್ಸಿಡೈಸ್ಡ್ ಪೋರ್ಷನ್ ವಿಲ್ ಬಿಕಮ್, ಆಕ್ಸಿಡೈಸ್ಡ್ ಪಾರ್ಟ್ ವಿಲ್ ಬಿಕಮ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್, ಅಂದರೆ Pb+4. ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಏನಿದೆ ಅದು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. ಸೊ ಸಿ ಕಮ್ಸ್ ಫಸ್ಟ್ ಆ್ಯಂಡ್ ದೆನ್ 1.67 ಅನಂತರ 1.26. ಸೊ thallium+3 Pb+4 thallium+3. ನೆಕ್ಸ್ಟ್ ಬಂದುಬಿಟ್ಟು tin+4 tin+4, ಲಾಸ್ಟಿಗೆ Al+3. ಇದು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಪವರ್ ದಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಇದರಲ್ಲಿ ಯಾವ ಥರ ಎದಕ್ಕೆ ಈ ಥರ ಪವರ್ ಬಂದಿದೆ ಅಂತಂದರೆ ಇಟ್ಸ್ ವೆರಿ ಈಸಿ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ that we have to take the highest SRP one as the most oxidizing power containing species. ಹಾಗಾಗಿ ನಾನು ಇದರಲ್ಲಿ ಹೈಯೆಸ್ಟ್ SRP ವ್ಯಾಲ್ಯೂ ಇದರಲ್ಲಿದೆ. ಈ ಎರಡರಲ್ಲಿ ಯಾವತ್ತು ತಗೋಬೇಕು ಅಂತ ಕ್ವೆಶ್ಚನ್ ಬಂದಿದ್ದಾಗ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಯಾವಾಗಲೂ ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಇರೋದನ್ನು ತಗೋಬೇಕು ಆ್ಯಂಡ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಲೋವರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಇರೋದನ್ನು ತಗೋಬೇಕಾಗತ್ತೆ. ದೆನ್ ಐ ವಿಲ್ ಗೆಟ್ Al+3 less than Sn+4 less than Tl+3 less than Pb+4. Let's go to the next part after this. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಿದ್ದಾರೆ. ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ E0 Cu plus 2 Cu E0 Zn plus 2 Zn E0 Ag plus Ag E0 Mg plus 2 Mg. ಈ ನಾಲ್ಕರಲ್ಲಿ ಯಾವುದಕ್ಕೆ ಮೋಸ್ಟ್ ನೆಗೆಟಿವ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಬರುತ್ತೆ? ಯಾವ ಎರಡು ತಗೊಂಡ್ರೆ ಮೋಸ್ಟ್ ನೆಗೆಟಿವ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಬರುತ್ತೆ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಇದು ಸಾಲ್ವ್ ಮಾಡಬೇಕಂದ್ರೆ ಒಂದೇ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ ಎನ್ ಎಫ್ ಇ ನಾಟ್. ಇ ನಾಟ್ ಎಷ್ಟು ಪಾಸಿಟಿವ್ ಆದರೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಅಷ್ಟು ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ. ದೇರ್ ಫಾರ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಆ್ಯಂಡ್ ಇ ನಾಟ್ ಆರ್ ರಿಲೇಟೆಡ್ ದ್ಯಾಟ್ ವೇ. ಇ ನಾಟಿನ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಪಾಸಿಟಿವ್ ಇದ್ದರೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟಿನ ವ್ಯಾಲ್ಯೂ ಅಷ್ಟು ನೆಗೆಟಿವ್ ಬರುತ್ತೆ ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಈಗ ಈ ಟೋಟಲ್ ಫಿನಾಮಿನಲ್ಲಿ ನಾವು ಇನ್ನೊಂದು ಸಲ ಯೋಚನೆ ಮಾಡಬೇಕಾಗಿದೆ ಏನಂದರೆ, ಯಾವ ಎರಡಕ್ಕೂ ಇ ನಾಟ್ ಹೈಯೆಸ್ಟ್ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ ಅಂತ ಅಂದರೆ ಹೈಯೆಸ್ಟ್ಗೂ ಲೋವೆಸ್ಟ್ಗೂ ಮಧ್ಯದಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ. ಅಂದರೆ ಈ ಇದ್ದಿದ್ದರಲ್ಲಿ ಯಾವುದು ಹೈಯೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ, ಇದ್ದಿದ್ದರಲ್ಲಿ ಯಾವುದು ಲೋವೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ತೊಗೊಂಡ್ರೆ ಆ ಎರಡಕ್ಕೂ ನಡು ಬರುವಂತಹ ಡಿಫರೆನ್ಸ್ ಏನಿದೆ ಅದು ಯಾವಾಗಲೂ ಹೈಯೆಸ್ಟ್ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ. ಆವಾಗ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಅಷ್ಟು ನೆಗೆಟಿವ್ ಬರುತ್ತೆ ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಇದ್ದಿದ್ದರಲ್ಲಿ ಹೈಯೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಎ ಜಿದು, ಲೋವೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಮೆಗ್ನೀಷಿಯಮ್ದು. ಹಾಗಾಗಿ ನಾನು ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಎ ಜಿಗೂ ಎಮ್ ಜಿಗೂ ಮಧ್ಯದಲ್ಲಿ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿದ ಗ್ಯಾಲ್ವಾನಿಕ್ ಸೆಲ್ನಲ್ಲಿ ಇ ನಾಟ್ ವ್ಯಾಲ್ಯೂ ಅನ್ನೋದು ಡಿಫರೆನ್ಸ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಬರುತ್ತೆ. ಅಂದರೆ ಇ ನಾಟ್ ಮೋರ್ ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ಇ ನಾಟ್ ಮೋರ್ ಪಾಸಿಟಿವ್ ಆಗಿದೆ ಅಂದರೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಅನ್ನೋದು ಮೋಸ್ಟ್ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಇದು ಕ್ವೆಶ್ಚನ್. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ಇವೆರಡು ಸ್ಟೇಟ್ಮೆಂಟ್ಸು. Statement 1. Corrosion is an electrochemical phenomenon in which pure metal acts as an anode and impure metal as cathode. Statement 2. The rate of corrosion is more in alkaline medium than in acidic medium. ಇದು ಕ್ವೆಶ್ಚನ್. ಈಗ ಈ ಕ್ವೆಶ್ಚನನ್ನು ಯಾವುದು ಕರೆಕ್ಟ್ ಯಾವುದು ತಪ್ಪು ನೋಡಬೇಕು. ಕರೋಷನ್ ಈಸ್ ಅನ್ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಫಿನಾಮಿನನ್. ಹೌದು, ಕರೋಷನ್ನಲ್ಲಿ ಲಾಸ್ ಆ್ಯಂಡ್ ಗೈನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿರುತ್ತೆ. ಲಾಸ್ ಆ್ಯಂಡ್ ಗೈನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎದರಲ್ಲಿರ್ತವೆ? ಅದರಲ್ಲಿ ರಿಡಕ್ಷನ್ ಆಕ್ಸಿಡೇಷನ್ ನಡೆದಿರ್ತವೆ. ಎಲ್ಲಿ ರಿಡಕ್ಷನ್ ಆಕ್ಸಿಡೇಷನ್ ಇರುತ್ತೆ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಫಿನಾಮಿನನ್ ಇದ್ದೇ ಇರುತ್ತೆ. ಇನ್ ವಿಚ್ ಪ್ಯೂರ್ ಮೆಟಲ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಆ್ಯನೋಡ್. ಹೌದು, ಪ್ಯೂರ್ ಮೆಟಲ್ ಲೂಸಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಇಂಪ್ಯೂರಿಟೀಸ್ ಏನಾದರೂ ಇದ್ದರೆ ಅವು ದೇ ಆ್ಯಕ್ಟ್ ಆಸ್ ಕ್ಯಾಥೋಡ್. ಕರೆಕ್ಟ್ ಇದು. ದೇರ್ ಫೋರ್ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಟ್ರೂ. Whereas the second statement, the rate of corrosion is more in alkaline medium than in acidic medium is a false statement. ಇದು ಎದಕ್ಕೆ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಂತಂದರೆ ಫಸ್ಟ್ ಈಗ ಕರೋಷನನ್ನು ಕೆಟಲೈಸ್ ಮಾಡುವ ಸಬ್ಸ್ಟ್ಯಾನ್ಸಸ್ ಯಾವಂತಂದರೆ ಸಾಲ್ಟ್ಸ್ ಮತ್ತು ಆ್ಯಸಿಡ್ಸ್. ಆ್ಯಸಿಡ್ಸ್ ಬೇಗ ಮಾಡ್ತವೆ, ಆಮೇಲೆ ಸಾಲ್ಟ್ಸ್ ಕೂಡ ಮಾಡ್ತವೆ. ಬಟ್ ಆಲ್ಕಲೈನ್ ಮೀಡಿಯಮ್ನಲ್ಲಿ ಕೂಡ ಆಗತ್ತೆ, ಬಟ್ ನಾಟ್ ಆಸ್ ಗುಡ್ ಆಸ್ ಇಟ್ ಹ್ಯಾಪನ್ಸ್ ಇನ್ ಎಸಿಡಿಕ್ ಮೀಡಿಯಮ್. ಅದಕ್ಕಾಗಿ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನೋದು ಫಾಲ್ಸ್ ಆಗುತ್ತೆ, ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್. Another question. ಈ ಕ್ವೆಶ್ಚನಲ್ಲಿ a solution of aluminum chloride is electrolyzed for 30 minutes. Using current of 2 amperes and the amount of aluminum deposited is how much? It's a quite understanding thing that we have to apply the first law for solving this question. W equals E by 96,500 into I into T, where E for aluminum is 9, 96,500 into current is 2 amperes, time is 30, but in seconds it has to be substituted as 30 into 60. ಇದು ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ 1/96,500 ಅನ್ನು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. 1.04 ಇಂಟು 10 ಪವರ್ -5 ಅಂತ ಬರೀತೀವಿ. ಅದು ನೆನಪಿದೆ ಅನ್ಕೋ, ಇಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋದು ಈಸಿ ಆಗುತ್ತೆ. ಸೊ 9 2s are 18, 3 6 are 18, 9 2s are 18, 3 6 are 18, 18 18s are 324 into 10 power 2 in the numerator. ಅಷ್ಟೇ ಅಲ್ಲದೆ ಇನ್ನು 1.04 ಕೂಡ ಬಂದಿದೆ ಇಂಟು 10 to the power -5 ಅಂದರೆ 10 power 2, 10 power -5, 10 power -3. 1.04 1 ಅನ್ಕೋ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ. ಆವಾಗ 324 ಇಂಟು 10 to the power -3 ಗ್ರಾಮ್ ಅಂದರೆ 0.324 ಗ್ರಾಮ್ ಆಗುತ್ತೆ. ಇದು ಆನ್ಸರ್. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. weight of the substance equals E by 96,500 into I into T ಅನ್ನುವ ಫಾರ್ಮುಲಾದಲ್ಲಿ 9 divided by 96,500 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಇಂಟು 2 ಇಂಟು 30/60 ಹಾಕಬೇಕು. 30 ಇಂಟು 60. ಇಲ್ಲಿ 96,500ಗೆ ರೆಸಿಪ್ರೋಕಲ್ 1.04 ಇಂಟು 10 ಪವರ್ -5. ಅದನ್ನು ನೀವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಮಲ್ಟಿಪ್ಲೈ ಕೂಡ ಮಾಡಿ ಹಾಕಬಹುದು ಆನ್ಸರ್, ಬಟ್ ಜಸ್ಟ್ ಕ್ಲೋಸೆಸ್ಟ್ ಆನ್ಸರ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಈ ಕ್ವೆಶ್ಚನಲ್ಲಿ ವಿಚ್ ಆಫ್ ದ ಫಾಲೋವಿಂಗ್ ಇಸ್ ಅ ಕರೆಕ್ಟ್ ಈಕ್ವೇಷನ್? Which of the following is a correct equation to show change in molar conductivity with respect to concentration? With respect to concentration of a weak electrolyte. Another question, and then they gave different equations. ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಗೆ ಇದು ಈಕ್ವೇಷನ್ ಬರಬೇಕು ಅಂತಂದರೆ ನಾವೇನು ಮಾಡಬೇಕು? ವಿ ಹ್ಯಾವ್ ಟು ಡಿಪೆಂಡ್ ಆನ್ ಕೋಲ್ರಾಶ್ಸ್ ಲಾ. ಅಕಾರ್ಡಿಂಗ್ ಟು ಕೋಲ್ರಾಶ್ಸ್ ಲಾ, ಆಲ್ಫಾ ಈಕ್ವಲ್ಸ್ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಆ್ಯಂಡ್ ಕೆ ಎ ಈಕ್ವಲ್ಸ್ ಸಿ ಆಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಆರ್ ಕೆ ಈಕ್ವಲ್ಸ್ ಸಿ ಆಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಬೈ 1 minus alpha. Therefore, k equals c into lambda square m by lambda naught m square divided by 1 minus lambda m divided by lambda naught m. Then k equals c lambda square m divided by lambda naught m whole square whole divided by lambda naught m minus lambda m divided by lambda naught m. It is an LCM taken there and subtracted. Therefore, lambda naught m square gets cancelled. C lambda square m divided by lambda naught m into lambda naught m minus lambda naught lambda m ಅಂದರೆ 2 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ವಿ. And then what I get is C lambda square m divided by lambda naught m square minus lambda m into lambda naught m with k. Then what we do is we have to carry it to the other side. Then k into lambda naught m square minus k into lambda m lambda naught m minus c lambda square m equals 0. ಇದು ಈಕ್ವೇಷನ್. ನಾನೇನು ಮಾಡಿದ್ದೀನಿ, ಇದನ್ನು ಈ ಕಡೆ ತಂದು ಇದು ಈ ಕಡೆ ತಂದು ಬಿಟ್ಟಿದ್ದೀನಿ, ಆವಾಗ ಆ ಈಕ್ವೇಷನ್ ಬರುತ್ತೆ. ಇದು ಫೈನಲ್ ಈಕ್ವೇಷನ್. ನಮಗೆ ಆಲ್ಮೋಸ್ಟ್ ಇಲ್ಲಿವರೆಗೂ ಗೊತ್ತಿದ್ದ ವಿಷಯನೇ, ನಾನು ಇದನ್ನು ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದ್ದೀನಿ ಅಷ್ಟೇ. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಆಲ್ಫಾ ಇಸ್ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಕೋಲ್ರಾಸ್ ಲಾ. ಕೆ ಈಕ್ವಲ್ ಸಿ ಆಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಬೈ 1 ಮೈನಸ್ ಆಲ್ಫಾ. ಈ ಆಲ್ಫಾ ತಂದು ಇದರಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. ಮಾಡಿದ್ದಾಗ ಸ್ಕ್ವೇರ್ ಎಮ್ ಬೈ ನಾಟ್ ಸ್ಕ್ವೇರ್ ಎಮ್ ಬಂದಿದೆ, ಡಿವೈಡೆಡ್ ಬೈ 1 ಮೈನಸ್ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಬಂದಿದೆ. ನಾನು ಈ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಅಲ್ಲಿ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಅಲ್ಲಿ ಬರೆದು ಡಿವೈಡೆಡ್ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಅನ್ನು ಇಲ್ಲಿ ಬರೆದಿದ್ದೀನಿ. ಬರೆದಿದ ಮೇಲೆ ಸಿ ಲ್ಯಾಂಬ್ಡಾ ಸ್ಕ್ವೇರ್ ಎಮ್ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಸ್ಕ್ವೇರ್ ಬಂದಿದೆ. ಅದು ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗಿದೆ. ಕ್ಯಾನ್ಸಲ್ ಆಗಿದ ಮೇಲೆ ಈ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಕೆಳಗಡೆ ಇಳಿಸಿ ಎರಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಇಂಟು ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಬಂದಿದೆ. ಸೊ ವಿ ಹ್ಯಾವ್ ಕೆ ಇಂಟು ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ ಕೆ ಇಂಟು ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಇಂಟು ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಮೈನಸ್ ಸಿ ಲ್ಯಾಂಬ್ಡಾ ಸ್ಕ್ವೇರ್. ಅಂದರೆ ಇದು ಆ ಕಡೆ ಕಳಿಸಿದರೆ ಈಕ್ವೇಷನ್ ಬರುತ್ತೆ ನಮಗೆ. ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಆಸ್ ಅನ್ ಈಕ್ವೇಷನ್ ದಟ್ ಕನೆಕ್ಟ್ಸ್ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಆ್ಯಂಡ್ ಸಿ ಫಾರ್ ಅ weak electrolyte. Okay, we shall stop here for today and discuss the rest of the things tomorrow. And tomorrow we'll finish electrochemistry. And on Sunday, like the previous Sunday, you'll have the same kind of schedule, like 8:40 to 11:40. A paper will be sent to you. You solve those questions, keeping the timer. And then after that, from 11:50 or 12 o'clock, the paper explanation starts. And then the rest of the things will follow. That's it. We will solve more questions from electrochemistry tomorrow. See you and thank you.